Hello there. My name is Michael J. Shannon, and I want to welcome you to the Google Certified Associate Cloud Engineer Complete Video course from Pearson. First off, let me tell you a bit about myself. I have almost 30 years of IT, security, and information system experience, as I've worked as an employee, a contractor, and a consultant for companies like MCI, Platinum Technologies, Fujitsu, IBM, State Farm, MindSharp, Skillsoft, O'Reilly, and of course, Pearson. This is a very exciting and special course in several ways. First, it will help you jumpstart your career in many aspects of cloud computing with one of the most popular cloud service providers in the world, Google Cloud Platform. Second, this course is the first step in the process for the professional level GCP certifications like Google Cloud Architect, Data Engineer, Cloud Developer, Network Engineer, and Cloud Security Engineer. In addition, this course will also be an excellent first step in preparing for the CompTIA Cloud Plus or the ISC Squared CSSP certifications if you choose to pursue them. And last but not least, once you complete this course, you'll be better empowered to decide if you want to dedicate or transition into a career in cloud computing, which is considered one of the top IT fields for 2019 and beyond into the next decade. I'm very excited to get started on this journey. But first, let's see what we're going to cover in the first module. Module 1, which has 3 lessons, is titled Introducing Google Cloud Computing. In Lesson 1, we'll get familiar with virtualization technologies, which is obviously at the heart of cloud computing. The cloud service types and deployment models are covered in Lesson 2. And finally, we'll conclude with an introduction to GCP core services like computing, hosting, storage, networking, database, and big data, finishing up with machine learning services. Module 2, which also has 3 lessons, is entitled Setting Up a Cloud Solution Environment. In Lesson 4 of this module, we'll look at setting up cloud projects and accounts, among other important early lifecycle tasks and best practices. Lesson 5 will explore important billing concepts and practices, and Lesson 6 involves installing and configuring the command line interface through the Cloud SDK download. Module 3 is called Planning and Configuring a Cloud Solution. It only has one lesson, Lesson 7. But it's almost an entire hour of training focused on planning the deployment of compute, database, and storage solutions. Module 4 has 4 lessons, and it's really the core learning content of this course. I will present over 22 live demonstrations with well over 2 hours of hands-on labs. This module covers all of the exam objectives for configuring compute, database, and storage services, as well as networking and other services like Google Cloud Launcher. The final module, Module 5, is titled Ensuring Successful Operation of a Cloud Solution. The 3 lessons in this module cover monitoring and logging, primarily with Stackdriver, and then the critical Identity and Access Management IAM service, with both predefined and custom roles configured in both the console and Google Cloud Shell. Module 1, Introducing Google Cloud Computing. In the first lesson, we'll get familiar with virtualization technologies, the core architecture of cloud computing. The cloud service types and deployment models are covered in Lesson 2, and Lesson 3 offers an introduction to the Google Cloud Platform core services like computing, hosting, storage, networking, database, and big data, finishing up with machine learning services. Lesson 1, Getting Familiar with Virtualization. In this lesson, we'll look at virtualization defined, Type 1 hypervisors, and Type 2 hypervisors. Okay, in these first couple of sub-lessons of Lesson 1, we're going to cover some fundamental concepts like virtualization, virtual machines. We're going to talk about types of clouds and categories of clouds. Now, if you're already familiar with this, you actually could go ahead and skip to sub-lesson 3 if you want to, where you can get right into the Google Cloud specifics. But if you're a beginner to cloud and virtualization, this will be good information for you. That's why I put this in here, just in case I have some people that are brand new to this concept. Now, in computing, virtualization represents the process of creating or generating an abstracted version of a device or a resource. Now, these resources are most often things like Windows servers and Linux servers, but they're also storage devices. They can be object storage buckets. Let's say, for example, Amazon Web Services storage, Google storage, and there can be databases of various types. They could be network components. They can even be different types of operating systems. The underlying framework will separate the resources into one or more execution environments. And it's those underlying frameworks that are those familiar types of virtualization products that we hear out there on a regular basis. So realize that the process of partitioning a hard drive could actually be considered virtualization, right? You're taking one drive and you're taking that drive, you're creating volumes on it, right? So you're kind of creating other virtual drives from a single drive or separate logical drives, okay? Same type of concept. This is not a new thing in the IT industry. Devices, applications, and human users are able to interact with various virtual resources as if it were a single logical resource. Now, when I mention these types of resources, often we think about, a hypervisor, which is that kind of underlying software that generates and controls the virtual infrastructure. That hypervisor allows for running multiple operating systems on a single physical machine. But we virtualize a lot more than just an operating system, okay? So we can have virtual CPUs, we can have virtual memory. Obviously, we're going to have virtual disks for storage. You've got virtual switches or vSwitches, virtual routers. Okay, in this course, we'll actually configure a virtual router in Google Cloud Platform. Virtual firewalls, we'll configure those as well. But we have things like Cisco's ASAV, which is a virtual firewall. In fact, I mentioned Cisco. They have an initiative called Software Defined Networking, or SDN, where the infrastructure is almost entirely virtualized using, virtual Cisco routers, virtual Cisco switches, and virtual images. In fact, we're going to see a little bit later on in this training, in my home office, on my workstation where I'm running VMware Workstation Pro, I'm running a product called Cisco Virl, V-I-R-L, that allows me to run a virtual Cisco network within VMware Workstation Pro. So it's kind of like that. It's called nested virtualization, but it's kind of like that movie Inception with Leonardo DiCaprio, where you have a dream within a dream within a dream. Okay, so we have that going on as well. But just remember, a hypervisor is that main software. The system running the hypervisor is called the host, and the virtual machines running on the host are called guests. Okay, now there's some proprietary hypervisors out there, okay, which means, these are usually going to have licensing involved and maybe some type of annual fees you may have to pay. But these are Hyper-V, that's Microsoft, okay. There's vSphere ESXi. There's Oracle's OVM, okay. OVM is basically what Oracle's public cloud runs on. And then there's Fusion Sphere. So those are proprietary. Some of the open source hypervisors that are out there would be KVM. Google Cloud uses the open source KVM hypervisor. So that's what they use. There's OpenVZ, there's Red Hat, and there's Xen, okay? Every AWS virtual machine is using a Xen hypervisor. So you can see from here, KVM is used by Google Cloud Platform. Xen hypervisor is used by Amazon Web Services. I think Oracle also uses Xen hypervisor. Now, in upcoming lessons, I'm going to talk about this thing called paravirtualization. okay? But let me define it real quickly, okay? In a nutshell, paravirtualization is a technique that offers a software interface to the virtual machines, which is similar but not identical to the actual underlying hardware/software interface. In other words, it's really a set of device drivers, okay? And the main limitation of paravirtualization is the fact that the guest operating system actually has to be tailored specifically to run on top of the virtual machine monitor, okay? And that's the host program that allows a single computer to support multiple identical execution environments. So this is a limitation. And so the big cloud providers and the large virtual data centers, they're not going to use paravirtualization. They're going to take advantage of techniques from Intel and AMD to provide what's called hardware-assisted virtualization. So Intel has what's called Intel V or Intel VT, and AMD has AMD V. So they provide a whole new set of instructions and an entirely new privilege level to allow for this full virtualization, this effective, this efficient, full emulation of the hardware environment. And so that's what we really use today, hardware-assisted virtualization. And if you're going to go out and you're going to purchase a workstation and you're going to run one of those proprietary hypervisors, or even if you're going to run something like VMware Workstation Pro, you want to have a system that has the CPUs that support this technology. With hardware-assisted virtualization, the hypervisor can now run at ring 1. And so the guest operating systems can run in ring 0, so we don't need paravirtualization. The VM machine, the monitor, does less work, and it's also less of a performance hit. In Lesson 1.1, I defined what a hypervisor was, but realized that there are two main types of hypervisors, Type 1 and Type 2. In this sublesson, we're going to look at Type 1 hypervisors. These run directly on the system hardware. They're often referred to as native or bare metal. You'll even hear the term embedded hypervisor in vendor documentation. So the first thing installed is the hypervisor itself. So let me just annotate this. You can see it's installed right there on the physical host, okay? And that could be, a rack-mounted Dell server, or it could be some box, just basically a server device. So the first thing installed is the hypervisor itself, which itself functions as the operating system for the bare metal physical host. The hypervisor software will talk directly to the host hardware, and it actually boots up before the operating system. This is where you really earn your stripes in a private cloud environment, making these key, well-researched decisions. Infrastructure, or IaaS, infrastructure as a service, pretty much is using the cloud environment of Google Cloud to remove all of this overhead. Okay, but remember, you're going to pay for that, right? You're leasing that information. Now, the physical host, which is, typically the rack mount server, is also called the virtualization host. And it's the first step to make sure that your system meets the requirements to serve as a physical host based on the open source or proprietary solution specifications. Now, in the traditional Intel x86 architecture, operating system kernels expect direct CPU access running in ring 0, which is the most privileged and protected level. Well, with software virtualization, guest operating systems can't run in ring 0 because the hypervisor sits there. So the guest operating system must therefore run in ring 1. But there's a catch. Some x86 instructions only work. They only function in ring 0. So the operating systems had to be recompiled to avoid this problem. Now that recompiling is something I mentioned in the previous sublesson. It's paravirtualization, okay? And that is impractical, especially if the source code for the operating system is not available, okay? So to get around this, the hypervisor traps these instructions and it emulates them. And of course, that results in a huge performance hit, okay, making these virtual machines significantly slower than real physical ones. So the solution is for the physical host to support hardware-assisted virtualization, okay? That's what I mentioned in the previous lesson 1.1. So generally speaking, type 1s are the best for high performance, for scalability, and reliability. They have less overhead and they provide better security because you're not adding another operating system on top of the hypervisor. So these are much more common, or maybe even exclusively used by enterprise cloud solutions and, of course, cloud providers like Google Cloud Platform. In the next lesson, we're going to be looking at my home workstation, which, by the way, I could have installed, let's say, KVM or OVM or vSphere directly onto that Dell box. It's very powerful, it's very fast. Or I could go ahead and install some operating system like Windows 10 and then add, let's say, VMware Workstation Pro on top of Windows 10, which is exactly what I did. And so in the next sub-lesson, I'll demonstrate Type 2 hypervisors on that home system. Type 2 hypervisors are loaded on top of an already installed host operating system like Windows Server 2019, Windows 10, or Linux, Ubuntu, or Debian. Common Type 2s would be products like VMware Player or VMware Workstation or Microsoft VM Player or Oracle VirtualBox, just to name a few. Now, unlike Type 1 bare metal, a Type 2 hypervisor depends on the underlying operating system, so they're less scalable and less secure. These are more likely to fit the needs of consumers as they support desktop virtualization as well. In this demo, I'm going to show you my home lab workstation environment, where I use VMware Workstation to run various virtual environments, like client-server operating systems. I'll do Kali Linux with Metasploitable 2 for penetration testing, and I also run the Cisco VIRL, VIRL virtual networking environment. Let me highly suggest that you consider on your own, if you're going to be getting heavily involved in Google Cloud Platform, that you become familiar with virtualization products. That's why I added this to this training, okay? Because it's important to become familiar with the architectures and the concepts and the technology. And you never know. You may be asked to deploy an on-premise cloud or a private cloud sometime in the near future. Now, by the way, when I do these demonstrations, I'm going to switch over from using the lapel microphone to using this Countryman microphone that's going to give me the ability to be more hands-free and to have more freedom of movement with my head. It's also, you're going to have less of the typing as I do typing, less noise from the typing on my keyboard. But also realize that the audio is going to change just a little bit, okay? It just sounds different. So keep that in mind as we go forward in all these demonstrations. In this demonstration, we're going to talk about Type 2 hypervisors. And this is for those of you who have not really gotten into any type of virtualization technology. The Type 2 hypervisor is really a great entryway, an excellent gateway, and you really should have knowledge about virtualization, even though you may never come in contact with the hypervisors that are being used by companies like Google Cloud. It's still an excellent technology to be aware of, and it helps you understand kind of what's going on in this multi-tenant environment using virtualization. So what I'm going to do is I'm going to show you my workstation and talk about some of the ways that I use my Type 2 hypervisor. Now let me just show you my workstation first. My workstation is a Dell Precision Tower 2610. It's a pretty beefy system. It has the kind of processing that you would see, for example, up at Google Cloud or Amazon Web Services. So when you spin up instances, when you spin up VMs, you're going to have choices most likely with processors like this. This is an Intel Xeon. It's an E5-2643, V3, and it's got two processors. So it's a dual processor. Each processor has 6 cores. and each one of those cores can do multi-threading. So just to give you an example, about 4 years ago, each one of these processors would cost you about $1,500, right? So just the CPU of this workstation is a little bit over $3,000. So when you add everything else in, this is about a $4,000 to $5,000 workstation. But think about this, if you were a startup company and you were going to hire 10 developers, and you could go and you could purchase, 10 machines like this, and some really nice dual monitors for them. But if you were to go and buy 10 of these machines, it's going to cost you, I don't know, about $35,000. Or you could take that money and you could pay Google Cloud Platform and use their infrastructure as a service, okay? So this is the host operating system. You can see it's Windows 10 Pro for workstations. So this is the host operating system that's running on this Dell computer with the dual Xeon processors. And then, of course, within this host, I'm running VMware Workstation. Now I'm using VMware Workstation. It's a licensed copy, and I like this particular product. If we go to Help, we can see that About VMware Workstation. Okay, I'll put it up here for you. This is Workstation 15 Pro. You can see the build there. You can see that it's licensed, okay, which is, always good to use licensed technology. Now this system, by the way, only has 8 gigs of RAM. And I'm just about to go purchase some more RAM memory. I'm going to spend about $300 and increase the RAM by 3 times as much. And I really need to do that. And you probably want to do that as well. If you can max out the RAM on your systems, always a good idea. Especially if you're going to run a Type 2 hypervisor like VMware Workstation. Now, VMware also has a VMware Player, which is a free tool. You can also go and get, let's say, Oracle's VirtualBox. You can use Microsoft's VM Player. I prefer this product. I've used VirtualBox quite a bit, but to tell you the truth, I like to run Kali Linux, as you can see here. This is not a demonstration of Kali Linux, but I like to run this, and by the way, the more memory you have, the better, okay? So here's how I use my Type 2 hypervisor environment. One thing that I do is for penetration testing and ethical hacking. I like to use Kali Linux and all the different tools that it has. I'll just show applications here. See the different categories of different types of vulnerability assessment tools, cracking tools, sniffing tools, exploits, forensic tools, password cracking, database vulnerability scanners, that type of thing. But I like to run Kali Linux, and then I can attack the Metasploitable 2. When this comes from the organization that makes Metasploit, okay, which is Rapid7. They have Metasploitable 2, Metasploitable 3, and that's basically a Linux system, an Ubuntu Linux system that has vulnerabilities that you can, practice on. So I kind of use this as a detonation chamber or like a sandbox to work through my penetration testing skills and exercises. You can also use the virtual environment to test out new operating systems. I have an old version of Windows 7 here because I also like to run pen testing and vulnerability assessment against Windows 7. But another great usage of the Type 2 hypervisor is to just test out new operating systems. Get new beta versions of Windows, for example, or new builds of Linux, and then bring them up in your environment and test them out and see if they're going to work with your applications, if they're going to work with your tools, okay? Another reason that I use this environment is I run another environment called VIRAL. And this is Cisco's VIRAL 1.5, which allows me to build kind of a virtualization, or what we call nested virtualization. So I create a nested virtual environment within my VMware virtual environment. And so I can go in here and emulate different types of Cisco topologies. I can test out virtual switches, virtual routers, the adaptive security appliance, the virtual ASAV. And so these are all great reasons to use this virtualization. And it never hurts to kind of, try to understand how to configure these and set them up. So, you go into settings here and you can see the main categories that we have for our settings is basically choosing the amount of memory you're going to allocate to that virtual machine, processors and cores, your hard disk. You can also access your CD drive and DVD drive on the host. You've also got virtual network adapters that have different types of settings, bridged, network address translation to get out to the internet, host only. You can customize it. You can see that this particular viral environment has a lot of network adapters. And of course, going in and configuring other various options. For example, you want to bring up a virtual machine, you're going to mess with it for a while, and you're going to create a snapshot so that you save all those settings, and the next time you bring it back up again, you just bring up that snapshot. Okay, so like if I right click on Kali Linux here, you can see that I've got a snapshot called Kali, right? So I can revert to a particular snapshot I've created. You have multiple snapshots. You could take a snapshot. You got a snapshot manager. So in this demonstration, I really kind of wanted to just give you like a peek. And this is, for those of you who aren't really familiar with virtualization technology, I could, if I want to, this machine that I showed you, this Dell workstation, is powerful enough for me to use as a type 1 hypervisor. So I could go ahead if I wanted to, and I could install vSphere on here, or Oracle OVM, or I could install KVM, which is open source. I could install Citrix Zen hypervisor, directly onto this Dell box, and I could have a type 1 hypervisor environment as well. And one of the good things is that I think, over the last year, because the way that cyber currency has gone, a lot of people have kind of given up on mining Bitcoin or mining Litecoin or mining things like Monero. So you can find a lot of machines, not necessarily this machine, cheap, but you can find other machines that are not nearly as powerful, but are definitely good enough to run even this viral environment, okay? And they're not as expensive as they used to be. So, eBay is a great place to go and find systems that you can use for your Type 2 hypervisor, and you can get them for a pretty fairly good price because of people just giving up on mining cybercurrency. So in this demonstration, I gave you a look at one of my workstation environments and the Type 2 hypervisor solution, VMware Workstation Pro. Lesson 2, Understanding Cloud Computing. In this lesson, we'll look at cloud service types and then cloud deployment types. I wanted to do this lesson early on for those of you who are really brand new to cloud computing, because you may be looking at Google Cloud Platform, looking at this entry-level certification and really wondering, why should I use cloud computing? Okay, why? So let me give you a simple scenario that might help us understand that. Let's say your company is developing a website for high-end luxury real estate and property, and you're selling these to clients all over the world, right? So you have to obviously have pictures of the property, pictures of the real estate and the mansions and whatever. So when you first start out, let's say, you store the image data in a database on site, okay, like we see in this diagram, right? If you're like many novices, you make the classic early mistake of adding, let's say, a binary or a var binary column to your database. Let's say you call it property_photo, and then you just shove any uploaded picture data into that column of your relational database, okay? Well, whenever someone wants to see a photo of one of your luxury listings, well, you're going to retrieve it from the database and return it to your web server, and then the web server will send an HTTP response with that picture, okay? Well, that's a poor implementation for several reasons. Number one, storing binary data in your database is not efficient for this type of data. Transactional data, yes, but not these kind of graphical pictures, okay? The binary data puts an unnecessary load on your database, and that's not really what it's best at, okay? Like joining tables together and creating views and processing transactions. It'd make a lot more sense to do what the graphic on the right is doing, which we'll look at this right here, and that's adding some network attached storage to the web server and let that deliver the pictures to your web app. And you know what? Has been done historically. But what about geography and location with this global website for our luxury property customers? Well, what if somebody in Australia requests a photo from your website, okay, to check out, let's say, some ranch property in southern Colorado? Yes, we have to send the bytes from the US, okay, from this attached server, this attached hard drive, for example, storage, to the web server, and then send it, from the United States all the way down under, okay, to Australia, across, the network infrastructure. But what if your site suddenly has to respond to thousands of requests or millions of requests? What if your company just did a huge advertising campaign? What if you bought airtime, at the Super Bowl or something, okay? So what if your product or your service only has this type of global demand, but on a seasonal basis, right? Let's say in Halloween in the United States through the beginning of the year. So you can see there's challenges when we're storing the photographic information on this attached hard drive and we're serving it from our web server, okay? So what we need a better solution. And that better solution is to use cloud computing. Well, we could scale and optimize our storage setup throughout the world. Okay, we could do that. We could go find data centers and we could have locations all across the globe. Or we could use that relational database for something else, let's say human resources, and then move the website and all the photographic data to the cloud using managed services like Google Cloud Storage to leverage their global infrastructure and their endpoints and their end caching in metropolitan areas all over the world, and take advantage of that, getting that content as close to the customer as possible. We call that content delivery networking. And this is what the big players do. Netflix, Hulu, Spotify, they're getting that content, whatever it is, as close to the customer as possible. Do you get the picture? Okay, so now customers can just use a URL to Google Cloud Storage and they can get that picture of that mansion in southern Colorado from the object storage on the server closest to them. Now, this is just one simple example, but think about how powerful this is for some small company or for some startup company that creates a new killer app or some awesome service or some new product. Okay, so to simplify this from a developer standpoint, cloud is a collection of services that helps developers focus on their project instead of the underlying infrastructure that powers it. Okay, and so that's why cloud computing is so important. And it's not really new. If we go back in time and think about, let's say in the 90s with AOL, America Online, they were in New York and they had a huge cloud of modems that people could dial up in and get onto that new thing called the World Wide Web, okay? So that concept of a cloud just simply means a whole bunch of something, okay? But now we're at a whole new level in cloud computing. So cloud computing is a model that allows for expedient, on-demand networked access to a shared pool of configurable computing resources. And these resources include networks, servers, databases, the object storage that I just talked about, okay, and various services that can be rapidly provisioned and released with minimal management work or collaboration or even having to deal at all with the service provider, okay? Now, the first type of this cloud computing is what we call IaaS, Infrastructure as a Service. Now, the diagram I'm showing you here is actually from Amazon Web Services. The reason why I'm showing you this is for two reasons. Number one, this is the best diagram available to explain IaaS. But also, secondly, Amazon Web Services is the biggest. It's almost 4 times bigger than Google Cloud Platform, and many people who use Google also use Amazon Web Services and vice versa. So the larger the organization, the more likely it is that they'll use both. We can also kind of compare. So what I would want to focus on here is the stuff that's down there in orange, okay? It's kind of the infrastructure. So at the very bottom, we have regions, okay? And all the major providers have regions, okay? These are locations all across the planet. And then within those regions, they have zones, okay? They're called failover zones. They're called zones at Google. They're called availability zones at Amazon. Same thing, okay? These are basically one or more data centers that have high-speed connectivity. And then they have, in large metropolitan areas, they have edge locations. So you grab my pen here real quick and just circle those three. So this type of infrastructure, the combination of regions, and then within those regions, one or more failover/availability zones, which are one or more data centers, and then edge locations or edge caching, which is very close to the customer in metropolitan areas. All of the big players have this, okay? So that's the underlying infrastructure. Then built on top of that, there's typically 4 main services. We could add 5 for Google, but there's compute services, there's storage services, there's database services, and there's networking services. And these are ones that we'll break down, of course, and we'll learn all about in this course. Now, technically, Google adds one more, and it's a machine learning foundational service. And then we have endpoints. And these are just ways to connect with SSL TLS in a secure way to, over the internet or other connectivity methods to get access to all these different services, okay? So with IaaS, the customer does not manage or control the underlying cloud infrastructure, okay? So everything in orange is done by Google or Amazon. We also have platform as a service. Here, the capability provided to the consumer is to deploy consumer-related or acquired applications onto the cloud infrastructure. So these are created typically using programming languages and libraries and services and tools supported by the cloud provider. So platform as a service is actually more of a gray area, okay? There's different degrees and levels of how much of the service is being managed by the provider and how much of the development you're responsible for. So there's lots of different layers, like a peeling of an onion with platform as a service or PaaS. Still, the customer does not manage or control the underlying cloud infrastructure, but the customer will control the deployed applications and often configuration settings for the application hosting environment. Some very popular platform as a service offerings would be Google Cloud Platform's App Engine, supported with programming languages like .NET, Java, Ruby, Python, Go, JSON, YAML, and others. There's also Amazon Web Services, and their most popular PaaS solutions would be Elastic Beanstalk and Elastic MapReduce. There's Microsoft Azure, there's CA Technology, and IBM Cloud. So these are kind of the big players, okay? You could think of these as Google's biggest competitors. The third main category is software as a service, or SaaS. Here, the capability provided to the customer is to use the service provider's applications running on a cloud infrastructure. The applications are accessible from various client devices, okay, like your mobile phone or a laptop, either through a thin, customary client interface like a web browser, or maybe some proprietary web interface, or even some proprietary API or application programming interface. The consumer of software as a service does not in any way manage or control the underlying infrastructure, okay? They don't even manage the individual application capabilities. There's some exceptions where maybe some user-specific application configuration settings. But for the most part, everything running up there is in the cloud. And this brings to mind some popular companies like Microsoft Office 365, Box, Zoho, Akamai, Salesforce, Workday, Google Drive, NetSuite, Oracle On Demand, a bunch of these. And most of these are going to be falling into these types of categories of what they're providing. CRM, ERP, community services, billing services, tax services, analytics services, and of course, personal storage services like Dropbox, right? Or Google Drive, for example. And you'll even see security services. So when a security company is involved with this, it's typically called a managed security service provider, an MSSP, and often to provide support for access management, identity and access management, it'll be what's called a CASB, a cloud access security broker. We also have other types of things as a service, okay? We have database as a service, DBaaS. We have functions as a service, okay? That would be Google Cloud Functions or AWS Lambda. There's containers as a service, like Kubernetes Engine or AWS ECS. There's business process as a service, BPaaS. Security as a service, as I mentioned, MSSPs. And, unfortunately, malware as a service. Okay, in this lesson, we're going to look at cloud deployment models, cloud deployment types. A deployment model also has to be chosen early on in the process of working in the Google Cloud because you have to determine the residency of data, the residency of your assets and your resources, who owns the actual resource, and especially the shared responsibility. So depending upon the deployment model or the deployment type, the provider, if they're offering managed services, may have more responsibility over identity and access management and security than you do. So it depends upon the model. And this is not unlike traditionally if you would go to a regular service provider and you would fill out, your service level agreements and you determine the demarcation point. Sometimes, you would lease equipment from the provider and you put it in your own edge, in your own server room, your own data center, or you're using the equipment at the service provider. So it's not unlike a traditional agreement where you have to determine the residency, the ownership, the shared responsibility of the logical or the physical asset. And this decision will be significant. It'll have a huge impact on your organization. It'll deal with your costs and your budgets. It'll deal with treatment of risk and risk handling, okay? Whether you accept risk, whether you share risk, those types of things. The allocation of resources, your business strategy, your business goals and objectives, and especially, are you subject to any governance or regulations like GDPR or HIPAA or Sarbanes-Oxley or PCI DSS? So your deployment model is going to tie in very, very closely to the type of organization that you have. The cloud infrastructure is provisioned for exclusive use in a private cloud deployment. And when we say private cloud deployment, this is one where this is not what you would see with Google or Amazon Web Services. This is basically you have the responsibility of creating your own kind of private virtualized cloud data center with multi-tenancy on your own site, okay? So it's private, okay? It's exclusively used by a single organization, but you may have multiple consumers. So at your company, you may have multiple business units or organizational units where you have organizational level agreements that are based on your cloud resources, okay? So a private cloud may be given access to the internet or other networks, or it may not be. It may be totally isolated. It may be totally, what we would say, air-gapped from the internet for security and privacy reasons, okay? A private cloud could be owned, managed, and operated by the organization, but you could also have some third party or combination of third party consulting firm or whatever helping you with your private cloud deployment, okay? When you go on to get certifications, some of the big ones that are out there, like, there's the CompTIA Cloud Plus and ISC Squared. These are vendor neutral certifications. A lot of these cloud certifications are actually going to expect you to understand a lot of deploying a private cloud. So it's kind of like taking the knowledge you would need for CompTIA Server Plus and applying that kind of virtualized and that cloud technology to your own private organization. Okay, so because out there in the job market, it's not just going to be about, we're going to use infrastructure as a service with Amazon or Google or IBM or whoever. Okay, there's so many different variants and different hybrids of this technology and solutions. A private cloud deployment offers the same benefits of a public cloud, but you aren't giving up control. You aren't giving up privacy, and you aren't giving up security. Okay, and again, it may be necessary due to governance or regulations. A private cloud deployment may exist off premises or on premises. So it could be a private cloud, but it's not actually at your site. Okay, it's not on premises. Often the term on-premise cloud is confused with private cloud, but they're not synonymous, okay? They're not synonymous. A private cloud can be located in any number of locations. It's just typically private, not on the internet, often air-gapped from the internet, and under your control, under your own privacy and security mandates, and often totally separate from the public internet and other networks. A community cloud deployment is common in the healthcare industry and the financial industry, okay? This is provision for exclusive use by a specific community of users or consumers that have shared concerns, okay? Like they're sharing lab information from their customers, for example, their clientele of patients. It could be owned, managed, and operated by one or more organizations in the community, okay? Or it could be some combination, even with third parties involved. And again, common examples of these would be healthcare and the financial community. And like private clouds, a community cloud can exist on-premise or it can be off-premise, okay? Now, there are community clouds that can be managed by a cloud provider, okay? For example, Amazon Web Services has an entirely separate thing called GovCloud. G-O-V cloud, okay? So just because it's a community cloud doesn't mean that a service provider like Google is not involved in the process. The one we're most familiar with and what we think about when we look at Google Cloud Platform, GCP, is public cloud deployment, okay? Provision for open use by the general public, okay? It can be owned, managed, and operated by a business like Google or Amazon. It could be academic, it could be a government organization, or some combination of those things. It's very common to use a public cloud service provider like Google Cloud Platform. There's also Amazon Web Services and Microsoft Windows Azure, okay? As everybody is fully aware, Amazon Web Services is pretty much the biggest player. They're 4 to 5 times the size of the next player, which would be Google Cloud Platform, okay? But these are typically the big three when we think about, public cloud deployment. What's most common today, however, because of the complexity of applications and services and DevOps, is a hybrid cloud deployment. It's an infrastructure that composes 2 or more distinct cloud infrastructures, like a combination of private and public, or community and public, okay? They remain unique entities in themselves, okay? A unique hybrid cloud deployment. Or maybe, for example, you're only using the public cloud for analysis, data analysis, maybe to analyze malware, okay? Maybe to just use it as a development sandbox, but you're not using it to use their infrastructure like to run your company on, okay? All of your internal employees are not using the cloud or even software as a service, okay? So it's a hybrid, right? It's just, and this is one of the most common models out there, okay? You're bound together by standardized or proprietary technology, and it's going to enable rapid deployment and portability. And that's why you see things in a hybrid cloud like Kubernetes and Docker's used so often, because of the ability to kind of create this portability of that code, okay, to move it from public to private or from community to private. It's one of the main advantages of that containerized application, okay? So you might also see hybrid cloud in a situation, let's say, for cloud bursting. So let's say you're a retailer, right? And so here come the holidays in the United States, right? Well, what you could do is you could use the hybrid cloud and you could burst up to Google Cloud and use Google Storage from, let's say, mid-October all the way through the beginning of the year. So for the holidays, which in your business is seasonal, right, you can burst up and you can spin up resources dynamically and in a resilient and an elastic way up to a cloud provider, but just when you need to on a seasonal basis, okay? And this is one of those things that companies in the early 2000s at the dot-com boom really wish they had, because there was companies that would go spend, almost $1 million on some advertisement on the Super Bowl and not be able to handle the capacity, okay? They didn't realize how popular their product or service was going to be, and their web services were just overwhelmed and they went out of business. And a lot of companies, that happened because they couldn't burst up to a cloud provider. And so this is why hybrid is such a popular solution. Organizations in a hybrid environment may need to keep certain resources internal and private, okay, because they're mission critical or for regulatory reasons, okay? So they're hybrid because of regulation and privacy, maintaining the secrecy of personal information and health information, okay? Now, software as a solution, and I'm in San Francisco right now, so we think about Salesforce with their big tower. Now they're the biggest tower downtown San Francisco. We think about Salesforce and Workday and Office 365. Remember for the exam that simply using software as a service like Dropbox or Microsoft 365, that doesn't make you a hybrid solution, okay? A hybrid solution really is a combination of public and private, community and private, those types, okay? Keep that in mind. Lesson 3, Introducing Google Cloud Platform Services. First, we'll look at computing and hosting services, then storage services, followed by networking services, big data services, and then finishing up with machine learning services. In this lesson, we want to get an overview of the computing and hosting resources. And let's start out first talking about Google Compute Engine, or GCE as it's commonly called. Realize that Google Compute Engine is a huge system made up of over 40 API resources. So this is basically the underlying foundation of Google Cloud. Now, part of your responsibility is understanding the fundamental choices when you spin up virtual machine instances into, let's say, your virtual private cloud. So first off, you want to know the use case, okay? Are you going to work in a serverless environment with cloud functions? Maybe you're going to use a managed application platform. Maybe you're going to leverage container technologies like Kubernetes to get more flexibility and portability. Maybe you're going to build your own cloud-based infrastructure so you have the most control and the most flexibility. You need to know your billing options and your budgets for any multi-tenancy within your organization. You have to choose those global regions and those zones to deploy your resources in, giving you control over where your data is stored and used, possibly based on regulations or compliance. You have to choose which operating systems you want to use, which builds of Linux, which Microsoft Windows Server operating systems, what development stacks, languages, frameworks, services, and other software technologies that you need. Are you going to create instances from public or private images? What about GCP storage technologies, cloud storage, object storage, or any other third-party storage technologies that you might be using? Are you going to use Google Cloud Launcher? We've got 2 sub-lessons on that to quickly deploy pre-configured software packages. Will you create instance groups to easily manage multiple instances together? With auto-scaling, with an instance group, you can automatically add or remove capacity. We call that elasticity. And What about attaching and detaching disks as necessary? And are you going to use Secure Shell to connect securely, directly to your instances? So again, there's lots of things to choose, lots of decisions to make before you actually get those resources up into the cloud. It involves strategy, planning, information gathering, baselining, and knowing the risk treatment policy for the various assets that are going to reside in the cloud. Let's take an overview using this diagram of GCE, Google Compute Engine. Now at the center of the Compute Engine are the VMIs, the virtual machine images, and these are most commonly launched from the Cloud Console or the command line using the G-Cloud program. Now what's visualized here is actually we've got several VM instances in an instance group. And that's optional, okay? But what that is, it's an auto-scaling system that's capable of elasticity. So we can automatically generate or spin up VMs, or we can destroy them as necessary based on things, for example, like the load, okay? Now, do you need all of these things, let's say for your own small business, to use GCE? Well, no. You could simply have a single VM instance of, let's say, a Windows Server or Linux Ubuntu, and then a disk image that's attached directly to that instance, okay? Or it could be detachable, okay? It could be a disk that you could take away and you can add. Now, it's better to create and manage disks separately from the VMs, even though you can have them created with the VMs, because the ability to attach or detach them gives you much more flexibility, okay? You can even detach and attach while they're running, okay? Now those are what we call persistent disks. And a persistent disk can be in one of three states. It can be unattached, which means you spun up this virtual disk, but it hasn't been mounted to any VM, let's say like Linux Ubuntu. Or it can be attached in read-only mode, or it can be attached in read-write mode. Realize if this persistent disk is in read-only mode, it can be attached to many different VMs, but the read-write disk can only be attached or detached to the original VM exclusively. Also notice in this diagram that the disk is in a subnetwork in a zone, okay? And so we'll talk more about that when we get to the networking area. One other thing here, notice that this is all being accessed at the top through a load balancer. That'll typically be the IPv4 or IPv6 point of presence into our instances. We also have instance templates. Those can be used to automate and have basically configuration as code to create reusable instances. We also have disk snapshots. Those disk snapshots at the bottom, those are going to be stored in object Google Cloud Storage. We also have disk images and, of course, continually health checking our VM instances from a variety of services. Here's an example of the Google Web Hosting options. So let's say you want to host a website, okay? Well, there's really four main options in Google. There's the static website. There are using virtual machines, okay? There are containers, and then there's using the managed service. So for example, for a static website, you might use Google Cloud Storage or Firebase hosting. If you're going to run the website, let's say your Apache website or IIS, you can run them on virtual machines using GCE. If they're going to be in containers, they'll be done in Google Kubernetes engine. Or it could be a managed service where you're letting Google kind of provide most of the service, and that would be using App Engine. You could even use one of their partners, right? There's many, many things in their marketplace you can choose to do that are their managed services. You also have lots of storage options. So for example, if you're doing a static website, you would use cloud storage buckets. But if it's virtual machines, you have a lot of options for how you're going to store that data. Okay, you could use the Cloud SQL Admin API, you could use the Bigtable API, you could even use an external provider, okay? With containers, you have a lot of the same options as Google Compute Engine, but it is going to be a different interaction with persistent disks. Okay, and then a managed service, the storage is managed by Google. Okay, so that's really more of what we call platform as a service. As far as load balancing goes, a static website in a storage bucket doesn't have any load balancing, but if you're using Google GCE, then you're going to have lots of options for load balancing, okay? And with containers, you can do what we call application HTTP, HTTPS load balancing. And again, if it's a managed service, Google will manage the load balancing. And then we've also got scalability options that vary between the web hosting option and different logging options. This slide is actually one of the most important things we've seen so far from an exam standpoint. Okay, so understanding this previous slide with this kind of overview of GCE, which by the way will reinforce these concepts as we move through the training, and this web hosting option are both very test relative. I mean, not relative, but they're very relevant to the exam, so keep that in mind. In this lesson, we're going to get a survey of GCP storage options or storage services, and we're going to start with Cloud SQL or Cloud SQL. Why here? Well, because relational databases are among the oldest methods for storing structured data. I remember this technology used to maintain a customer and inventory database way back for this rare coin dealer that I worked at in the early 1980s. So these make great general purpose storage systems with robust and mature query language support. Like all the other cloud providers, like Microsoft and Amazon and others, Google offers a push button choice for spinning up these database services. With Google, it's either MySQL, MySQL, or PostgreSQL. So Cloud SQL is a Google-managed VM hosted on GCE running a version of the MySQL library. It can be managed from the Google Cloud Console, you can manage from the SDK command line tools, or even using a REST API. This is similar, by the way, to the AWS Relational Database Service, or RDS. The MySQL client will connect using SSL TLS. And by the way, when we say SSL TLS, we really mean TLS, okay? TLS 1.1 through 1.3. So the client connects getting a server CA certificate, and then there's a client certificate, and then there's a client private key. What about Cloud Data Store? Document storage is a type of non-relational storage that differs greatly from the relational database you would see in Cloud SQL. So a document database works in terms of collections and documents. So instead of storing data in tables containing rows or records or columns in a rectangular grid, it's technically a document database. So for example, you might have a producers collection with two documents as shown here. So you've got one producer whose name is Michael Shannon with gender male, and a second producer with the name Peter Velati, who's also gender male. Notice we each have our own unique identifier. So this is a set of key value pairs. And this is how this mechanism of Cloud Data Store works and is different from, let's say, a traditional MySQL database. Now keep in mind, even though Cloud Data Store is what we call NoSQL, okay, NoSQL, you can still use the structured query language to actually interact with Cloud Data Store, okay? So NoSQL really should stand for not only SQL. Cloud Data Store originally came from Google Megastore as the default method for storing data in the Google App Engine. The most common use case for Cloud Data Store would be the Gmail mailbox store. And you access this NoSQL service through the Cloud Data Store API. Let's talk more about the comparison of SQL versus NoSQL, okay? SQL are relational databases that are typically offering rich query, strong consistency, and transactional semantics. But they have trouble with large traffic loads. NoSQL databases have a trade-off. They give you better horizontal scalability and better traffic handling for large data sets. NoSQL can choose not to accept SQL commands and are actually more secure for web backends. Next, let's talk about cloud storage. Cloud storage and Amazon Web Services S3 both use the concepts of buckets and objects. And actually, you may use object storage at both of these service providers. Buckets have a globally unique name. So instead of being some type of hierarchical file system, they have a globally unique name that is unique within that project. Objects are the files that you place in buckets, and they have a unique name within that bucket. These are basically named chunks of bytes that you retrieve on demand, okay? So just think of a bucket as a container that stores your data. Maybe think of it as an extremely large disk with 11 nines of durability, okay? And the term durability is important. It's not the same thing as availability. Remember, with availability, that is measuring my access, okay? 4 nines, 5 nines ability to get access to that. Durability means its existence, okay? What's the likelihood of it being destroyed or damaged? Well, with both Google and Amazon, you're going to get what we call 11 nines of durability. So it's almost impossible to actually destroy it when it's being stored in Google's infrastructure, okay? Also, both GCP and AWS use separate access control lists to actually control and limit access to the bucket and the object level. So they have things like owners and readers and writers. Let's talk about storage classes, okay? There are different cloud storage classes for buckets with differing latency and differing availability. So whether it's object storage or it's block storage in files, you typically have some type of, file management, okay, or data management. So the same thing applies here. You have different use cases and different capacity management tiers that will dictate where you store the data and when, okay? So we have multi-regional storage, okay? Most projects begin with multi-regional storage. Later on, when we're into our demonstrations, you'll see that's the default option, and it's optimized for geo-redundancy, okay? Redundancy across regions, if possible, and low end user latency, okay? That's very important. The next one is regional storage. Regional storage is used when your project needs higher performance local access to computing resources. For example, high frequency analytic workloads, okay? Nearline storage is fast and highly durable storage, but it's for data that's accessed less than once a month. And then we have cold line. It's also fast, it's also highly durable, but it's for archived data that's accessed less than once a year. Now, remember that when we say nearline storage is less than once a month and cold line is less than once a year, they're not going to say you can only access your data once a month. But if you try to access it and retrieve data more often, then they'll charge you for it. So it's just like when you open up that first savings account and you put in your $100 and they told you you get 3 free withdrawals, but after that, we're going to charge you a fee. Same concept here, okay? Let's talk about object storage, generally speaking, at a cloud service provider. Typically, this is virtually unlimited file storage. There's 3 main components to an object: the data or the content object, like a graphic file or a video file or an audio file, okay? Then a unique identifier, and then additional metadata or data about that particular file, okay? And we use the identifier to easily track it, okay? We use the metadata to add additional contextual information, okay? The name, the size, the content type, the security attributes, the URL. The metadata is generally stored as a key value pair, and we can also use the metadata to have different versions of that object. That's another advantage to having object storage is versioning, as opposed to putting files in block storage in a file system. So as you see in the bullet point here, we are able to maintain file revisions if we want to. There's also no hierarchy of relationships, okay? Files in folders and directories and subfolders and the such like that. We also use HTTP and TLS or SSL TLS as our interface to those objects that are stored in buckets. And the files are distributed in different physical nodes, okay? Now, block storage is where you have your files split up and stored in fixed size blocks. And this is good for hosting databases, supporting random read-write operations, keeping the system of files of your running virtual machines. Let me give you a quick example. Let's say you have a PDF file, okay? Let me a text file. We'll go with that. You have a text file that you store in block storage, let's say on some detached device, an SSC drive, right? So you have that text file stored there. But you're also going to store that text file up in object storage, okay, in Google Cloud Storage. If you make a change to the text file that's stored in an SSD drive that's detached, for example, in a file system, it's going to go and it's going to find that block where the change to that paragraph is made, and it's just going to change the zeros and ones in that block, right? But if you need to change the text file up in object storage, you're basically going up and you're replacing the existing object with a new object that is now a new version of that text file, okay? So that's a fundamental difference between block storage and storing in an object storage, right? The capacity of block storage is increased by adding more nodes and is suitable for applications that need high input-output per second, IOPS, for databases and transactional data. If it's data like graphics and pictures and media files and videos and audio files, those are best, and maybe even PDF documents, those are best in object storage. Cloud Spanner, okay, is a storage service from Google Cloud Platform. New SQL, NEW SQL systems that offer rich querying, transactional semantics, strong consistency, and horizontal scalability. Cloud Spanner databases function like SQL databases. They have schemas. You can do join queries with scalable features of NoSQL, but they're next generation. Okay, a spanner can split and even redistribute data over more machines much more quickly and much more efficiently, even in different data centers in different zones. Cloud Spanner uses dynamic resizing and reshuffling of data chunks for better resiliency. The Cloud Spanner service actually used to be available only to Google engineers, but now a Cloud Spanner instance is available to you as a customer, and it's an infrastructural container holding multiple to many databases. It's discrete units of compute power that serve the Spanner data. And to access it, you use the Cloud Spanner API. By the way, we'll explore this service in greater detail in Lesson 9.5, Initializing Data Systems with Cloud Spanner. Cloud Bigtable is a petabyte-scale, fully managed NoSQL database service for large analytical and operational workloads. It's used as the storage engine for large-scale, low-latency applications and throughput-intensive data processing and analytics. It's a fully managed, seamless, document-based data with scaling and replication. It provides consistent sub-10 millisecond latency. Its replication offers higher availability, higher durability, and resilience in the face of zone failures. It's ideal for advertising tech, fintech, financial technology, and the IoT, Internet of Things. It's a storage engine for machine learning applications, and it has easy integration with open source big data tools. We'll do a deeper dive into Cloud Bigtable in sublesson 9.7, Initializing Data Systems with Cloud Bigtable. Okay, in this lesson, we're going to get a survey of the cloud networking services from Google you need to be aware of for the exam. And of course, later on in this training, we'll be actually doing quite a few demonstrations of these services. But just to realize, you must know about Google Virtual Private Cloud, or the VPC network that you can spin up in their infrastructure. There's also Google Cloud Load Balancing, and there's several types of load balancing, specifically network load balancing and then application load balancing, or HTTP/HTTPS. There's Google Cloud DNS for domain name service, and there's hybrid cloud connectivity, okay? Different ways to connect. Now, one thing you're noticing is not on this list, which is VPN services. Okay, that will be included as well, but technically that's more of a security thing. But there are different ways to connect and flexible ways to connect that can actually bypass the internet, for example. So you can do cloud interconnect, okay? VPN, of course, we know that that's a very popular method, but there's also carrier peering or direct peering. So this is the main terminology to be aware of for the exam. And there's also what's called Google Cloud CDN, which is their content delivery networking, okay? And so that's how companies, let's say like a Netflix, would get their content as close as possible to the customer. Let's look first at Google Virtual Private Cloud. The VPC network is a complete set of Google-managed networking mechanisms, okay? That includes granular IP address ranges. They can be private address ranges. They can be publicly addressable ranges. They can be routes, static route or BGP routing, firewalls, VPNs, and the logical Google Cloud Router. You can deploy GCP resources. You can link them together using Google's global network, or you could choose to isolate them from each other. You also have the ability with VPC to define fine-grained networking policies for your specific solution. Google Cloud Load Balancing lets you scale your applications on Compute Engine without any pre-warming, okay? Without any kind of pre-setup. In other words, you go from 0 to full throttle within a matter of seconds. You can distribute your load balance compute resources in single regions or multiple regions. You can get them near your users to meet high availability needs. Cloud load balancing comes in a wide variety of flavors, or several different flavors, and it integrates very closely with CDN, Cloud CDN, for optimal application and content delivery. Cloud load balancing can place resources behind any single Anycast IP. Remember, that's IP version 6, and it can scale your resources up or down using intelligent auto-scaling. Next, we have Google Cloud DNS. This is a managed service. It's a reliable, authoritative DNS service running on the same infrastructure as Google. Cloud DNS translates requests for domain names into IPv4 and IPv6 addresses. Those addresses most likely are going to point to a load balancer. Cloud DNS has low latency, it has high availability, and it's cost-effective. Cloud DNS is also programmable, so you can quickly publish and manage millions of DNS zones and records. Google also offers hybrid cloud connectivity. For example, Cloud Interconnect offers an enterprise-grade connection to your GCP VPC, or Virtual Private Cloud, that's backed by industry-leading service-level agreements. Cloud VPN lets you connect your on-premise or other public cloud networks to GCP VPC securely over the internet through an IPsec Cloud VPN. And one of the advantages over Amazon Web Services is you can use IKE version 1 or IKE version 2. Or you can connect directly to Google and bypass the internet altogether using direct peering, or you can choose one of their partners and do carrier peering partnerships. In other words, the direct peering only offers certain services. If you need more granular access or you need more managed services, Google has a ton of partners like AT&T or Verizon that you can work with. In the intro, I mentioned Cloud CDN. Cloud CDN leverages Google's globally distributed edge caches to accelerate content delivery for websites and applications served out of Google Compute Engine. Cloud CDN lowers network latency. It offloads origins and it reduces serving costs substantially. It's similar to Amazon Web Services' CloudFront service. In this lesson, I want to introduce the big data services you have to be aware of on this exam. Now, also realize that coming up later on in this training, we actually have demonstrations of all of these different services. So this won't be the first time that we talk about these. But on the exam, you need to be aware of Google BigQuery, Google Cloud Data Lab, Google Cloud Data Proc or Data Pros, Google Cloud Data Flow, and Google Cloud PubSub. Let's look at these one at a time. Google Cloud BigQuery is Google's serverless, highly scalable enterprise data warehouse solution. There's no infrastructure for you to handle. Okay, so this is a real platform as a service solution, so you can just focus on your data analysis. There's no need for a database administrator. Okay, you can create a logical data warehouse over managed columnar storage and data from object storage and spreadsheets. It also has built-in machine learning, and you can access this through the Cloud SDK with the BQ command tool. Cloud Data Lab is an interactive tool developed to explore, analyze, transform, and visualize data. It also builds machine learning models. Data Lab runs on GCE, and it links cloud services together for data science projects. It's built on Jupyter, which has a robust development ecosystem. Next, we have Google Cloud Data Proc or Data Pros. It's a fully managed and easy-to-use cloud service for running Apache Spark and Apache Hadoop clusters. Operations can be accomplished in seconds or minutes with pay-as-you-go per second billing. And it seamlessly integrates with other GCP services, providing a fast, powerful platform for data processing, analytics, and machine learning. Google Cloud Data Flow is a fully managed service for transforming and processing real-time data streams and historical batches. It uses a serverless approach with virtually unlimited capacity for clickstream, point of sale, and segmentation analysis in retail. It helps you perform fraud detection in financial services. Data Flow provides personalized gaming experiences and IoT analytics in manufacturing, healthcare, and logistics. And then finally, there's Google Cloud PubSub. PubSub is a simple, reliable, scalable foundation for stream analytics and event-driven computing systems. It ingests streams and then sends them to Dataflow for processing, or it sends them to BigQuery for analysis as data warehousing solutions. For example, real-time personalization in gaming, fast reporting, targeting, and processing, and syndicating market-related data streams for financial services. In this lesson, we're going to look at cloud machine learning, which is actually for Google Cloud what they consider one of their core services. Okay, early on we saw there were really 4 core services for someone like Amazon, but Google adds machine learning to that. Now, one of the fundamental aspects of machine learning, modern machine learning, is what we call a neural network. Okay, so in a neural network, nodes are organized into layers, where the first layer accepts the input values and the last layer will produce the outputs. Okay, well, what would be a good example of that? Well, a classic example is speech recognition programs that continually learn different dialects and different speech patterns, right? So those different dialects, those different speech patterns, right, depending upon, what area of India that you're in or what area of the United States that you're in, those patterns can be learned as input, and then the output can be the common language, okay? Neural networks are what do the heavy lifting of both learning and predicting using what's called a directed graph with numerous nodes. Transformations are much like the game of telephone, okay? So the transformational process that machine learning goes through is like that game where you had 10 kids in a circle, okay? And the first kid whispered into the ear and said, "The cat is scared." And then by the time it got to the 10th kid, it ended up being "the buck stops here." Okay, how does that happen? Okay, well, that's that same type of transformation process. Here, however, with machine learning, what we're looking for is maximum accuracy and a learning process. Now, let me recommend a Kindle book for you, okay? It's called Machine Learning for Absolute Beginners, and the author is Oliver Theobald. He uses a great pizza delivery scenario to help explain the usefulness of machine learning. He also puts machine learning in a fundamental context of overall data science, how it relates to artificial intelligence, how it's used in data mining and other disciplines, okay? So realize that these concepts of machine learning, they're not going to be tested on this exam, okay? So just keep that in mind and you can, relax. Cloud machine learning combines powerful cloud machine learning engines with Google Cloud Storage. So it's a flexible architecture that allows easy deployment of computation across a variety of platforms, okay? CPUs, GPUs, and TPUs, and from desktops to clusters of servers all the way to mobile and edge devices. So the machine learning was originally developed by researchers and engineers from the Google Brain team within Google's AI organization. And it comes with strong support for machine learning and deep learning and the flexible numerical computation core that's used across many other scientific domains. Workflows involve training a model and then making predictions using that model. TensorFlow is an open source software library for high-performance numerical computation. And again, like I said, it was originally developed by Google's AI organization. Google AutoML, or Auto Machine Learning, is a suite of machine learning products that allow developers with limited machine learning experience to actually train high-quality models specific to their business use case. It leverages Google's state-of-the-art transfer learning and neural architecture search technology. AutoML Vision lets you train machine learning models to classify your images according to your own defined labels. So this is used with graphics files, for example, like GIFs or JPEGs or PNGs. So you train models from labeled images and then you evaluate their performance. You can leverage a human labeling service for data sets with unlimited or unlabeled images, and then you can register trained models for serving through the AutoML API. And as a matter of fact, we're going to actually look at the results of an AutoML API later on in one of our demonstrations. There's also AutoML Natural Language. This allows for the creation of custom machine learning models to classify English language content into a custom set of categories. These are useful when a predefined category is available from the API and it's too generic and you want to get more specific and applicable to your use case or your knowledge domain. These are useful when the predefined categories that are available from the natural language API are too generic or they're not applicable to your specific use case or to your knowledge domain. You can use the AutoML Natural Language UI to upload your training data, train and test your custom model. And then there's AutoML Translation. AutoML Translation empowers you to create custom translation models so that translation queries return specific results to your domain. AutoML Translation can help you automate your translation jobs in a scalable fashion, allowing you to enter new markets quickly. Imagine if you run a financial reporting service that has an opportunity to expand to new countries. Those markets require that your time-sensitive financial documents are translated in real time. So instead of hiring, a bilingual finance staff or contracting with a specialist translator team, both of which come at a high price, because of their expertise, and you also need a quick turnaround, AutoML Translation can help you automate the translation job in a scalable way, allowing you to enter these markets much more quickly. Module 2, Setting Up a Cloud Solution Environment. Lesson 4 of this module explores setting up cloud projects and accounts, along with other important early lifecycle tasks and best practices. Lesson 5 will explore important billing concepts and practices, and Lesson 6 involves installing and configuring the command line interface through the Cloud SDK download. Lesson 4, Setting Up Cloud Projects and Accounts. We'll begin with introducing projects and accounts, followed by creating projects, then enabling APIs within projects, and finishing up with linking users to G Suite identities. In this brief lesson, we're going to introduce projects and some other structures to be aware of when you first create your account in GCP. Remember that all resources must belong to projects. Projects can map to various components. They could map to your business unit. They could map to an organizational unit. They could map to a department, like the development department, the production department. They could map to different phases of a life cycle. There's lots of ways to have flexible demarcation or separation of different projects. Keep that in mind. Resources that are deployed within one project can communicate with each other without needing a gateway. There are region and zone limitations, however. Resources in one project can talk to resources in another project only through an external network connection. Here you can see a screenshot of that original project info. For example, this was my first project. You can see it has a unique project ID and a project number. You'll need to have a Google registered ID to register to use GCP services. Again, each project has a project name, a project ID, and a project number. The project ID has to be unique across Google Cloud Platform. Google can generate one for you, as seen here. I didn't make up Enduring Byte 230316, or you can make up your own, Even if the project is deleted, the ID can't be reused in the future again. Now, this is my free trial account, which has originally a $300 credit for 12 months. And if I exceed the credit, my services will be turned off, but I won't be charged or billed. I will be contacted by Google to see if I want to continue in the relationship. Here's the organizational hierarchy. Notice that resources are spun up inside of projects. Projects can optionally be put into folders, and folders are actually points of compartmentalization within organizations. So at the lowest level, resources are the fundamental components that make up all the GCP services. So resources would be things like compute engine, virtual machines, cloud pub/sub topics, cloud storage buckets, app engine instances. All these lower level resources can only be parented by projects. So projects represent the first grouping mechanism of the GCP resource hierarchy. GCP resources are organized, as you can see here, hierarchically, starting from the bottom all the way up, okay? All resources, except for organizations, have exactly one parent. The organization is the top of the hierarchy and does not have a parent object. The organization resource is the root node of the GCP resource hierarchy, and all resources that belong to an organization are grouped under the organization node. This is going to provide central visibility and control over every resource that belongs to an organization. An organization resource consists of the following: an organization ID, a display name, a creation time and last modified time of the organization, and the owner of the organization. Folders are an additional grouping mechanism on top of projects, as you can see here. For example, I have the project development and the project production. And then, of course, those are going to be linked to resources. But I have some folders here. Notice that they're under the organization node. So I have OUA, Organizational Unit A, which has two subfolders, Team X and Team Y. Then I have the Business Unit B folder, which has a subfolder, Team Z. Notice that under the Team Y folder, I have a Product 1 folder, and within that folder I've got two projects, Project Dev and Project Prod. The organization at the top is created using the Resource Manager API. An organization ID is a unique identifier for an organization. The owner is specified when creating the organization resource. It cannot be changed once it's set, and it's basically the G Suite customer ID that is specified in the directory API. So to wrap up, the GCP resource hierarchy for most organizations includes an organization resource and folders, and it allows companies to map their organization into GCP and provides logical attach points for access management policies, specifically Cloud IAM and organizational policies. Both IAM and organizational policies are inherited through the hierarchy, and the effective policy at each node of this hierarchy is the result of policies directly applied at the node and policies inherited from its ancestor or its parent. As you learned in the previous lesson, a GCP project is the fundamental organizing entity for your Google Cloud resources, such as a pool of virtual machines, a set of databases, and a network that connects them all together. Projects also contain settings and permissions, which specify security rules and who has access to what resources. Projects are the outermost container and are used to group resources that share the same trust boundary. Projects also serve as a collector of billing and quota details that track your resource consumption. In addition, projects contain networks, which contain subnetworks, firewall rules, and routes. In this demonstration, we'll get started creating projects and talking about the basics for those of you who are brand new to Google Cloud Platform. Now, again, before I start, I want to let you know that going forward, I'll perform these demonstrations switching over to my Countryman headset microphone, the one I used in lesson 1.3, in fact, so it's going to sound a little bit different. Well, now that you've learned about projects and accounts in Google Cloud Platform, at least from a basic point of view, let's go ahead and take a look at signing up for Google Cloud Platform. Now, if you already have an account and you're doing some of your own projects already at GCP, you can pretty much just bypass this demonstration and move on to the next lesson. But for those of us who are just getting started, if you go up to cloud.google.com/GCP/getting started, you're going to see this page, which is going to have quick starts, the Cloud Minute, and some sample projects. If you click on Try Free, they're going to ask you to use an existing Google account. So for example, as you can see, I've got a Gmail account here. You can use that to log in, but you'll have to sign up specifically for this cloud account. So I'll put in my password here and click on Next. So they're telling me to get started with the Google Cloud Platform, and I get an account for free. I'm going to get a $300 credit. So if I sign up, I get $300 to spend on Google Cloud for the next 12 months. And after the free trial ends, there is no auto charge. So they're going to ask me for a credit card for a couple of reasons. One, to make sure I'm not a robot. But secondly, if I do incur charges, they have a way, of course, to bill me and get compensated for whatever I do at GCP. So I'm in the United States here. If you're not, choose the country that you're in, right? Probably want to go read the terms of service. Okay, wouldn't be a bad idea. So I'm going to click on that and agree and continue. And once know my account type, okay, so you can say business or individual. I'm going to choose individual. And I'm going to go ahead and fill in this information. I'm not going to do this on camera, obviously, for privacy reasons. But let me go fill this out. And then, of course, down here, I'm going to put in my, how am I going to pay, automatic payments, and put in my credit or debit card down here, and then start my free trial. So let me go fill this in, and we'll catch up on the other side of this. Okay, I've signed up, Michael James, and I've got my $300 in free trial credit to spend. And again, if I run out of credit, don't worry, they're not going to bill me without my permission. So, after you sign up, you get automatically taken to this cloud console. So click on Got It. And you can tour the console. You can see their top products here. You can explore the marketplace, okay? Notice that, by the way, you're kind of automatically in My First Project. So you've already got a My First Project going. And over here on the left-hand side is your navigation menu, which you can click on this upper left-hand 3 bars here, and that pops out your navigation menu. And again, as you scroll down here, you kind of start out with getting started to the home area, and then you can scroll down and see different areas that we're going to be in. As I demonstrate over the course of these courses, we're going to be in these main areas. Now, in the previous sub-lesson, we kind of talked about, the hierarchy and the architecture of projects. So you're already familiar with that. And remember that projects are basically a container for all of the resources that you might create. And you can go in and create an empty project right off the bat here. So if you create a new VM, that VM will be owned by the parent project. And of course, that ownership will carry over into the billing. So any charges that you incur for resources get charged to the project, okay? So that's an excellent way to have that kind of chargeback model for, a company. If you're using Google Cloud Platform, each department, each business unit, each organizational unit can have their own project or projects, and that way you can, charge back and you can show back and bill them accordingly, okay, on a department by department basis. You can have somebody responsible in each department for the billing. And also, projects give us a way to isolate objects and isolate services from each other, like having a workspace. Now, probably the next thing you're going to do once you create your account is to go and install the SDK. So you can get the suite of tools on your local workstation that allows you to build software to use Google Cloud. You also can get some tools for managing your production resources. Now, a little bit later on, in lesson 6, 6.1 and 6.2, I'll actually install the SDK on the local workstation, and we'll kind of get started with that tool. So that would probably be the next logical thing you would do, or you can just stay here and work in the Google Cloud Platform console, the graphical user interface. So this is called the Cloud Console, and if you want to go and click on the menu again, you can go right to the compute engine and check out your VM instances. And as you can see here, I can only use compute engine after I enable billing. Okay, and by the way, we'll talk about enabling billing in an upcoming lesson as well. But I wanted to show you this, and I also want to show you that if you're going to want to learn more about using Google Cloud Platform, I want you to be able to do this while spending as little money as possible. So what I might recommend to you is to go and check out Qwiklabs. As a matter of fact, I'm going to be doing quite a bit of my demonstrations in Qwiklabs. And the reason why I'm doing that as opposed to my own account, number one is it's much cheaper to do it in Qwiklabs, okay, than using my own account. Secondly, by doing it in Qwiklabs and doing demonstrations, you can go and use your own Qwiklabs subscription and you can do the exact same demonstrations, okay? So I'll basically give you a walkthrough and you can watch me do it, and then you can come back afterwards and you can do the demonstration yourself, okay? So it's a great way to learn and a great way to pass this exam. So let's go check out Qwiklabs. Okay, so I'm here at qwiklabs.com, and you can simply, first you can sign in with your Gmail account, and it's going to feature some learning. It's got what are called different quests, okay? And there's actually a quest that maps directly to this particular Google Cloud Certified Associate Engineer. So if you go down here, www.qwiklabs.com, and you check out Cloud Architecture, if you click on that one, it's going to tell you this is a fundamental level quest, and the labs have been curated to give hands-on practice with topics and services that appear in the Google Cloud Certified Associate Cloud Engineer. And so I'll actually be doing quite a few of these demonstrations, and I'm going to do some other ones as well, some that are a little bit more advanced that are also on the same topics, okay? But when you enroll, you have a couple of options. It shows me that I've enrolled in this, and basically if I start the lab, it's going to use 1 credit. So you have a couple of options for the billing of this. So let me show you this area right here. You can go and just purchase credits, okay? So for example, I purchased at one time 40 credits, and it cost $37.99. Then I decided, you know what, I'm going to go ahead and do a subscription, an Advantage subscription. So for $55 a month, okay, and you can cancel that at any time, you get unlimited credits, okay? So what I would recommend to you is, in preparing for this exam, is to go ahead and get an Advantage subscription. It's going to cost you $55, and then that gives you 4 weeks to go through and use this training that I'm giving you and the Qwiklabs, and you'll be ready to pass that exam. So this is a highly recommended method for not just passing this exam, but also moving forward with your knowledge of Google Cloud Platform. So let's go back up here to the menu and go back to Home. And we get back to our dashboard. You can see I've got my project name, and every project, as we talked about, has 3 components, okay? A project name, a unique project ID. So when you're creating your project, it needs to be a unique name. So typically it's kind of a mnemonic, combination of words that maybe don't relate to each other, and then some numbers, okay? You'll typically have no problem combining a couple of words together that you can remember, and then some numbers, and it'll be unique, okay? And then a unique project number. And then within that project, you can see your activity. We're at the dashboard now. You can see your activity, and then you can see any resources you have, any traces that you've done. Again, we'll talk about monitoring some areas to get started with, okay? If you're a programmer, you're starting out, you can do some, a Hello World app, or take a VM Quick Start, and we can see our appies and other status and reporting information. There's also some news down here. As I go through my demonstrations, you can use your $300 credit, okay, that you have, and go through the demonstrations with me until you use up your $300, which you may or may not do, and then you can fork out the $55 to get the subscription to Quick Start, and then you could just cancel after the first month, okay? So in this demonstration, we kind of got our feet wet with the console, the GCP console, talked about the Quick Labs, and that'll be all stuff that we're going to reinforce as we go forward in this course. Once you create that first project and you start to get familiar with the Google Console interface, you'll want to explore the library of Appies within GCP that you can launch in your projects. Remember that Google Cloud Platform, as well as Amazon Web Services, is really just thousands and thousands of Appy calls. It's these application programming interfaces that really give us the exciting possibilities in the cloud. Well, as JLP would say, engage. Since we're talking about enabling Appies within your projects, we want to start, of course, here in my first project at the main area. Now, if we scroll down, we can notice a couple things. First of all, there is an Appies area down here where actually you can see any requests you have. You can also click on Go to the Appies Overview, so that's one way to get there. Also on the navigation menu, if you click on that, a couple of areas to be aware of, especially for the exam. We will look at endpoints because endpoints use Cloud Identity and Access Management, Cloud IAM, to control access to your Appy. We can grant access to our Appy at the project level and at the individual endpoint service level. So we could grant access to project members on a per service basis. We could grant permission to a user or a service account to deploy an updated endpoints configuration, or we could grant access to our Appy users so they can enable the Appy in their own Google Cloud Platform project. And we'll get more into roles, which allows us to do that a little bit later in this training. Let's go back to Appies and Services and go to the dashboard. And if I go down, I can see traffic, I can see errors, I can see latency, but I'm going to scroll down here. You can see there's pages and pages of different Appies you could be using in your project or projects. If I determine I want to hide the unused Appies, I'll see that right now I'm using Compute Engine Appy. I've had over 7,000 requests, Cloud Deployment Manager V2 Appy, and the Cloud Runtime Configuration Appy. If I click on the Compute Engine Appy, realize that to use this Appy you may need credentials, so I may have to go ahead and create credentials for certain users besides myself, but I can see here the traffic by response code and any billing information, metrics, quotas, other things like that. Let's go back here and go to the library. This is really the main area that I wanted to focus on because we're talking about, how do we enable Appies? One great place to do this is to go to the Appy library. And you can see over here on the left-hand side, we could filter out by public Appies or private Appies. And then, of course, you want to spend some time looking at different categories of Appies. And you can see down here, there's all types of categories. From analytics to big data to compute to Google Cloud Appies, G Suite Appies, machine learning, monitoring, networking, security, storage, even YouTube Appies. So you can see we have YouTube Data Appy version 3, YouTube Analytics Appy, YouTube Reporting Appy. Under the G Suite, for example, Google Drive, Google Calendar, Gmail, Google Sheets, G Suite Marketplace SDK. So as I scroll down, I can see the different categories of Appies that we have. Now, if you go and you decide to spin up some App Engine instances, for example, or services, well, that's also going to leverage some of these Appies as well. So one of the first things you're going to want to do before you really dive too far into this, and that's why I wanted to show you this early on in the process, you do want to familiarize yourself with the different Appies in the Appy library. And as we move through this training, we'll be going through some exercises and some demonstrations where we're actually going to be not only controlling access to our Appy through IAM, but also using Google Cloud Platform endpoints. And that includes looking at the Cloud Endpoints portal to basically generate a developer portal, which is a website that the users of our Cloud Endpoints Appy can access to explore and test the application programming interface. Now in the next lesson, when I actually get into doing a demonstration of working with Appy calls, I'm going to recommend to you that you go to a Quick Labs, which is going to be Quick Labs number GSP 294. And one of the appies you're going to use is the Fitness appy. So I'll just type in fitness here. In the search area, you can see here's the Fitness appy, a fitness appy for managing users' fitness tracking data. So it gives you an overview. You can see the type. It's in the mobile category. You can go to tutorials and documentation to learn more. You can see the terms of service. And if you want to enable it, you can just click on Enable. And I've now enabled this appy in my first project. And you can obviously see traffic by response code and more documentation. If I go back twice, you can see that now the Fitness appy in Google is enabled. So that's how easy it is to, bring up an appy and use it inside of your project. Now also, I'm going to be talking about a little bit later in this demonstration about some key terms you need to know about appies for the exam. One thing we're going to talk about is JSON, which is a kind of a language you probably need to learn. So for example, if I went to search for cloud storage, there's a cloud storage JSON appy, okay? And so this one's already enabled, okay? So lets you store and retrieve potentially large immutable data objects. So for example, when you do the GSP 294 Quick Labs, you'll actually use this cloud storage REST JSON appy in Cloud Shell to create a bucket and upload content to it. I wanted to show you that. Let me give you some key terms for the exam we need to know when it relates to appies, and this will help us also going forward. We kind of want to be aware of the GCP appy architecture, and the first concept is of a client-server model. Realize the internet is the standard communication channel that appies use to transmit requests and response between the programs. The client-server model is the underlying architecture that web-based appies use to exchange information. And of course, if it's the internet, that involves the HTTP protocol. Appies that use the HTTP protocol use request methods, or HTTP verbs, for transmitting client requests to servers. The most commonly used request methods are GET, POST, PUT, and HEAD. Endpoints are very important. Appies use channels called endpoints, so clients can easily access the resources they need. Endpoints are access points to data or computing resources that are hosted on a server, and they look like an HTTP URI. So the endpoints are actually added to the appy's base URL. For example, http://sample.com stores San Francisco. So you would add the endpoint after that to create a path to a specific resource or a container of resources. Appies that use the HTTP protocol, request methods, and endpoints are referred to as RESTful appies. REST stands for Representational State Transfer, and it's an architectural style that prescribes standards for web-based communication. And then we have JSON. RESTful appies, like the ones at Google Cloud Platform, are going to use either XML or JSON. JSON stands for JavaScript Object Notation. This is a file format for data held in the body of an HTTP request method. JSON has surpassed XML in RESTful appy use, largely because JSON is lightweight, easier to read, and faster to parse. Now, you don't need to know JSON for this exam, but I highly recommend that you learn JSON. It's not very difficult going forward. JSON is used in Google Cloud Platform, and it's used in Amazon Web Services. Next, I want to introduce the concept of authentication and authorization. Authentication refers to the process of determining a client's identity. Authorization refers to the process of determining what permissions an authenticated client has for a set of resources. In other words, authentication identifies who you are, and authorization determines what you can do. There are three types of authorization services that Google appies use. First, we have appy keys. Appy keys are secret tokens that usually come in the form of an encrypted string. OAuth tokens are similar to appy keys in their format, but they're more secure, and they can be linked to user accounts or identities. These tokens are used primarily when appies give a developer the means to access user data. While appy keys give developers access to all of an appy's functionality, OAuth client IDs are all based on scope. Different privileges will be granted to different identities. And then we have service accounts. Service accounts are a special type of Google account that belongs to your application or a virtual machine instead of to an individual end user. Your application assumes the identity of the service account to call Google Appies so that the users aren't directly involved. Application programming interfaces are software programs that give you access to computing resources and data. Companies from many different sectors provide publicly available Appies so that developers can integrate specialized utility, services, or libraries with their own applications and codebase in their projects. In this demonstration, I'm going to return to the Appy library to find and enable the Google Drive Appy. Google Drive is part of G Suite, of course, and this Appy belongs to G Suite's REST HTTP Appies. I'll get the necessary OAuth client credentials for my app to access the Google Drive Appy, and then I'll run the app to retrieve data from my Google Drive. You can perform these same tasks yourself by going to googlequicklabs.com and searching for GSP238. However, I highly recommend that you do lab GSP294 as well on your own first. Again, this demo is based on QuickLabs GSP238. All right, let's go over to the menu over here, the navigation menu, and navigate to Appies and Services, and we'll go to the library. I'm going to search for the Google Drive Appy, and there it is. I don't have to enable it, it's already enabled. Once I verify that it is enabled, I need to generate an OAuth client ID. This will be used to verify the Appy caller's identity. So we'll go back up here to the menu, Appies and Services, and go to Credentials. I'm going to go to Create Credentials button. Here's the three ways I mentioned, right? Appy keys, OAuth client IDs, and service account keys. I'm going to choose Help Me Choose. So, which Appy am I using? I'm going to be using Google Drive Appy. Scroll on down there till I find Google Drive Appy. Where am I calling the Appy from? You can see web browser, Android, iOS. I'm going to do other UI, for example, Windows CLI tool, and it'll be user data. Click on what credentials do I need. I'm going to stick with the default other client 1. I'm creating OAuth 2.0 client IDs. Click on the Create button. Notice the email address is my QuickLabs username. I'm going to call this Sample App and click on Continue. I'm now in step 4, the Download Credentials step. So I'm going to click on Download to download the credential information to my local computer. Save the file. Now it's named client_id.json, but I need to rename it to credentials.json. So I'm going to go ahead and do that in the background, and we'll click on Done. Now I need to create a cloud storage bucket and upload that credentials.json file so it can be used by the Google Drive Appy. So back up to the navigation menu, going to go down to Storage, and then Browser, and then create a bucket. This name has to be unique, so I'm going to say les4_4_demo. So it's lesson 4 for demo. It'll be in the multi-regional default storage class in the United States, cost about 3 cents per gigabit per month. We'll click on Create. Now, once my bucket's created, I'm going to go upload some files. So click on Upload Files. Go find it in my Downloads area, credentials.json. So now I've got that JSON file in my bucket. Let's go to the Cloud Shell. I like to run my Cloud Shell in a new tab, so I'm going to make a directory. It's called gdrive_appy_lab. Let's get into that directory. And going forward, I want to make sure that I'm in this gdrive_appy.lab directory. I need to copy the credentials.json file from my bucket to a working directory. So I'm going to use the gsutil command. followed by the cp command, and then gs:// the bucket name / credentials.json. Oh, I forgot something. .json space dot. Enter. Okay, there we go. So my credentials are now in the right location, and I can now make Google Drive API requests. I'm going to go up here and open up the code editor, up the upper right-hand little pencil icon. I can already see credentials.json in this folder, but I need to create a couple of more files. I'm going to go to File, New File, and I'm going to call this index.js, JavaScript, and then I'm going to paste in some code. And this is why using QuickLabs is so powerful and important, because can you imagine, me having to go through this script of code from scratch? But the bottom line is index.js here contains the authorization methods and functions necessary to store the token in a separate file named token.json. And upon authorization, this file will return a list of files and folders in the Google Drive. I also need to create another file called package.json. Paste this JSON in there, and this JSON file is going to list the packages that the project will depend on. Okay, so this file installs dependencies necessary to make an API request. Need to make sure I've saved these. Okay, I'm going to close out of here. Make sure I'm in the G Drive API lab folder, which I am. I need to run the npm install command, and that's going to install dependencies. This will take a second, so we'll probably pause till it's done. Okay, this is what I want to see, so I'm going to run this command, node dot. Okay, so it's telling me to authorize this app by visiting a URL, so we'll click on that. I need to use this account and then click on allow. I can just use this button to copy it. So enter the code from that page here, so we'll just copy that in there and hit enter. Token stored to token.json, no files found, that's what I want to see. ls, and I'm looking for credentials.json, index.js, most importantly, token.json. All right, let's add files to the Google Drive. Okay, so I'm going to go to https://drive.google.com/drive/my-drive. Use another account, and then I'll put in my password. Okay, from the left-hand menu, we'll click on New Google Docs. We'll call this API Test 1. New Google Docs, and we'll call it API Test 2. Okay, I had to fix API Test 1. I had misspelled that. So I have API Test 1 and API Test 2. Let's go back to the Cloud Shell session. And let's run the following command to view the files in the Google Drive. That'll be node dot. And I'm seeing what I want to see. I see API Test 1 and API Test 2. If I add more files to this drive, I can run the node dot command again, and I'll see the newly added files in the input. All right, so we just linked this user, this client, to a G Suite identity, specifically Google Drive, created a bucket, and then copied files up to that drive in G Suite. Don't forget, when you have time, you want to go and do GSP 238 in QuickLabs and follow all of the things that I just did here to reinforce your learning. You can download this PDF file which talks about expanding G Suite identity services with SAML. Okay, we used OAuth 2, but they've expanded with SAML and OIDC, in other words, OpenID Connect. On the exam, the OAuth 2 would be the method to be aware of, but going forward, this is a great article. You can see here's the URL at learn-more, and you can go download the PDF file and find out more solutions for your organization and find out more about Google Identity Services with other protocols besides OAuth 2.0. Lesson 5, Managing Billing Configuration. We'll start out introducing billing concepts, then create a billing account, and then establish billing budgets, alerts, and exports. In this lesson, we're going to be introduced to billing concepts. And so, once you log in for the first time, you're probably going to use a Gmail account. You're going to go and you're going to select billing. You'll see your billing overview. And as of April of 2019, when you create that account, you're going to get $300 of credits, free credits. Okay, so, and you have those credits for a year. So as you can see on this screenshot, I have $183.04 credit remaining, okay? And I have 350 days remaining. So in a couple of weeks, I used up almost half of what I had. Now, also realize that just because you have credits doesn't mean you get to use all the services, okay? There's certain services that they're gonna definitely bill you for, that they'll make you go farther and set up more billing with them to be able to use this beyond just this basic account. Also, Google is different than, I'll say, Amazon Web Services, okay? Amazon Web Services doesn't give you a credit, right? So they'll start billing you right away, okay? So you give them a credit card, or you have you give them maybe a bank card, a debit card. You can start incurring costs right away. With the Google, if you start incurring costs beyond $300, they're not going to bill you. You're going to go to the next level with them. Okay, so it is quite different between Google and Amazon. With Amazon, you basically have a year to use their what are called their free tier services. Okay, so very different. So please don't think that if you go to use AWS or Microsoft Azure, it's the same type of situation that you have with Google. Google kind of stands on their own, right? So they provide several flexible methods for setting up and managing billing for your resources, because you could be a single person, you could be a small business, a medium-sized enterprise, you could be for profit, you could be a nonprofit, you could be a large corporation. So they have very flexible options. The billing account is basically how users pay for their consumed resources. So that first initial user, which is typically the Gmail account that you're using, that is basically called the billing account. It's similar to what we would call the root account over on Amazon Web Services. And the billing account is associated with a method or methods of payments. And so your access is established by using a Cloud IAM role. And so the initial billing account has a Cloud IAM role, which is very powerful, instead of permissions that's applied to it by default. A project has to be associated with a billing account in order for resources to be deployed in a project. More than one project can be linked to a single billing account, and that's often, the way it is. You could have a single billing account with a bunch of projects, or you could create multiple billing accounts. So for example, at your company, if you have like a different chargeback or a different showback methodology where you have an R&D department and you have, let's say, the marketing group and the sales group, you may have individual billing accounts for each one of those. So they could be charged according to their budget on an individual basis based on your organizational level agreements, your OLAs, right? Or maybe you have, production and development. And those are two different billing accounts, okay? So this philosophy, this kind of approach you take to having a single billing account with a bunch of projects or multiple billing accounts with fewer projects is a strategic or an architectural decision that you really need to make part of your team, your steering committee, before you decide to start, really seriously deploying resources at Google Cloud, okay? So make sure that you have that out of the way. Also, GCP offers two major types of accounts. The kind that I'm using and the kind that most of you will use is called the self-served account, okay? Because we're just a bunch of self-serving, no, I'm just kidding. It's self-served. So it's a small deployment, right? We'll use a debit card or a credit card, or we can set up a bank ACH, okay? So, they can do a direct removal or deposit from your checking account, okay, the ACH. For other organizations, they may want to do an invoiced methodology. Now, this is going to be a much more stringent process, okay? So you're going to go through a lot of hoops to be approved for the invoiced account, okay? So you apply for eligibility, and then once you pass all of the different prerequisites that they have for you, then payments can be made by check, and then they have invoices that are mailed to a particular user at your company, like a comptroller or the CFO or a financial manager or whatever, or the organization itself, okay? So more of a direct corporate invoiced billing process. So realize those are the two main options, and it's not unlike most of the other cloud providers as well. Just realize that direct invoicing option is going to involve a high level of stringent investigation. As far as incurring costs goes, there's really two ways to do that. There's monthly billing, where your costs are charged on a monthly cycle, okay? That's best to use if you're anticipating predictable and consistent costs, okay? The second one is threshold billing, where you're billed when an account accrues a certain amount. So let's say you set the billing threshold to $1,200. And by the way, we're going to see this in upcoming sub-lessons, right? We're not just going to talk about it, we're going to see it. So say you set the billing threshold to $1,200, and when you reach that mark, you get a bill, okay? If the threshold cost is reached within 30 days, then you'll be billed instantly, okay? So they won't wait, right? So those are the two main options. You also have what's called a sub-account. And in Google Cloud Platform, a sub-account really functions kind of like a master billing account, but you can use that cloud billing API to generate these sub-accounts on the fly, okay? And then you can associate them with roles and you can link them to projects. So sub-accounts is a great way to manage if you're going to have, for example, like I said, in your organization, that different type of chargeback methodology where different business units and different departments, or you have your development group and you have the production group or you have the marketing group that you want to have kind of a separate billing for. Sub-accounts is a great way to accomplish that. And these accounts get linked to the master billing account, and then your projects can be linked to the sub-account. So in the diagram here, you can see you have the master billing account, and then you can have sub-account 1 and then sub-account 2. And then within those sub-accounts, you can assign projects. So you can see I've got project W and project X assigned to billing sub-account 1, and I have project Y and project Z that are assigned to sub-account 2, okay? So those are some concepts to be aware of. You will need to know these for the exam, and they're also extremely important in the real world because obviously you want to make sure that you're using a cost-benefit analysis when you're using cloud resources. We just learned that one of the biggest advantages of hosted cloud computing with a cloud provider like Google Cloud is the substantial cost savings and pay-as-you-go pricing. However, even in this model, costs can quickly get out of hand. So let's look at creating a billing account along with other features and recommendations to best control costs. In this demonstration, we're going to talk about billing, which is actually something you'll be tested on the exam. If you remember back to lesson 4.2, when we created our first project, which was called My First Project, you can see it down here. And when we did that, the billing wasn't turned on right away. If you remember, we did that in real time, and I added my credit card information. And when I did that, created my individual account, which only allows me to use a debit or credit card, when I went over to try to create a new VM, billing wasn't turned on yet, okay? After a little while, I can now go to the billing area. So if we go up here to the navigation menu, notice there's a billing right down here. And so these options that we see on this sub-menu of billing are the same things that we're seeing over here on the left-hand side. And here's my billing account overview. Now, Your billing account is also going to be linked to what's called a Google Payments profile. And I can actually go up under, my user up here, and I can look at my profile. As a matter of fact, it'll be under this payment settings area over here on the left-hand side. Because the profile is actually what's used to pay for any cloud resources that I create. Virtual machines, Google storage, other services I might want to consume. There are several things that can, incur costs. And as we know, I've got 300 credits, which is part of the 1-year plan that you have by default. This billing account area, though, is also where we control the access to billing, where we create reports, and we're going to look at that in the next lesson. Okay, we'll talk about some reports and some alerts and budgets, just overall monitoring of the behavior of your GCP account from a financial point of view. Now remember, I have an individual account, so if I say, look at my payment method, I could see that obviously I used a MasterCard here, and I can add a payment method, and it's either a credit or debit card, or I could do an ACH to a bank account. Now, if this was a business account, which mine is not, but with a business account, you actually have more options. So for example, you can do invoicing to your finance department or your accounting department. So you have some more flexible options besides just using a debit card, credit card, or your checking account. Now, as your usage in GCP grows or your business usage grows, you can do exports. Okay, there's billing export over here, and you can edit the settings. This is disabled. I don't really need this, but you could automate exports of billing data to CSV formats or to JSON files, and you can see that you can export these to BigQuery, or you can do a file export, or you can store these in Google Cloud Storage. And if I had been generating anything, I could go to the reports area, and I could also take a look at that. If I go back over here, I want to notice that by default, I've got one billing account administrator, so that's a role that was assigned to me by default. So if I were to click on this drop down, it would have my email account, my Gmail account actually, that is tied to this creation of my first project and this billing account, which is actually a Google payment profile. Now I could add members to your billing account, okay? You can see you can add one or more. Another Gmail account, you could add a Google group. We'll talk about service accounts in greater detail when we get into IAM, okay, Identity and Access Management, but we're definitely going to create some service accounts, and we'll look at that. And that can be done programmatically. It could also be done here through the console. As a matter of fact, there's actually a Google Billing API. So this could be done programmatically or scripted through API calls instead of using this console. So for larger organizations, you can generate a wide variety of billing processes that are application based. You can also add a Google Apps domain, or, and this would not be a good idea, but you could do all users, okay, anybody, all users, or all authenticated users, okay, which we're probably not going to do that, right? And then this is under the permissions area. And of course, you can rename the billing account, or you could close out the billing account, which, by the way, by the time you watch this video, this billing account will be closed out. So any information you're seeing up here of these account numbers, they're not going to be valid because I'm going to close this account out for obvious security reasons. Now, as I mentioned, if it's a business that you're dealing with, you might want to get into invoiced billing accounts. Okay, so you have to request invoiced billing for your organization, and you have to meet Google's eligibility requirements depending upon your business's funding, your size, the structure. It can be a pretty grueling process. You may not qualify. Let's just put it that way. On the other hand, you could decide to work through one of Google's global network of partners. Okay, so for example, companies like Onyx, O-N-I-X, and SADA, SADA Systems. And you can go search for that on your favorite search engine, which is most likely Google. So to wrap up here, some recommendations. Obviously, that first billing account will be created soon after you provide your credit card or debit card information. Make sure that you adjust the permissions adequately and correctly. And there's a wide variety of roles that you can choose from. Okay, these are kind of permission sets. And you can see under each category, like billing, you've got billing account administrator. And by the way, that's what this is by default. So when you create your account, your individual account, by default, your role, the permissions you have, are going to be billing account administrator. But you can see there's other roles like billing account user and billing account viewer. You've also got them that are more selective for different services like Cloud Composer, Dataflow, Dataproc. You can get just error reporting viewer, for example. You can also get different types of logging roles, logging admin, logs viewer, logs writer, different monitoring roles, okay? And if you're going to be dealing with organizations at a higher level, you've also got organization policy roles, and there's a manage roles area down here. We're going to hold off on that because we're going to be diving into identity and access management a little bit deeper later on in this course. But again, just realize that, best practices, make sure that you adjust your billing account permissions accordingly to meet your personal needs or your business needs. You might want to consider, if it's a small to medium size or even larger company, exporting to BigQuery, okay? That can give you some good analysis and visibility. In the next lesson, we're going to look at setting budgets and alerts. And finally, I might want to recommend to you going to the payment method area here and considering adding a secondary or an additional credit card or debit card or have a bank account in case your primary payment method has any problems. All right. Alrighty, let's continue our exploration of billing by establishing billing budgets, billing alerts, and look at some various export operations. All right, I'm at the GCP console, and you can see that I've got, over the course of several days, I've got 3 compute instances, a BigQuery dataset, an instance of SQL. I've also got some CPU utilization, some SQL storage being used. But what I want to look at now, of course, is going up to the menu and go to billing. And you can see of my 300 credits, I've got $173.98 of credit remaining in this project. Well, something has used up those credits, so let's start with the transactions. This is for a 2-week period of February 1st through 16th in 2019. We go down here, we can see I've got some sales tax. I've got a Cloud SQL Database Standard. You can see I got a little discount on that as well. I've got some Cloud SQL storage on SSD in the Americas. I've got a compute engine licensing fee for Windows Server 2012 R2 Data Center Edition. I've also got a predefined instance core running in the Americas, instance RAM running in the Americas, storage, and of course you can see where I've credited my free trial here, okay, over the course of 2 weeks. And of course I can go to, if I have other billing accounts, I could go look at those as well, but I only have one billing account. Let's go look next at budgets and alerts. So we'll click on that area, and it tells us to avoid surprises by creating budgets to monitor all your Google Cloud charges in one place. Realize though, it's going to remind me this: setting a budget does not cap resource or API consumption. So you may want to click on learn more and go read into that. We're not creating any type of limits here. I want to go ahead and name this budget. So I'll call this my first budget. And am I going to do this based on my billing account or on a project by project basis? Of course, I could have multiple projects in this billing account. I've only got one project, so we might as well just stay with the my billing account. We can also set a budget by putting in a specified amount, or we could say, well, what did I spend last month? Well, that's not going to really help me because I only have a couple of weeks, right? So we would say a specified amount, and I could say, I want to set a budget based on, $500. For example, or $1,000, my budget, or maybe $1,200, right? Something like that. It depends on your organization. I also have a checkbox that says cost after credit. This is the total cost, and then you take away any credit that's applied. Okay, so in my case, it would be cost after the $300 credit. And the credit could be usage discounts, it could be promotions, or you could have an educational grant from Google to use Google Cloud Platform. But how do we find out? Okay, well, we need to set budget alerts. You can see based on this amount right here, $1,200, at 50%, the $600 mark, I'm going to get an alert. There's a 90% mark, so at $1,080, and of course at 100 I'll get an alert. If I decide this is too high of a budget, maybe I want to make it 750. If I go change that number, notice it's going to change the percentages down here. Okay, so now I'll get my first alert at $375. So you definitely want to do this, and we're going to be talking later on in this training about best practices, and this is obviously one of those best practices. So when we get there and we talk about, the budgeting best practices, you'll know what we're talking about. Setting up a budget, setting up alerts, and again, we can do these budgets on a project by project basis or for the entire billing account. And then of course down here you could also use the pub/sub, publication subscription feature or engine to programmatically get updates, sent, for example, to your cell phone, for example, a text message. But to do this, you have to connect to an existing pub/sub topic that you have created, and that's for a different topic. So we can check out our transactions, set up our budgets, and create alerts based on those budgets. Then we can also create reports, and we have two options under reports. And we can see here I can view this information either in a graph or a bar chart. Okay, I can also view this information on a monthly basis if I want to, but I don't have enough information yet, enough time. Over on the right hand side you can create filters. You can use the preset filters, which are the current month, the last week, on all the projects or all the products. And I've got several products here. So if you go to products, you can see I've got 3 different products. I've got Cloud SQL, I've got Compute Engine, and Stack Driver Logging. And for me, running on Compute Engine, I've also got Microsoft Server 2012, and that would be under the SKUs area. Okay, you can see licensing fee for Server 2012 Data Center. I've also got some licensing fees for Debian 9, the Bitnami WordPress for the website, okay, that I spun up as well. So you can see, your different SKUs, your different products, different projects. You can group by project or group by product or SKU, and you can also see your time range there. At the bottom we see, of course, my first project. So there's your reports. You can export this information. If you have a BigQuery table set up, you can do that. I actually went ahead of time and created a BigQuery. So when it comes in here, it says, here's a data set. So this is where the billing data is going to be stored. I already went ahead and created my first billing data set. So that's where it would store this information. So I would just save it there, and it'll create a table in that data set. Or I could export this to a file, but to do that, I'd have to have a cloud storage bucket. So I have to specify a cloud storage bucket, specify that. I can save that in a CSV file or in JSON format. And it's highly recommended, again, when we look at our best practices coming up later on, it's highly recommended that we create this export to BigQuery, because there's just so much we can do on that information, okay, as far as big data analysis, and especially for a medium-sized enterprise organization or a large corporation or large organization, it's really mandatory that you export to BigQuery and take advantage of all the features that you get and the capabilities that you get with GCP BigQuery. All right, establishing billing budgets, alerts, and exports. Lesson 6, Installing and Configuring the Command Line Interface. This lesson has 2 sub-lessons, setting up the G-Cloud CLI and then getting started with the G-Cloud CLI. So far in this course, we've used the graphical GCP console and the integrated Cloud Shell. And as a matter of fact, we'll be using the integrated Cloud Shell a lot more throughout this training series. However, most experienced DevOps people will eventually download the Cloud SDK to their own management platform. The Cloud SDK has a rich set of tools and utilities for the cloud. For example, it has the G-Cloud utility, GSUtil for Google Storage, and the BQ, BigQuery command line tools. You can use these to access and manage Compute Engine, cloud storage, and BigQuery. The SDK also includes client libraries for Java, Python, Node.js, Ruby, Go, .NET, and PHP available for installation. There's also Google Cloud Tools for PowerShell as well. In this demo, I'm going to install the Cloud SDK on my home Windows 10 workstation and then set up the Cloud GLI. Now, even if you're not a programmer or a developer, let's say in the DevOps world, you're more ops than you are dev, you're going to want to go ahead and get the Cloud SDK from Google, which is the Cloud Software Development Kit. And again, this is going to give you the command line interface to run programs like gcloud and gsutil, as well as BQ for BigQuery. Now, I'm going to install this on my Windows 10 machine. If you go here, you can see we've got an install for Mac OS, we've got an install for Linux, there's a separate install for Debian and Ubuntu, and a different install for Red Hat and CentOS. And I mentioned in the introduction the advantages of the SDK, but let's go down here. I want to show you a couple of things here. Obviously, you can see all the different areas of the platform that this can be used. Okay, Kubernetes Engine, Cloud DNS, Cloud Dataproc, the list goes on. I want you to look at the Google Cloud Client libraries. This will probably be a test question, okay? So you need to know what's supported on Google Cloud. So this is a list of things to remember for the exam, okay? Go, Java, Node.js, Python, Ruby, PHP, and C#. So make sure you remember that list for the exam. That's the Google Cloud Client library list. So we've got to know that. Also, you're going to want to go and look at the documentation, okay? And this will give you an idea of kind of what we're going to do. And obviously, there's a different set of instructions depending upon what your operating system is that you're going to run this, okay? So I'm going to go ahead and download the Cloud SDK installer. I'll go ahead and do that here in real time, okay? It's going to tell you some other things, though, to keep in mind. It requires Python 2 with the release of Python 2.7.9 or later, and it'll install the necessary dependencies, including the Python version by default. If you already have it, you can just uncheck the Install Bundled Python option. It also says that depending on when you're watching this particular video, this may or may not be even showing up here as a note, but just experimental support for running Python 3.4 plus interpreter. After I finish installing, I'm going to accept to start the Cloud SDK shell, and I'm going to run gcloud init. So in that terminal window, I'll run that command, and that'll give me my kind of initialization. One other thing, on Google Compute Engine instances, if you're going to do this, on an instance in the cloud, for example, you're going to use that as a bastion host or a jump host. If it's running Windows Server, IE is set for enhanced security configuration, and this will prevent you from running the installer. So you have to disable the enhanced security configuration first, restart IE, and then run the installer. Okay, so just keep that in mind. There's also quick start guides, how-to guides, APIs and references, which has the gcloud CLI reference. On the exam, you're not going to be, burdened with having to memorize a bunch of gcloud CLI commands, but we will, in the next lesson, we'll look at some of the basics, some of the fundamentals to make sure that you're covered for the exam. But you're going to want to take some time on your own to dive in and get as familiar as possible with the gcloud commands and the keywords and the switches and gsutil as well. And if you're going to use BigQuery, you'll want to dive into BQ. BQ commands won't be on the exam, though. Now, we may see some of those when we get into some demonstrations later on in this training, but don't get hung up on BQ commands, all right? Now, for best results installing the SDK, my advice is to go create a service account first that you actually are going to log in and get authenticated within that service account. We're going to talk more about service accounts later on, but I wanted to show you this now. I'm going to go and I'm going to create a service account name. I'm in the IAM and admin area. I have to choose my project. So I'm choosing my first project here, and then I'm going to go down to service accounts, and then I'm adding a service account, SDK service, ACCT, And then here's the account ID, and you can see it's an account for the GCP SDK. Click on Create. I now want to select a role, and I'm going to choose Project Owner. I want full access to all resources, and then Continue. I need to create a key because I'll need that key when I use the gcloud init for the first time after I download. So I'm going to click on Create Key. I'm going to download a file that has a private key, and you want to store this file securely because you cannot recover it if it's lost. Also, if it's in the wrong hands and this is an owner, I could be in big trouble, right? So I'm going to stick with the JSON recommended and click on Create. I'm going to save the file and close. So let's go up here and I'll click on Cloud SDK Installer. It knows I want to do Windows, so that's what it's going to give me. And so I'm going to save the file, display the progress of my downloads. It's completed, so I'm going to go to my Downloads folder. Here's the Google Cloud SDK installer. Double click on that. I'm not going to send anonymous stats to Google. That's all I'm going to say about that. Okay, click on Next. I am going to agree. Typically we should read this, but I'm just going to go ahead and agree to that. I'm a single user. I'm the owner, so I'll click on Next. And I'm going to go ahead and stick with the default destination folder. Click on Next. And this is what I mentioned earlier. Obviously, I'm going to get the Cloud SDK core libraries and tools. I don't have Python or that version running on this system. This is a pretty new build on this workstation. So I'm going to go ahead and do the bundled Python. And I don't want to install the cloud tools for PowerShell because I don't need them. But a lot of you out there, if you're going to be working with Windows Server instances or Active Directory environments, obviously you want to make sure you have those tools. I'm just going to take them out and click on Install. I'm going to pause while this installs on my system. Okay, so the Google Cloud SDK has been installed. We'll click on Next. Here's some options. Okay, I do want a Start Menu shortcut. I don't want a desktop shortcut. I do want to start the SDK shell, and I also want to run gcloud init to configure the Cloud SDK, right? So we mentioned that that's going to be the next thing we're going to do, so I'll click on Finish. Okay, so I'm running my command.exe as administrator. I'm going to issue the command gcloud auth, and then activate service command, service account that is, followed by key file, and we'll say equals, and I'll paste it in there. And now we have activated service account credentials for my service account in my project. Let's run gcloud init. It says welcome. We're going to go through the configuration of gcloud. You can see the account, a couple of options, pick configuration to use, reinitialize this configuration at default with new settings, or create a new configuration. I'm going to choose one. I want to choose the account I want to use to perform operations. I'm going to choose one. Scroll down here a bit. Notice that I'm logged in as my service account, the one that I created. I'm going to pick my cloud project, which is one. I don't want to configure a default compute region and zone. I'm going to say no. Clear the screen. And let's do one command here just to make sure that we're working fine. gcloud auth list. And there's that service account that we're using. And by the way, you'll run this same command also often when you're doing some of the labs up at quicklabs.com. But we're now ready to use the SDK, and we're ready to use things like gcloud, gsutil, and BQ, and other things. And we'll take a look at some of those basics and fundamentals in our next lesson. Excellent. In this demo, we want to familiarize ourselves with some common gcloud and gsutil tool commands. Although this is not a heavily tested skill set on the exam, you'll need these skills to go further in your GCP certification path and real-world activities. So let's check it out. Okay, so we're going to be using the CLI, we'll be using the Cloud Shell, we'll be using gcloud, we'll be using gsutil. quite a bit. I'm going to be doing a lot of demos after this, demonstration videos. We'll be seeing a lot of these commands. So let's just kind of get our feet wet here. If we issue a gcloud and we do a -- help, that's really where you want to begin if you're kind of brand new to this, okay? So it tells us that gcloud helps us manage Google Cloud Platform resources and developer workflow. So for example, I'll do a Control-C, get to the top. Let me show you this command, gcloud h. You can see that we can follow up gcloud with optional flags, and we'll talk about those. There's a bunch of flags that are available to us. But notice you can also follow up group, and so the group might be, you know, these are services, right? So app group, Bigtable, Composer, Compute, Data Store, Container, IAM. There's also functions, which is, you know, serverless code, machine learning engine group, PubSub. So you can issue the gcloud command, then a flag, then one of these groups. For example, we could say gcloud compute, and then maybe do a -- help here. It describes what that group is. It shows the cloud-wide flags that you can use. So let's talk about some of those real quick. The account flag, it's the GCP user account that's going to invoke this particular command. Configuration, so what configuration are we going to use to invoke this command? The flags-file, basically a YAML or JSON file that specifies a flag. Format, that's one that's pretty popular. You can set the format for printing command output resources. There's a bunch of supported formats like CSV formatting. There's JSON, there's list, table, text, YAML. Those are all very popular. We've already seen -- help. The project flag is basically the GCP project name that's going to invoke this command. So for example, in my case, it would be my project. Quiet is a flag that disables all the interactive prompts when you're running the gcloud commands. And verbosity is basically overriding the default verbosity for this command with any of the supported standard levels like debug, info, warning, error, critical, and so on. And so we know that groups, there's a ton of groups here. If I hit the tab key, you can see all these different groups that are showing up, okay? A lot of them, okay? And then a lot of different commands. For example, config secure shell, connect to a serial port. We don't really use copy files anymore. Reset the Windows password, the SCP, secure shell. So just a lot of things to look at. So you want to kind of get, you know, familiar with gcloud. And like I said, we'll be using that quite a bit. There's also gsutil. You can do gsutil -- help. Tons of commands here. We're going to be seeing gsutil quite a bit when we do our demonstrations. It's a Python application that lets us access cloud storage from the command line. We can do a bunch of things on buckets, object management tasks. We can create and delete buckets. We can upload, download, delete objects. We can list buckets and objects. We can move, we can copy, we can rename, we can edit. You can see here's the ACL, okay, the access control list, so we can get, set, or change bucket and or object ACLs. CP, copy files and objects, we're going to definitely see that for sure. IAM, getting, setting, or changing bucket or object IAM permissions. And we can scroll down and see, you know, other things we can do here. And here's additional help topics. Now, if you're going to use this command, gsutil uses gs:// to designate the resource in cloud storage. So it would basically be gs://, you know, whatever the bucket name is, and then it would be followed by a // and then whatever the object name is. gsutil help is the main help command that you'll use. And again, you can say help and then follow that up with any of these commands. So if you wanted to see, you know, ACL, you could say gsutil help ACL or ACL, and you could get information about that particular command, okay? So like I said, we're going to see these over and over and over the next dozen lessons or so as I go through different demonstrations. So just make sure that you're familiar, especially with G-Cloud, but also to a lesser extent, understanding how GS-Util is going to help us when we access and manage cloud storage. Okay. Module 3, Planning and Configuring a Cloud Solution. This module consists of just one lesson, Lesson 7, but it's almost an entire hour of training focused on planning the deployment of compute, database, and storage solutions. Lesson 7, Planning and Configuring Compute and Storage. First, we'll plan and estimate best practices. Then, we'll look at estimating with the pricing calculator. We'll look at selecting appropriate compute choices, planning data storage options, and then finish up configuring storage options. This lesson presents the 8 key steps for good planning and best practices for estimating a successful GCP deployment. I suggest on the exam that you memorize the 8 main phases or the 8 main steps. Now, as you see in this diagram here, this is basically our organizational structuring or hierarchy of our resources. And we talked about this in sublesson 4.1, right? Where we have at the very bottom, we have our projects, and our projects have resources that belong to those projects. So for example, GCP project, the second project has 2 resources. It has VMs and storage. And then of course we have optional folders. For example, the dev team folders, team 1 and team 2. And at the top is the organization. Realize that for a large enterprise, you can use the organization setup wizard, which is a graphical utility for your large organization. Now let's get into the 8 steps I want you to memorize. And the first, of course, is plan the hierarchy. And so we understand the need for doing that. The ideal project structure will depend upon your requirements, okay? These may change over time. They may evolve over time. Hopefully you've implemented some continual improvement methodology like ITIL version 4 to make this possible, okay? But when you design your structure, you have to think about, you know, are you going to have a separate billing? Are you going to have unified billing? What degree of isolation do you need? Are you subject to governance or regulations? And then how are your teams going to manage those resources and those folders once you begin to deploy those resources in the cloud? So step 1 is planning the hierarchy. Step 2 is designating the project structure. And again, this ties back to step 1. You're going to control the scope of your projects. A single project may contain multiple apps, may contain multiple separate apps, or equally, it could be a single app, right, that might be involved with several projects. Just depends upon your scenario. Projects can contain resources spread across multiple regions and geographies. And for a large multinational corporation, that will commonly be the case. The ideal project structure, of course, depends upon your individual needs and requirements and your individual business case. So phase 2 or step 2 is designating the project structure. The third step is to automate project creation. And this is especially important in a larger organization because by automating the process, it allows you to better take advantage of best practices, okay, and consistency. So automation offers consistency. It offers reproducibility. It offers a modular approach and testability. Automation is often called configuration as code or infrastructure as code. In other words, using templates and pre-existing modules to duplicate your work and your effort. Automation supports the consistent naming and labeling or tags of resources. And within this training, you'll learn about the value of, for example, tagging a firewall rule, because it can be a complex firewall rule that can be identified by a tag, and you can reuse that tag in a wide variety of different implementations. Automation simplifies project refactoring. Code refactoring is the process of restructuring existing computer code or changing the factoring without changing its external behavior. Refactoring is intended to improve non-functional attributes of your software. For GCP projects, you can use the Cloud Deployment Manager. There's also other tools such as Terraform, Ansible, and Puppet that are quite popular for this automated configuration and deployment. Our fourth step is to implement IAM best practices, okay? And for many organizations, the IAM best practice is going to come down to leveraging your pre-existing directory service. So you can manage your Google identities, and you can synchronize those with your existing identity platform. Yes, you can go in and create an elaborate IAM construct with different users. However, it's for most organizations, you're going to want to leverage and implement some type of single sign-on solution using your existing, let's say, Active Directory, for example, or other identity management service. That's going to be the most scalable solution in the long run. It allows you to resolve any conflicting accounts much easier. It gives you singular and centralized control and access to all the resources instead of having multiple types of access control methodologies. You want to leverage groups and service accounts on an as-needed basis within IAM, specifically using service accounts for the administrative and management purposes. And then use these best practices and use IAM to help you define your organizational policy. Phase 5 is networking and security practices. Use a virtual private cloud to define your network. Control traffic flow with firewall rules. Limit the external access channels. In other words, reduce the attack surface or the blast radius. Centralize your network management, either using integrated tools from Google or maybe some third-party resources from Google's partners. Make sure that you connect your enterprise network properly and that you're giving access in a least privileged manner. Secure all of your apps and your data. Consider all of your data at rest and all of your data in transit. For data in rest, typically it's going to be AES 256. For data in transit, it's typically going to be TLS 1.1, 1.2, or 1.3. But it may also involve secure shell or security services as well, and of course, VPN technologies. Step 6 is logging, monitoring, and operations. Make sure you centralize your logging and your monitoring. Stackdriver is a great tool for that. Set up an audit trail. Make sure you export your logs, for example, to Google Cloud Storage. Leverage DevOps and explore STE, Site Reliability Engineering. 7 is cloud architecture practices. Plan your migration carefully. Remember, there's many different ways to migrate and upgrade a cloud environment. If you can, opt for managed services to help you with this migration or your upgrade whenever feasible. Design for high availability. Plan your disaster recovery strategy. Often, individual organizations will begin their cloud deployment or their transition using Google Cloud as their disaster recovery strategy, and then they'll start moving production activities and other development activities up to the cloud as necessary. And then finally, step 8 is manage your billing and management practices with best practices. Know how your resources are charged in every instance. Configure your billing controls early on in the life cycle. Analyze and export your bill so you can do further analysis. Make sure you're always staying on top of your costs. Analyze and export your bill to some tool that can do further analysis and help you with continual improvement and also managing your cost to benefit ratios. Plan your capacity requirements. Implement cost controls, automated controls using Google's help. Consider purchasing a support package. If you're a developer, you may not need that, but a larger company, a larger organization, get a support package from Google. Leverage subject matter expertise and expert judgment to make decisions for billing and management practices. And finally, you can support all 8 of these steps by using the launch checklist. Here's the URL, and I highly recommend that you go and look at this checklist and that you absorb it before you take the Associate Engineer exam. In this demo, we'll be exploring the GCP Pricing Calculator. Not only is the calculator a great tool for organizations to use for acquisitions, planning, budgeting, strategy, and cost-benefit analysis, but as far as an exam prep tool, it's also very powerful. It's an excellent resource to discover the many variables and service offerings for over 40 different GCP products. I'll use this opportunity to point out to you the products you must be familiar with on the Associate Cloud Engineer exam. These are products that we'll dive into going forward in later lessons and sub-lessons of this training series. Okay, I've signed into one of my accounts and I have gone up to cloud.google.com/products/calculator. And that's where you're going to want to go. Now, up here at the calculator, you think I might start with one of these products, like Compute Engine, which would make sense, but I'm not. I'm going to navigate to the end, and I'm going to show you first free, because on the exam, you may have a question like this one. What products are free at Google Cloud Platform? Okay, and they're going to tell you here, the Cloud Deployment Manager, the Cloud SDK, which we know, we've installed that already in a previous lesson, Cloud Resource Manager API, and this Cloud Calculator, all provided for free. So that's one thing we want to keep in mind. They may ask us on the exam. As we go back, though, we'll see a lot of these services and products are things that we're not responsible for on the exam. Okay, these are things that you'll dig into at higher levels of certification and things you'll dig into in your own job roles and responsibilities. As we move back here, we'll see things like video intelligence, Internet of Things, core, data prep. Now, Cloud Spanner. Cloud Spanner is one of those products we need to be aware of. We'll talk about Key Management Service as well. We will talk a little bit about machine learning, and of course, we'll talk about Cloud DNS. You need to be aware of Google Stackdriver, Cloud PubSub, Bigtable, Cloud SQL, Cloud Data Proc, Cloud Data Store, BigQuery, networking, cloud storage, Kubernetes Engine, App Engine, and Compute Engine. Those are all areas you'll need to be knowledgeable about these products for the exam. Let's start with Compute Engine. And as I mentioned in the introduction, really one of the great things to understand about this pricing calculator is obviously, how it works and the functionality of it, but it's also a great learning tool. Because when you come into something like the Compute Engine instances and you want to say, well, I want to look at 4 instances, you can use the up, the little up and down controller. What are these instances for? And this, by the way, is a label or a tag that you're adding. It's metadata that you're adding to this. Then you can say, well, what about the operating system and the software? So if you click on the drop-down arrow, here's a great place to see, well, for the exam, you would obviously want to know what are the free operating systems, Debian, CentOS or CentOS, CoreOS, Ubuntu, maybe other user-provided ones, okay? And then the paid ones, right? Windows Server, you can see 2008, 2012, 2016, Windows Core. It won't be long, you'll see Windows Server 2019 up here. And then, of course, other builds of Linux, and here's SQL Server, by the way. So, you choose your operating system. What about the VM class, the virtual machine class? Is it regular, or are you going to do preemptible? And preemptible, by the way, if you click on the question mark here, it'll show you that preemptible is, interruptible. Okay, so it's going to be lower costs, it's going to be cheaper. And these are the kind of things you would choose if you were going through and you were in the compute engine and you were spinning up your own virtual machine, right? These are the choices you have if you're going to use the console, the graphical interface, to do this. And you can see the different categories. So on the exam, would you need to know the different categories of your instances? Custom, shared core, standard, high memory, high CPU, mega, and ultra memory? Yes, you would. You need to know those categories. Not the specific types within those categories, but you need to know those categories. Now, if I choose a standard one as opposed to a shared core, okay, it's going to give me the ability to add to this GPUs, graphical processor units, right? So this is the kind of thing you see when people are doing, let's say, cyber mining of Monero or Litecoin, for example. And you can choose your number of GPUs, okay, up to 8, and you can even choose your type. Obviously, NVIDIA is really the only vendor they have here, but that's an extremely popular type of graphical processor, right? And then, of course, we have local SSD drives, which we can choose. They come in increments of 375 gigabytes. That would be something you want to know for the exam. The location of your data center. Then other things that are going to determine your estimate, right? How many average hour per days is the server running, okay? Are you going to do it according to hours, or are you going to do it according to minutes, okay? But minutes per day or per month. And how many average days per week is the server running? So these are the types of things that will help you in doing your planning, your evaluation, and helping your organization decide the cost benefits of moving from the data center to the cloud, to help you in your hybrid cloud solution, determining your budgets, your cost benefit ratios. And then obviously we get down into the persistent disk area, we get down into load balancing, which is going to add extra charges. Cloud TPUs are basically machine learning accelerators for TensorFlow. So AI services, machine learning services, these help you quickly deliver cutting-edge machine learning models with extra computational power combined with your custom high-speed network, okay? So that is a great learning tool. You would also want to go and take a look at App Engine. You've got standard environment instances, you've got flexible instances. For your App Engine appies and services, you can estimate outgoing network traffic, the cloud storage you're going to use, the memcache you're going to use per hour, the total number of search queries, estimating, indexing, logging, and task queues. And again, if you have any questions on these objects, click on the question mark next to it, and it'll say see more details here. And then obviously cloud storage is the next biggie. On the exam, I would try to focus on the granularities of compute engine and cloud storage for questions about the calculator. So they're going to ask you, is it multi-regional? Is it dual regional? Is it regional storage? Class A operations, which would be put, post, get on services and buckets. Class B operations would be get object and head requests. You can include the always free usage in your estimate or not, okay? And then of course you can look at nearline storage. We're going to talk about this and define this obviously later on in this training. But again, for the exam, it would be nice to know the nearline storage and the cold line storage options as well. Now, if we get down to the bottom to wrap up here, if you just want the pricing data, you can use the API, okay? Just use an API to get the information, which is going to give you a list of all public services and the metadata, a list of the public SKUs within the service, or you can say, just take me to the web page where I can actually see the SKUs, the platform SKUs, okay? And so this is going to give you alphabetically all these different product SKUs throughout the entire Google Cloud catalog, and it'll be based on product and other variants of the product, and also based on location as you move down through here, right? You can see all the different locations for the Cloud Data Store entity. From a retail standpoint, and Google is a retailer, A SKU is a stock keeping unit. Okay, so each one of these different products offerings has unique numbers and unique metadata that goes along with it. Okay, and you can see that number beneath these different products. Okay, so make sure on the exam that you do go up and you familiarize yourself with the platform pricing calculator. If you focus on these services that I listed for you, and they're also going to be in the kind of the table of contents of this training, if you focus on those, you can use this again as a learning tool to help you go and look at the different options you have and learn about the different metadata of these different services. So it's a learning tool and a pricing calculator. Excellent. On the Google Associate Cloud Engineer exam, one of the many specific objectives deals with being able to properly choose the right compute service for a given scenario. The good news is that Google Cloud is a great document with a decision tree dedicated to this topic. So in this brief demonstration, I'll take you on a web safari to this excellent resource that you can use for exam preparation and real-world planning. Okay, this is a blog article, the one I was talking about. It's at google.cloud.com/blog/products/GCP, and then it's choosing the right compute option in a GCP decision tree. And this is actually a specific objective, and it comes from a podcast, but this is really an excellent article. And it just basically reminds us that when we start a new project in GCP, that one of the earliest parts of the decision-making process or the planning process and information gathering is deciding which computing service we should use. And so typically the choice is between Google Compute Engine, Google Container Engine, App Engine, or Google Cloud Functions, which is going to be serverless, and Firebase. So the first diagram here shows you for more highly customizable options on this horizontal line, you'll focus more on Google Compute Engine, GCE. As things get more highly managed, which of course means in the scope of the shared responsibility, you're moving more from an IaaS solution to a PaaS solution with more management, more security being provided by Google Cloud. So once you go from Container Engine with your Kubernetes and get into the Google App Engine, GAE, to the Cloud Functions, it gets more highly managed on the Google side, and of course, all the way up to Firebase. And they're telling us that if you're used to managing virtual machines and you want that same type of experience in the cloud, then go ahead and pick Compute Engine. If you use containers and you have to coordinate more than one container, you can abstract away some of that management overhead by using GKE, Google Container Engine. Here's some questions down here. Are you building a mobile or HTML application that does its heavy lifting process-wise on the client? Okay, then they'll mention Firebase. Are you building a system that's more based on events than user interaction? In other words, are you building an app that responds to uploaded files or maybe logins to other applications? Well, you can already guess you're looking for something serverless. So you're looking for functions as a service solutions, okay? And that's where you're going to do Cloud Functions. Amazon Web Services has their Lambda service. Does your solution already exist somewhere else? Okay? Does it include licensed software? Do you need anything other than HTTP or HTTPS? Well, they'll mention App Engine. So there's some good questions here. I'm not going to read all of them because there's a decision tree here. And I would like you to be familiar with this on the exam, okay? So are you a mobile HTML5 developer? Yes. Well, then they're going to send you to Firebase. No. Are you developing an event-driven app? Yes. Then Google Cloud Functions. No. Then is your application any of the following? Using a specific operating system or kernel, using GPUs? If the answer is yes, you're going to use Google Compute Engine. And by the way, I can tell you this is not a very easy to see. It's kind of blurry, which is why you're going to want to go to this website yourself and add this resource to your own knowledge base. Okay, but basically just kind of giving you a heads up here about this resource that you should use in the real world and for the exam. And so ultimately, it starts to get into things like, containers. Is it a hybrid or multi-cloud deployment? Are you using licensed software? Are you using protocols besides HTTP or HTTPS? Is it already an existing app? Okay, so it starts to get into questions about containers, and obviously the answer is no to those things. They're going to send you to the Google App Engine. So anyway, great resource. I wanted to take some time in this demonstration to talk about this. Don't forget, here's the URL. Go make that a favorite in your browser, Google Chrome, for example, and make sure that you go over this before the exam. In this demonstration, we'll survey the various choices for data storage based on different scenarios and use cases. We'll also take a web safari up to Google Cloud to add some key resources to our knowledge base for exam and real-world application. Okay, this lesson is technically a demonstration only because I called it that. Okay, we're going to have some slides. I'm going to do a web safari back up to Google Cloud, but for the most part, what I'm demonstrating really is just your data storage options. Let's start out with some common use cases for cloud storage, which is probably the most common usage of Google Cloud Platform. Okay, so this is going to be a primary repository for media content, media content storage and delivery. It's geo-redundant storage, gives you the highest level of availability, the highest level of performance, so it's excellent for low latency, high quality content serving to users that are distributed across geographic regions. So streaming videos and music, serving up images and website content. It's also excellent for mobile application development. Google Cloud Storage gives you the highest level of availability and performance within a single region for your compute, analytics, and machine learning workloads. So things like video transcoding, genomics, and general data analytics and compute activities. Another great usage for cloud storage is for backups and for archives. Okay, so you can have regular archives like nearline and cold line storage. You can do tape migrations up to the cloud. It's a great place to archive your multimedia source files. It's often used as part of a business continuity or disaster recovery plan. So part of an organizational continuity of operations, or the results of their business impact analysis might be to use cloud storage for some or all of their continuity and disaster recovery. It's also a great place to keep your images for forensics investigations. It can be part of that chain of custody. Also realizing that it's being stored with a high degree of availability and 11 nines of durability. It's often used for storing image snapshots that are then provided to web servers and web services and application services, or just long-term storage based on your retention policies from HIPAA or Sarbanes-Oxley or GDPR, or a wide variety of other regulations and mandates. I'm going to show you some comparisons of storage class, and these are the 4 classes that you'll need to remember for the exam. Now, I wouldn't worry about the pricing in gigabytes per month. This is subject to change, so it's highly unlikely that this information is going to be tested, but it will give you kind of a good idea of the differences. Okay, so if we start with multi-regional, and multi-regional is the most common usage, okay, you're going to be looking at basically 0.026 to 0.036 cents per gigabyte per month. Notice that regional is about the same, okay? Where you really see your cost difference is when you go from multi-regional and regional in gigabyte per month to nearline and look at cold line, okay? Cold line compares very well to Amazon Web Services Glacier, coming in at 0.007 to 0.014 cents per gigabyte per month. The highest availability is in multi-regional, so the service level agreement is going to be 99.95. The availability slightly goes down between there and cold line, but like most of the providers in their object storage, the durability is going to be 11 nines. And, so the odds of something stored as an object in a bucket being destroyed is kind of astronomical. Responsiveness, millisecond access that's consistent with your application programming interface. Redundancy, multi-regional is geo-redundant, regional is regional and redundant across availability zones, and nearline and cold line both have regional redundancy. Use case and applications is probably the most important information for the exam. Okay, so multi-regional use case is for content storage and delivery, for business continuity. Regional is to store data and to run data analytics, let's say machine learning, your video transcoding, your genomics within a region. Okay, nearline is store infrequently accessed content, and then cold line is your archive storage, backup, and recovery. Realize that nearline and cold line are both going to allow you to have a certain number of retrievals per month, and then after that they're going to charge you. So it's kind of like when you got that first savings account, right? I put $100 in my savings account and they allowed me to get 3 withdrawals per month. After that they're going to charge me. Okay, same concept. They're not going to disallow a retrieval, but they may charge you for excessive retrievals. And then applications, multi-regional, we're looking at video content, multimedia content, and business continuity activities. Regional would be transcoding, data analytics, compute, and intensive data processing. Nearline is to back up long tail content and rarely accessed docs like PDFs, for example. And then cold line is your archive storage, your file backup, your long-term disaster recovery, and your long-term data retention based on mandates and regulations and governance. Now, one of the most common reasons to use a public cloud provider, let's say like Google Cloud Platform, is migration. Migrating from your existing data center, part or all of your operations up to the cloud. When we say migrating, remember, we could be migrating data at rest for various reasons. We could be migrating applications and application development for various reasons. And by the way, migration may actually come from or stem from an existing disaster recovery plan or business continuity plan. So for example, your company may be a large organization. You may decide to use the cloud provider first as part of the disaster recovery solution and then go through different tests and different scenarios, different walkthroughs, and once you're confident with the cloud being a secure disaster recovery and business continuity solution, you may then begin to migrate your operational activities, your ongoing operations up to the cloud, whether it be systems, services, or applications. So this usually involves migrating from your existing storage area network or your network attached storage, or maybe you have both, depending upon how you're using your databases. Maybe migrating your Microsoft SQL Human Resources Department up to the cloud. Maybe taking advantage of some software as a service solution for your endpoints. Or it could be your disk attached on-premise solution. Typically, you're going to be migrating to Google Cloud Persistent Disk and or Google Cloud Storage. Now, if you're going to migrate from Amazon Web Services, or really you're migrating from AWS or IBM Cloud or Microsoft Azure or your own on-premise physical data center or on-premise cloud, this is the link you want to check out. Okay, so it's at cloud.google.com/solutions/migration center. Let's go take a look. So here's the link I just mentioned. You really want to add this to your knowledge base, and you probably want to read through this before you take the exam, because they're going to mention different types of migration strategies. And these four right here, I mean, I could have made a slide for this, and I do have a slide, but this particular look pretty much says in a sentence what these are. And you need to know these for the exam. So first we have lift and shift, which is very popular. It's typically the easiest way to start. It requires the fewest changes to your applications. It's going to involve shutting down the existing application, copying the data and the virtual machines to the cloud. So the first step in lift and shift is to move the data necessary to run the application. And it tells you that this approach works best if minimal architecture changes are required. Save time and money when you shift infrastructure and apps from on-premises into the cloud, such as migrating VMs from on-premises to GCP. And that's the one I want you to be the most aware of. It's the most popular. Next, you have move and improve. It tells you that many applications are best suited to simply migrate as they are or as is, but others need some post-migration enhancement or taking advantage of some of the services that GCP provides. For example, converting a system into a Kubernetes container or modifying some legacy components into cloud-based services. Okay, move and improve. Then there's rebuild in the cloud. Google, as well as partners, help you modernize your traditional on-premises applications by rebuilding them in the cloud using their serverless computing platform. And again, that's taking advantage of Google Functions and other services. And then the fourth option is the hybrid and multi-cloud, using Google Cloud to craft the architecture that is suitable for your particular situation. You can leverage their openness, you can plan, build, and manage your applications across the cloud and still retain on-premise data centers or private hosted services or a multi-cloud environment. So remember, on the exam, these are the four main migration options. If you come down here, you'll see the life cycle of a migration journey according to Google Cloud. So step one or phase one is to assess, determine the use case, explore migration solutions, and what migration journey is right for you. Phase two is plan. Develop a detailed migration plan with tools, solutions, or partners. Phase three, migrate. Migrate according to your detailed plan created during the previous planning phase. And then finally, optimize. After your migration, look for ways to establish operational best practices and enhance existing processes. And you can even see they're showing one of their partners there, Velostrata, okay? And if you even go down here more, you can see other partners that will assist you in the migration process, especially in the first two phases. And then in all four phases, they've got other partners. Memorizing these partners like Accenture or Stratozone is not important. They won't be on the exam, but it wouldn't hurt to memorize these four phases of migration for the exam. This demo will give us our first glimpse into several storage options and services in GCP. GCP has an excellent variety of storage choices to meet your needs for structured, unstructured, transactional, and relational data. In this demo, I'll show you persistent storage, Google Cloud Storage buckets, Cloud Spanner, Cloud SQL, and Cloud Bigtable. Keep in mind that we'll go even farther into these services in Lesson 9, deploying and implementing database and storage services. Okay, as you can see, I'm in my first project, and I've created a new VM instance, and we're going to look first at persistent storage. And this is basically persistent disks that are what we would consider durable network storage devices, and these get mapped directly to our instance. If I go to the boot disk area first and click on Change, I can obviously see, obviously some OS images, application images, but I want to come down here to the boot disk type and realize that, for the boot disk, we have the standard persistent disk, or we have the SSD persistent disk. Either one of these can be used as regular storage, and the data stored on them will be on the disk until it's deleted. Keep in mind that data on a persistent disk is redundant. It's also optimized for performance. In addition, persistent disks are independent of any virtual machine, so you could detach and reattach persistent disks to other compute instances. Now, obviously, this one right here is going to be a boot disk image, but if I cancel out of here and I scroll down to where I can expand out management, security, disks, networking, and sole tenancy, go to the disks area, and by the way, I think management would be selected by default, but go to disks area, I can add a new disk. And here we see, and here would be an example of a persistent disk that I could attach and reattach. The thing about persistent disks is if your instance is deleted, the persistent disk data remains if you decide not to delete it. And you can see I've got standard persistent disk and I've got SSD persistent disks. These can be resized at any time. And a compute engine by default will get deployed with one root persistent disk that has the operating system. We saw that earlier. The scope of a persistent disk is limited to a zone. So a persistent disk can only be in one zone in a region. It won't span multiple zones or regions. If your application needs high IOPS, SSD persistent disks are best to use. I can also take a snapshot of the persistent disk to protect the data against any errors. Snapshots will be incremental, and I can take backups even when the instance is up and running. Also notice down here where it says encryption. All data is encrypted by the compute engine before it travels out of the virtual machine, and it's written on the persistent disk. So each persistent disk is encrypted either by the system defined, or I could go, and provide a customer managed key or a customer supplied key. The maximum size of a persistent disk is 64 terabytes. And at this particular point in time, I can have a maximum of 16 attached disks. Now, another option that we see up here is what we call the local SSD scratch disk. Local SSDs are physically attached to the server that hosts the virtual machine instance. This actually gives you higher throughput and lower latency, but there's a catch, okay? The data on this local SSD is only going to be persistent as long as the instance is up and running. So the data remains in the local SSD if I reboot the instance or if I do a live migration. But if I stop the instance or delete the instance, all the data is lost. Now that you know about standard SSD and local SSD, let's go take a look at Google Cloud Storage buckets. I'm going to go to the navigation menu and go down to the storage area, and I'll click on Browser. Now, in the previous lesson, I talked about the differences between multi-regional and regional and nearline and cold line. I'm not going to reteach that, but notice that our object storage here is scalable. It is available, highly available, so it's 99.95 availability for multi-regional storage, and it's durable, or 11 nines. Now, let me remind you, there's a difference between durability and availability. So for example, I just got a puppy, right? My wife gave me this beautiful miniature Australian Shepherd, and so I've got a bunch of pictures of my pet, okay? So I want to put those precious pictures up into a storage bucket, right? Well, if I have those pictures up in the bucket and I'm able to get access to those pictures, that's what we call availability, okay? 99.95 SLA availability. Now, the fact that those pictures will stay intact and not be destroyed or deleted accidentally, that's durability, okay? 11 nines. So multiple copies of those pictures of my puppy are going to be stored redundantly across disks, across racks, and across power and network failure domains, okay? So this 11 nines of durability, by the way, is the same thing you would get from Amazon Web Services if you're using their S3 service, for example. So keep in mind, durability and availability aren't the same thing. But let's go and create a bucket. And we're going to do this again, okay? But I'm just kind of showing you, obviously, you have to give a bucket a unique name. Okay, so I can only have one dot in there, but that's a unique name. So make sure that you have that unique name first off. Then, of course, you'll choose your storage class. If no storage class is chosen, the default storage class for the bucket is going to be standard storage, okay? Keep in mind, I could transfer data from my Amazon S3 instance, or from really any HTTP, HTTPS instance or third-party storage buckets into my Google Cloud Storage bucket if I wanted to. If I wanted to do that, I would go over and click on the transfer over here on the storage menu. As I go down, I can see that I can choose my access control model. So we have a separate access control list that can be applied, okay? So, and this is separate from the firewalls that you would think about, okay? So we can set permissions uniformly at the bucket level. So that's a bucket policy only. It enforces the bucket's identity access management policy without using object ACLs, or I can set object level and bucket level permissions. This enforces the IAM policy and it uses ACLs for more granular control. Labels are the same things as we see as tags. It's a key value pair, and this is metadata that you can add to the bucket that can also facilitate using, let's say, for example, Google Cloud Functions, okay? So based on certain labels, you can have functions that are triggered, or other automated and orchestrated activities based on your labels. Again, with encryption, we can use the Google managed key, or we can do a customer managed key. And of course, if we have an encryption key, we could choose it from the drop-down, or we could go create one. And we could create one in the Cloud KMS. Then, of course, we're going to choose our retention policy. This sets the minimum duration that the objects in this bucket must be protected from deletion or modification once they're uploaded. So you would use this to be, in adherence to your governance or your regulations, for maintaining PHI and PII for your HIPAA or your Sarbanes-Oxley, okay? By the way, this is an advanced setting here. I can show and hide those. And of course, I can choose different locations. When I'm done, I can click on Create. Okay, let's go take a look at Cloud SQL. I'll go to the navigation menu and go back down here to Storage, and I'll see SQL or SQL. And we're going to be doing a more elaborate version of this a little bit later, fully managed relational database service. And it's for, as you can see here, MySQL versions 5.6 and 5.7 at the time of this recording, or Postgres. That's version 9.6. So you get a lot of features here. You can deploy large instances that can support up to 416 gigabytes of RAM and 10 terabytes of storage space. Also, Google automatically encrypts all the customer data on these database instances. Now, at the time I'm recording this, PostgreSQL 9.6 will support machines up to 416 gigabytes of RAM, 32 CPUs, and 10 terabytes of storage space. So you can choose your option. And when you do, you'll give it an instance ID. You want to have a root password. You can have one generated for you, or you can say no password, and you can choose your location, your region, and your zone. Also, you can show additional configuration options. For example, you can choose your database version. You can set up your connectivity to make it public IP enabled. You can configure the machine type and the storage. For example, by default, the storage type is SSD. And the storage size is 10 gigabytes. You can enable backups and high availability. You can set up flags, a maintenance schedule, or you can add labels. Let's look next at Cloud Bigtable. I'm going to go up to the navigation menu, to Bigtable. Now, by the way, once I'm here, it's going to tell us what Bigtable is. It's a petabyte scale, no SQL or no SQL. So it's a document-oriented database. You can scale up to billions of rows and thousands of columns. This is great for applications that need high throughput, okay? It's a great storage engine for batch map reduce operations and machine learning applications. It stores data in tables, and these are sorted in a key value mapping. The Bigtable service also has multiple client libraries that will let you easily integrate into existing environments. So you just go in here and create an instance. And of course, you would give it a name, an ID, instance type, productions recommended with 3 nodes, or you can choose development for a low-cost solution. You've got SSD storage or HDD storage, and then at the bottom is where you're going to set up your cluster configuration. And again, we have a demonstration coming up later on in Lesson 7, and we'll get more into this. All right, that's our quick demo introducing Google Cloud Platform Storage. Module 4, Deploying and Implementing a Cloud Solution. This module has 4 lessons, and it's really the foundational learning content of this course. I will present over 2 hours of hands-on demonstrations. Module 4 covers all of the exam objectives for configuring compute, database, and storage services, as well as networking and other services like Google Cloud Launcher. Lesson 8, Deploying and Implementing Compute Services. We'll begin deploying and implementing Compute Engine, then deploying and implementing Kubernetes Engine Part 1, and deploying and implementing Kubernetes Engine Part 2. Then deploying and implementing App Engine and Cloud Functions Part 1, and deploying and implementing App Engine and Cloud Functions Part 2. In this demo, we're going to start out with a return to the service account. We configured a service account earlier in sublesson 6.1 when we set up the Google Cloud SDK under the context of an account, which is not only a best practice, but it eliminates some common errors. Service accounts are a special Google account that grant permissions to VMs instead of end users. Service accounts are typically used to ensure safe, managed connections to APIs and GCP services. After we dig deeper into the service account, we'll then implement some Compute Engine instances, including one from the marketplace. Okay, like I said, the first thing we're going to do is we're going to focus on service accounts, and we've already created a service account earlier in this training. Remember when we did the G-Cloud SDK installation on my machine, I created a service account for that, and we're going to do that again. And obviously, as you can see here, I'm in Quick Labs, and I'm going to give you the name of these Quick Labs or the numbers, so you can go in and do these yourself to help prepare for the exam. Now, when you run G-Cloud, by the way, one command you'll need to know for the exam and to be very familiar with is the command G-Cloud auth list. Remember that one for the exam? That'll basically show me the active account name, so we can see that it's basically Google and some, pseudo-random number _ student at quicklabs.net. Another command to know for the exam is G-Cloud config list project. And that'll show you the active project. Now there's several types of service accounts, and we've already seen a user managed service account, okay? That was the one we created when we installed and we ran the SDK, the Google SDK, under the context of that user managed account. So if you generate a new cloud project using the GCP console, and if the Compute Engine API is enabled for the project, a Compute Engine service account will be created for you by default. And you can see it. Here's an example. You could access it through email. For example, here, project _ number. Okay, so whatever the project number is, --compute@developer.gserviceaccount.com. But there's also Google managed service accounts. Okay, and you might see these in your project's IAM policy or in the GCP console. These Google managed service accounts are created and owned by Google, and these represent different services, and each account's automatically granted IAM roles to access your GCP project. And then you've got what are called Google Appies service accounts. So let me clear all this out and show you an example of that. A Google Appy service account would be identifiable using the email, your project number at cloudservices.gserviceaccount.com. And this is basically used to run internal Google processes on your behalf. It's not going to be listed in the service account section of the GCP console. And by default, the account's automatically granted the project editor role on the project, and it's listed in the IAM section of the GCP console. All right, let me go ahead and get rid of this, and let's go ahead and create a service account. So we'll do this command, G-Cloud IAM service accounts, then create, and we'll call this my service account 123, and then the display name will be my service account. Okay, something creative like that. I'm sticking pretty close to the lab here, so when you do this on your own in QuickLabs, you'll just be reinforcing what I'm showing you. Okay, so I've created that service account. The next thing I want to do is grant IAM roles. And when you do this, you can basically make your service account either a resource or an identity. Your application will use a service account as an identity to authenticate to Google Cloud Platform services. So for instance, if you have a Compute Engine VM running as a service account, you could grant the editor role to that, the identity for that project. So the bottom line is you grant roles to the service account so it has the permissions to do certain actions on the resources in your GCP project. Like, for example, you might want to grant the storage.admin role to the service account so it has control over objects and buckets in Google Cloud Storage. Let's go ahead and grant some roles to this service account that I just generated. Okay, so I copied and pasted this command in there. See right here, gcloud projects add IAM policy binding. I ran that to grant roles to the service account that I just made. And we can see in the output here a list of the roles that the service account has. Now there's three kinds of roles in Cloud IAM. There's primitive roles, which include the owner and editor and viewer roles that existed prior to the introduction of Cloud IAM. We have predefined roles which provide granular access for a specific service. These are managed by GCP, and we have custom roles which provide granular access according to user-defined lists of permissions. So we're going to query the BigQuery public data sets from an instance using this service account which has the necessary roles. So I'm going to go back over to the navigation menu, and I'm going to come down and go to IAM and admin, and I'm going to go to service accounts. I can see some existing service accounts here, AppSpot, developer, and so on. I'm going to create a service account. I'm going to call this BigQuery QuickLab, and I could describe it. I'll click on create. I'm going to add a couple of roles here. So I'll select a role. I'm going to go to BigQuery, and I'm going to add BigQuery Data Viewer, add another role, go to BigQuery, and we'll add BigQuery User. Click on Continue. I could optionally grant users to this service account, okay, but we're going to go ahead and attach this to an instance or a VM. I could also create keys if I wanted to. You can see JSON pops out there. Click on Done. Let's go back up to the menu and go to Compute Engine, VM Instances, and we'll create an instance. We'll call this BigQuery Instance. We'll stick with the default region, default zone, the machine type, the boot disk, but for service account, we'll go to the drop-down and we'll choose. It didn't show up there, so I'm going to type in BigQuery, and now there it is. BigQuery QuickLab. Okay, well, I've accomplished the goals of this demonstration so far. We've gotten to the point where we have created a VM instance and we've attached a service account, in this example, BigQuery QuickLab, to this VM instance. Now, when you do this lab on your own, you're actually going to go and use Secure Shell. You're going to connect and you're going to run some sudo apt-get commands and some sudo pip install commands. You're going to install the necessary dependencies. You'll then create a Python file. You'll copy and paste that in there. You run a couple of commands to add some things to that script, that query.py script you'll create. Then you'll actually do a BigQuery application using the permissions that are associated with this service account to get some output about the years and numbers of babies that were born in the BigQuery database. Now, this is not a demonstration or discussion about BigQuery. That's going to come up later on in this training, and so we'll do some demonstrations of BigQuery when we get to it. Okay, I'm going to go up to the menu, the navigation menu, and choose Marketplace. The GCP Marketplace is an excellent way to launch common software packages and application stacks on GCE in a user-friendly way. You're going to find a lot of common web frameworks, CRMs for customer relationship management, databases, and more. And it's a really fast, rapid deployment method to get up and running on Google Cloud Platform. So we'll just go to the search box here, and I'll start typing in. I'll do NGINX, and I'm going to see NGINX open source certified by Bitnami. Click on that and we'll launch on Compute Engine. Now it creates my project for me and I'm going to see a new NGINX deployment page in the Cloud Console. You can see the deployment name, fine, I can just stick with that. It gives me a default. I can choose the zone I want to choose, so US Central 1F is fine with me. We're going to leave this as default, but the machine type, there's lots of options there, okay? But for this, or very low cost version, we're going to go with the micro, one shared vCPU, 0.6 gigabytes of memory, and the F1 micro. We'll stay with the standard persistent disk, the boot size of 10 gigs. We'll make sure that we come down here and that allow HTTP traffic and allow HTTPS traffic. We have to also accept the GCP Marketplace Terms of Service and then click on Deploy. This will take a few minutes, so I'll catch back up with you when it's done. Okay, that took a few minutes, but you can see that it's up. You can see a lot of things going on here, a lot of Python scripts, of course, a couple of firewalls. We can click on the Visit the Site button over here to the right. Congratulations, you're now running Bitnami. You got a quick start guide, access phpMyAdmin, Bitnami documentation, Bitnami forums. I can also, if I want to, click on the SSH link for the VM instance in the console and open up a secure shell prompt in the new browser window. Then I can use, commands like ps to see if it's running on my instance, for example. So we'll do ps aux, pipe that to grep, and then nginx. All right. Kubernetes is an open source project available on kubernetes.io, which runs on many different environments, from laptops to high availability multi-node clusters, from on-premise deployments to public clouds, and from virtual machines to bare metal. For this demonstration, using a managed environment like Google Cloud Kubernetes Engine, let's focus on experiencing Kubernetes rather than setting up the underlying infrastructure. In this two-part demo, I'll provision a complete Kubernetes cluster using Kubernetes Engine, and then deploy and manage Docker containers using kubectl. Okay, this Kubernetes lab or demonstration I'm going to do has a lot of steps, so I'm going to be doing a lot of copying and pasting in of my commands. I'm not a super fast typer anyway. I actually have carpal tunnel in my left hand from being a guitar player for decades, so I kind of have some issues with that. Never have been able to type really fast because of that. So the first thing I'm going to do is I'm going to copy and paste in the command in the Cloud Shell that's going to set the zone. So basically, gcloud config set compute zone US Central 1B. Let's go ahead and set up a cluster to use for this lab. So this will be, I'll go ahead and type this one in. This will be gcloud container clusters create IO. It'll take a while, so I'm going to go ahead and pause this. Okay, so I'm done. You can see that we've got a master IP address and the status is running. So now I'm going to clone the GitHub repository. So I'm going to use git clone and then that address. Let's change directories with cd. So now we're in the orchestrate with Kubernetes /Kubernetes directory. By the way, if you decide to go up to Quick Labs and perform this GSP 021, which is actually the lab orchestrating the cloud with Kubernetes, you want to make sure that as you're doing this, that when you need to be, that you're in this directory. Okay, otherwise it just simply won't work for you. Let's go ahead and list the files we're going to be working with here. Deployments, Nginx, pods, services, TLS, and then a cleanup script. All right, we have the code. Let's dive into Kubernetes. Let's go ahead and use kubectl and make sure that you're aware of this command on the exam. Kubectl, and we're going to launch a single instance of the Nginx container. So now Kubernetes has created a deployment. We'll talk more about deployments a little bit later in this demo, but for now, the deployments keep the pods up and running, even if the nodes that they run on happen to fail. In Kubernetes, all containers run in a pod. So let's do kubectl get pods. Now we can see the running Nginx container. Once it's running, we can expose it outside of Kubernetes using the kubectl expose command. So basically what we're going to do here is behind the scenes, Kubernetes is going to create an external load balancer with a public IP address attached to it. Any client who hits this public address will be routed to the pods behind the Kubernetes service. In this case, it's an Nginx pod. Let's list our services. So we'll do kubectl get services. What we're looking for here is the external IP address for Nginx. So we see that it's pending. It could take a few minutes for this to actually get exposed. You could run that command kubectl get services, over and over and over again. But I'm going to pause the recording and wait to get that external IP address, and we'll be ready to roll on. Okay, so I'm going to use curl, and I'm going to say http://, and then that IP address, which is 35.202.208.254, or port 80, to hit that Nginx container remotely. And so you can see, this is what you would see in the page. I could open up a browser, by the way, and I could go to that IP address and I would see a simple little HTML page. Okay, so at the core of Kubernetes is the pod, and pods represent and hold a collection of one or more containers. So typically, if you have multiple containers with a hard dependency on each other, you would package the containers inside a single pod. So for example, as you can see here, there's a pod that contains the monolith and the Nginx containers. Pods also have volumes. Volumes are data disks that live as long as the pods live. So they're ephemeral and can be used by the containers in that pod. Pods offer a shared namespace for their contents, which means that the two containers inside of our example pod can communicate with each other, and they also share the attached volumes. Pods also share a network namespace. What that means is there's one IP address per pod. Now, pods can be created using pod configuration files. Let's look at the monolith pod configuration file. So we'll do cat pods/monolith, and it'll be in YAML format. So it starts right here. Few things to see. Your pod is made up of one container, okay? You're also passing a few arguments to this container. When it starts up, you're opening up port 80 for HTTP traffic. I'm going to issue this kubectl command to create the monolith pod. It's created, so we'll do kubectl and we'll say get pods. And we can see our pods. And they're both running. Now by default, pods are allocated a private IP address, and they cannot be reached outside of the cluster. So we have to use the kubectl or the kubectl port forward command. It'll map a local port to a port inside the monolith pod. Now from this point on, I'm going to be working in multiple Cloud Shell tabs, and you'll be doing the same thing, okay? You're going to be opening up, I think, 3 more terminals if you do this lab. So one thing we have to do is this. I'll activate Cloud Shell again and go to this little terminal settings and go to the tmux settings and make sure that you turn off this enable tmux integration. Okay, so kind of hard to keep track, but here's my Kubernetes shell. So to the right of that is shell 1 and then shell 2, okay? So in the second terminal that I created, I'm going to run this command to set up port forwarding. And in the first terminal, I'm going to use curl on port 10,080 to talk to my pod. And if you see message hello, then you're getting a friendly hello back from your container. Now that's good. Now what happens if I use the same curl command and I hit a secure endpoint? Authorization failed. Oops. So I'm going to paste in this command and try to get a auth token back from the monolith. At the login prompt, we're going to use the password PASSWORD. Now that's a pretty long token, okay? That's a JWT token, but Cloud Shell doesn't handle these long strings very well. So what I need to do is create an environment variable for this token, and I'm going to do that with this command. Do the password again. Let's copy this token and hit the secure endpoint with curl. Curl-H, and that's good. We got a hello message, a response back from the application telling us that everything's all right in the world. And let's say that I want to run an interactive shell inside the monolith pod. I can do that with this command, okay? kubectl exec monolith, and then you can see I've got some variables there. And this is handy if you want to troubleshoot from within a container. So for example, I can do ping, we'll do count 3 of them, let's say google.com. When you're done with the shell, just click on exit. We're back to the monolith pod. Okay, let's continue along with part 2 of the deploying and implementing Kubernetes engine demo as we look at Kubernetes services and then break an application into 3 microservices using Kubernetes deployments and services. Now, pods aren't persistent, nor are they meant to be persistent. They can be stopped, they can be started for a wide variety of reasons. For example, if a readiness check fails, and that could cause a problem. What happens if you want to communicate with a set of pods? Well, when they get restarted, they might have a different IP address than the one we saw earlier. Well, that's where services can help out. Services provide stable endpoints for pods. Services use labels to determine what pods they operate on. If a pod has the correct label, it's automatically picked up and exposed by our services. Now, the level of access that a service provides to a set of pods depends on the service's type, and there's currently 3 types of services. Cluster IP or internal. This is the default type, which means that this service is only visible inside of the cluster. Node port. That gives each node in the cluster an externally accessible IP. And then there's load balancer. This adds a load balancer from the cloud provider, which forwards traffic from the service to nodes within it. Now, before you create services, we need to create a secure pod that can handle HTTP traffic. We need to make sure, by the way, you're in the same directory, orchestrate with Kubernetes /Kubernetes. Okay, so these commands, which are basically kubectl create, secret config map, and then -f pod secure, basically creates the secure monolith pods and their configuration data. So now that you have a secure pod, we can expose the secure monolith pod externally. And we do that by creating a Kubernetes service. Let's do cat services.yaml. Notice there's a selector which is used to automatically find and expose any pods with the labels app equals monolith and secure equals enabled. Now we have to expose the node port here because this is how we'll forward external traffic from port 31000 to Nginx on port 443. So we'll use this command, kubectl create -f, to do that. So we're using a port to expose this service. So it's possible to have port collisions if some other app tries to bind to port 31000 on one of your servers. Typically, Kubernetes would handle this, but we're in a lab environment. So we're going to choose a port so it's easier to configure health checks later on. We want to allow traffic to the monolith service on the exposed node port. So we're going to do some firewall rules. Creating the firewall. Good. Let's get an external IP address for one of the nodes. We'll run gcloud compute instances list. Now if I try to hit one of these IP addresses, 23.251, if I tried to hit that using the curl command, curl-k, then the IP address on port 31000, it's going to time out. The problem is I need a label because currently the monolith service doesn't have any endpoints. So one way to troubleshoot this issue is to use kubectl get pods with a label query. But what about app monolith and secure enabled? We'll run that. No resources found. So we need to add the secure enabled label to them. So we'll use the kubectl label command to add the missing secure enabled label to the secure monolith pod. Okay, so now that our pods are correctly labeled, let's see the endpoints on the monolith service. Kubectl describes services monolith, pipe it to grep endpoints. All right, so we have one. There's an endpoint, 10.4.2.5 on port 443. Let's test this out. Try to hit one of our nodes again. So you can see at the bottom, I'm going to try to hit 23.251.157.179 on port 31,000. All right, message hello. Well, our long-term goal is to get ready for scaling and managing containers in a production environment, and that's where deployments come into play. Deployments are a declarative way to make sure that the number of pods running is equal to the desired number of pods needed by the user. The benefit of deployments is in abstracting away the low-level details of managing pods. Behind the scenes, deployments use replica sets to manage starting and stopping the pods. If pods have to be updated or scaled, the deployment can handle that. Deployment also handles restarting pods if they happen to go down for some reason. Pods are tied to the lifetime of the node they're created on. So for example, if a node goes down, it'll take the pod along with it. Instead of manually creating a new pod and finding a node for it, your deployment will create a new pod and it will start it on a new node. So to create a deployment, we're going to break the monolith app into 3 separate pieces. Auth, which generates JWT tokens for authenticated users. Hello, which greets authenticated users. And front end, which routes traffic to the auth and hello services. Let's get started by examining the auth deployment configuration file. The deployment, as we see here, is creating one replica, and we're using version 2.00 in the Kelsey Hightower auth image. So let's go ahead and run the kubectl create command to create the auth deployment. It'll make one pod that conforms to the data in the deployment manifest. So you can scale the number of pods by just changing the number specified in the replicas field. So go ahead and create the object. Deployment.extensions auth created. Next, let's create a service for our auth deployment. The service auth is created. And we'll do the same thing to create and expose the hello deployment. And one more time to create and expose the front end deployment. Now there's one more step to generating the front end because you have to store some configuration data with the container. But we can interact with the front end by grabbing its external IP and then curling to it. So curl-k https:// the external IP is 35.188.65.5. Then hopefully we get a hello response back. All right. Well, congratulations. We just developed a multi-service application using Kubernetes. When you have time, make sure that you go up to Quick Labs and do Orchestrating the Cloud with Kubernetes, GSP 021. Good job. In this 2-part demo lab, we'll explore several App Engine components, like the App Engine Admin API and the Google Cloud SQL Admin API. We'll also create a SQL Cloud instance with a backend cloud storage bucket, and then deploy the WordPress app and create a WordPress project. All right, well, as I said in the introduction, we're going to get into the App Engine here. We're also going to look at some cloud functions a little bit later on, but we're going to look at several different components of the App Engine. We're going to look at the App Engine Admin API, the Cloud SQL API, We'll also create a cloud storage bucket and set some permissions. We're going to install Composer, which is a dependency management tool for PHP. And then we're going to also dig in and create a WordPress project. So we're going to be looking at quite a few components here, quite a few solutions in this particular demo lab. If you want to do this on your own, by the way, this is going to be QuickLab GSP 029. Well, the first thing we have to do is enable the App Engine Admin API. So I'm going to go up to the navigation menu and make sure we choose App EN Services, and we'll go to the dashboard. We're going to click on the plus sign here, Enable APIs and Services at the top. I'm just going to start typing App Engine in here, and we see the App Engine Admin API, which provisions and manages developers' App Engine applications. As we can see, the API is enabled. We can manage the API, we can try this API, but we want to go and enable the Cloud SQL API now. So we'll go back up to the navigation menu, we'll go to APIs and Services, and then back to the library. And we'll type in Google Cloud SQL. That should get us there. We want the Cloud SQL Admin API. And again, this is the application programming interface for Cloud SQL database instance management. This API is enabled, so we're ready to create a Cloud SQL instance. So back up to the navigation menu, we go down to SQL, we'll click on SQL, we want to create an instance. We're going to do a MySQL or a MySQL instance, and we're going to call this WP, because this is going to be for WordPress. Our root password will be PASSWORD. Click on Create. This will take a second. You can see it's over here churning, so I'm going to pause, and when it's done, we'll go to the next step. Okay, so as you can see, we've created our WP instance. Let's go and set up a user and database in our MySQL instance. So I'll just click on it. We'll go to Users, and we'll create a user account. We'll call this user WP, and give them a password, and create. All right, there's my WP user. Let's go to Databases, and create a database. We'll call this WP, keep the defaults, and click on Create. All right, there's our WP database, along with several other default databases. I want to also create a cloud storage bucket. We're going to need that, so let's go back to the navigation menu, go down to Storage, and then click on Browser, and we're going to create a bucket. I'm going to call this Test WP BKT 1234. I'm also going to write that down because I'm going to need that later on. I'm going to scroll down and just click on the Create button at the bottom. If I go back up here to Browser, there's my bucket. Notice over to the far right, there's these three vertical dots. If I click on those, I'll see Edit Bucket Permissions. You can also edit the labels and edit the default storage class, but we're going to edit the bucket permissions. And by the way, by doing this, we're also fulfilling some other objectives of this exam, but we're going to get more dedicated into objects, Google Cloud Storage, and buckets later on in this course. Over to the right where it says Add Members, we want to go type in All Users. Notice we have all authenticated users and all users. We're going to choose all users, and for the role, we're going to give them storage admin, and then we'll click on Add. The next thing we're going to do is we're going to install the Composer tool. Composer is a dependency management utility for PHP. We're going to set this up in the Cloud Shell environment. This is a good tool for managing the moving parts in our App Engine WordPress deployment. Now there's several commands I'm going to go and copy and paste in here. When you do the lab on your own, you can just copy and paste those commands in there. There's no reason for you to learn PHP to accomplish this. Okay, so I made that home directory, and now I'm going to go run those PHP commands. Okay, so I've run the commands php-r to verify the installer. They downloaded it, all the settings for Composer, Composer version 1.84 successfully installed to this home directory right here that was created with this command up here. And then I did an export command finally. Now I can find out more about Composer if I wanted to. I could just type in Composer right here, but I could also go to Get Composer, getcomposer.org/download. All right, let's create our WordPress project now. So the first thing we're going to do in Cloud Shell is run this command to clone the GitHub repository. Next, we want to change directories to get into the directory where we're going to instantiate WordPress. And let's use sudo and Composer to install some dependencies next. Type in yes. Down at the bottom, we're going to do Composer install and then with the variable nodev. This will take a little bit of time, so I'm going to go ahead and pause the video. Okay, from the command line, let's create our WordPress project. So it's going to be PHP and then WordPress.php setup. We're going to go ahead and use the default directory, so I'll hit enter. I want to continue, yes. It defaults to US Central 1, so I'll just hit enter. I'm going to copy and paste my project ID into here. Hit enter, put in that password of the DB, yes, and we're going to download all the WordPress stuff. Again, I'm going to pause and catch you up when this is finished. As you can see, I downloaded and installed a bunch of packages, and so my WordPress project is ready. So if I want to deploy it, I'm going to type in the command gcloud. I have to make sure I change directories into my WordPress project. Don't forget to do that. App deploy. And so I'm going to go ahead and choose US Central 11. And again, this is going to take at least 5 minutes or more. So I'm going to go ahead and pause the video again. Now this is still going on. This update service will take a while. And while this is happening, I want to talk to you about the components of an application. Your App Engine app is generated under your Google Cloud Platform project when you create an application resource. The App Engine application is a top-level container that includes the service, the version, and instance resources that make up your app. When you create your App Engine app, all the resources are created in the region that you choose, including your app code, along with a collection of settings, credentials, and your app's metadata. Each App Engine application includes at least one service, the default service, which can hold as many versions of that service as you want. As you can see in this diagram from Google, it shows the hierarchy of an App Engine app running with multiple services. In this example, the app has 2 services that contain multiple versions, and 2 of those versions are actively running on multiple instances. Having multiple versions of your app within each service lets you quickly switch between different versions of that apps in case you need to roll back for testing and for any other temporary event. You can route traffic to one or more specific versions of your app by migrating or splitting traffic. Now, each of your app services and each of the versions within those services has to have a unique name. You can use those unique names to target and route traffic to specific resources using URLs, for example, like these. And finally, you should always design with scalability in mind. So for the exam, I'm going to give you this short article as a homework assignment. Take the time before the exam to follow this link and go read this article on scalability. Okay, so it's finally done, and I want to view my application. So as it tells me to view your application in the web browser, we're going to run gcloud app browse. And here's a link, okay? So I'm going to copy and paste that into a new tab. All right, there we go. In deploying and implementing App Engine and Cloud Functions Part 2, I'll finish up the WordPress deployment from the previous lesson, Part 1, and then explain and create basic Google Cloud Functions in the console and the CLI. Welcome to the famous 5-minute WordPress installation process. Just fill in the information and you'll be on your way. All right, sounds good to me. Okay, so I'll call this Shan's blog, MJS blah. Let's get that password into the clipboard, put in my email here. Don't be offended that I'm going to hide that, and we'll install WordPress. And then we'll log in, paste that password. All right, there we are on the dashboard. Never save that. Now to configure our WordPress blog, we want to go to plugins over here on the left-hand side and go to Google Cloud Storage Plugin. Click on the checkbox, activate, and then go to settings. And we need to put in that bucket name. Remember I mentioned that to you earlier. Mine was test WP BKT 1234. Now otherwise, if you don't remember it, didn't write it down, you can go over here back to your browser up here and go to your GCP console. You'll be able to see it there. Click on Save Settings. And this plugin lets us upload media files to the cloud storage bucket and then serve them from there instead of using a local file system. And since App Engine can spawn a new server for you, the media files have to be shared between all the servers. Okay, so I can go back to the dashboard. And if you do this in the Quick Labs, depending on how much time you have left, okay, because it did take about 7 to 8 minutes to install WordPress, you might want to go and spend some time here just kind of playing around, writing your first blog post, something like that, and you can start, getting into that. All right. Okay, I want to finish off this demo looking at Google Cloud Functions, both in the console and from the command line. And if we look over here at the left-hand side on the navigation menu, we can see that Cloud Functions are down here under the same category as Compute, along with App Engine and Compute Engine. And because of that, we're going to include that here in this demonstration. Now, Cloud Functions are basically serverless execution environments. If you're familiar with Amazon Web Services, they call it Amazon Web Services Lambda. So it's the same thing. You write simple, single-purpose code or functions, and you attach these to events that come from your cloud infrastructure and from various services. The function's triggered when an event that you're watching gets fired. And this code executes in a fully managed environment. In other words, using Google's infrastructure. You don't have to worry about managing servers, configuring any software, no updating of frameworks, no patching of operating systems. The software and the infrastructure are fully managed. You just add the code. And some of the use cases would be things like lightweight ETL, automating cloud activities, data processing, creating webhooks and lightweight APIs, mobile backend actions like analytics, and IoT, Internet of Things. So basically, cloud events are just things that happen in your environment, okay, like changes to data in a database. Maybe you add a file to a storage system, or you spin up a new VM. An event occurs whether or not you choose to respond to them. You can create a response to an event with a trigger. And a trigger is a declaration that you want to create some event. And a trigger is a declaration that you're interested in a certain event or a set of events. So when you bind a function to a trigger, it lets you capture and act on events. So let's go over to Compute on the navigation menu and choose Cloud Functions. We'll see a brief definition here of what they are. Realize that Cloud Functions are written in JavaScript and they execute in Node.js environments on GCP. Click on Create Function. We'll just name this GC Function, and you can allocate different amounts of memory from 128 megabytes to 2 gigabytes. We'll stick with the default 256. There are several ways to trigger this. There's also some things that are in beta, but for the most part, we either use HTTP as a trigger from an event there, a cloud pub sub event, or a cloud storage event, and several other things that are in beta. We'll stick with HTTP. You can see the function has its own URL. As far as source code goes, we're going to stick with the inline editor, and our runtime will be Node.js 6 as opposed to Python or Go. And we're going to go ahead and use this index.js, and we're going to use the hello world function, the default that shows up right here. in just this, 9 or 10 simple lines. I'll click on Create. This will take a few seconds to spin it up, so I'm going to pause the video and I'll catch you up when we're there. Okay, that took quite a bit of time, but my function is actually spun up. Let's start over again, this time doing it in the command line, and we'll also look at some other things like actually triggering the function and looking at some logging. Okay, the first thing we're going to do is make a directory for our function code, so GCF hello world. Next, we'll change over to that directory, and we need to create and open index.js to edit. So we'll say nano index.js. I'm going to paste this into the index.js file. This is our cloud function. By the way, on the exam, you don't need to worry about memorizing this code. We're just getting our feet wet here. I'm going to exit nano, do Control X, and then yes to save the file. Next, I'm going to use gsutil, and I'm going to create a new cloud storage bucket for my function. The bucket will be called myGCFunction BKT. Now, when you deploy a new function, you have to specify certain parameters like trigger topic, trigger bucket, or trigger HTTP. When you deploy an update to an existing function, the function will keep the existing trigger unless you specify otherwise. So we're going to set the trigger topic as hello world. So to deploy the function to a pub sub topic named hello world, we're going to do this. So cloud beta functions deploy hello world. And I'm going to go ahead and pause because it might take up to 2 minutes. Okay, let's verify the status of the function. Status active. Good, that's what we want to see. Every message published in the topic triggers function execution. So the message contents are passed as input data. After we deploy the function and we know it's active, we want to test it. So we're going to test that the function writes a message to the cloud log after detection. We'll issue this command. Got an execution ID. Let's view logs. By the way, we could also view logs over in the graphical interface as well. All you had to do was, once the function spins up, there's those 3 little buttons over to the right. If you click on that, you've got an area where you can test the function, and then you can go back to the overview window and you can also view the logs as well. So there's our logs. We see hello world, function execution started, then my cloud function hello world, and then you can see it took 127 milliseconds with the status of OK. All right, so looking at cloud functions both in the console and the command line. Lesson 9, Deploying and Implementing Database and Storage Services. We'll begin initializing data systems with Cloud SQL, then Cloud Data Store, followed by Cloud Storage, and then BigQuery, and then Cloud Spanner. We'll then look at Cloud PubSub, move on to Cloud Bigtable, and finish up with Cloud Dataproc or Datapros. Now this demo isn't our first foray into Cloud SQL, and it won't be our last. MySQL is a very common backend relational database for a wide range of GCP products and services. In this demo, we'll use the command line exclusively to import some U.S. Bureau of Transportation statistics via CSV text files into a Cloud SQL instance. We'll then perform a basic data analysis exercise using some basic queries. Okay, this demo lab is going to use a set of code samples and scripts from an O'Reilly Media book called Data Science on Google Cloud Platform. O'Reilly and Safari is actually one of the partners of Pearson, and we're basically going to clone a sample repository that's used in chapter 2 of this book from GitHub. So that's the first thing we're going to do. Clone this, and then we're going to carry out all of our tasks from this point on. Okay, I need to change to the repository directory. Next, I need to create some environment variables that I'll use later in the lab for our project ID and storage bucket that'll have our data. So we're exporting the project ID and we're exporting the bucket. Next, I'm going to use gcloud SQL instances create, and we're going to be using flights, as I mentioned, that data that is from that Department of Transportation. This will take a little bit of time, actually several minutes, so I'm going to go ahead and pause the video and we'll resume when it's done. Okay, next we need to set a root password for this instance. It's going to be capital PASSW0RD. Next, I'll use the export command to create an environment variable with the IP address of the Cloud Shell. Next, we'll use gcloud SQL instances patch to whitelist the Cloud Shell instance for management access to the SQL instance. We'll say yes. This next command, MySQL IP, will actually get the IP address of my Cloud SQL instance. And then now we could just use echo MySQL IP. And there it is. I'm going to jot that down just in case. This next command is going to actually create the flights table, create_table.sql. Put in the password. And there's the table. You can see there's quite a few columns of varying data types: airline ID, carrier, origin, airport, destination, depart time, taxi out. Great information. There's just a ton of data analysis you can do on this, and if you get that book from O'Reilly and this is in your wheelhouse, you may want to dig deeper into this. Next, I want to go ahead and connect to the MySQL command line interface. As I put in the password again. There we go. Let's check the import by entering use BTS, describe flights in a tabular format. I'm going to query this table, select distinct from the flight date column. Notice that it's empty. Well, we need to get some data in there. So we're going to copy the CSV files that are stored on cloud storage. We'll do that locally. These are the source files that basically I talked about. Problem was I was trying to do that from within MySQL. Okay, I needed to get out and exit out. I forgot to do that. So that's where you see the errors up there. But now I'm back into the command prompt, and now I'm going to import the CSV file into Cloud SQL using MySQL. Let's connect now back into the MySQL Interactive Console, and we'll use BTS. Use a SQL select command, distinct flight date from flights. There's about 59 days, okay? So you have 59 flight days. Now we're going to query distinct carriers from the flights. And we've got 14 rows, so 14 carriers. So this initial data model is based on an assertion that if a flight is greater than 15 minutes late departing, it's also going to be greater than 15 minutes arriving. Now, if you've ever flown, you know that that's not always the case. Okay, they can make up the time in the air, but this is interesting. We can use these queries to see if this model holds true. And so there's basically 4 scenarios that could be considered in this model. So if the arrival delay is less than 15 minutes and the departure delay was also less than 15 minutes, this is what we call a true negative. Where the arrival delay is greater than 15 minutes and the departure delay was less than 15 minutes, this is a false negative. Where the arrival delay is less than 15 minutes and the departure delay was greater than 15 minutes, this is a false positive. And where the arrival delay is greater than 15 minutes and the departure delay is also greater than 15 minutes, which is the initial assertion, this is a true positive. So we're going to run these SQL commands. What we find out is the true negative is the first figure, the false negative, 89,710, the false positive, 71,982, and the true positive, 292,550. So our assertion that if a flight is greater than 15 minutes late departing, it'll be greater than 15 minutes arriving, we have 292,550 instances that actually meet that scenario. Some of the GCP database services like Cloud SQL that we just looked at are pretty straightforward. Some services like Cloud Data Store, on the other hand, are rather unique to cloud hosting as they rely on huge, shared, highly scalable systems built by and for Google. Cloud Data Store is actually an adapted externalization of an internal storage system called Megastore, which used to be the underlying system for many Google products like Gmail. Google Cloud Data Store is a NoSQL document database built for automatic scaling, high performance, and ease of application development. In this demonstration, I'll show you how to get started with Google Cloud Data Store. On the exam, this GCP service is referred to as Cloud Data Store. However, this is being rebranded as Cloud Firestore, so you may see it as either one of them on the exam. Okay, let's go take a look. Okay, let's get our feet wet with Data Store, which is really Firestore. If I go to the navigation menu up here, I'm going to go down to the storage area where I see Data Store, and we'll choose Entities. We do have a Firestore link, of course, now too, but we're going to go to Data Store and choose Entities. But we're going to choose our Cloud Firestore mode, Firestore being the next generation. We can find out more about choosing a mode. Let's click on this link and go see it in a new tab here. Okay, so you configure the database instance to run in Data Store mode, which makes it database backwards compatible with Cloud Data Store. So Cloud Firestore in native mode uses the best of Cloud Data Store and the Firebase real-time database. So again, this is a NoSQL document database with new features such as a new strong consistent storage layer, a collection and document data model, real-time updates, and mobile and web client libraries. Again, Cloud Firestore is backward compatible, but you don't get these new features in the backward compatibility mode. Okay. Now we can also take a look at pricing. It is the same for Cloud Firestore. So on the exam, remember, when you use Cloud Firestore, you're going to be charged for the number of reads, writes, and deletes you perform, the amount of storage your database uses, which includes overhead for metadata and indexes, and the amount of network bandwidth you use. That's going to be in gigabytes, or 2 to the 30th power bytes, accruing on a daily basis. So you can see we've got several regions in the US here, but regardless of the region in the US, you're going to have a quota, a free quota per day of 50,000 reads. Once you go beyond the quota, it's going to be 6 cents per unit or per 100,000 documents. Document writes, 20,000 is your free quota. Beyond that, 18 cents per 100,000 documents. And deletes, your quota is 20,000, and beyond that, 2 cents per 100,000 documents. And then 1 gigabyte of storage is your free quota per day, and then beyond that, 18 cents. Okay, so these are some important things to remember for the exam. Let's go back and finish up our configuration. Now, native mode enables all of Cloud Firestore's features with offline support and real-time synchronization. Okay, you get those real-time updates, you get those mobile web client libraries and offline data persistence, but we're going to go ahead and choose the Data Store mode, which is the one you need to be aware of for the exam. Notice it says choose your location, and choose it carefully because your location selection is permanent. It also applies to this project's App Engine app. So I'm going to go ahead and choose United States, or NAM5, I'm going to create the database. This takes a couple of minutes, so I'm going to go ahead and pause the video, and I'll see you on the other side. Notice that our database is ready to go, but it's empty, okay? And we're going to have two different types of queries, query by kind or query using GQL. We'll see both, but let's go ahead and create an entity. We're going to stick with the default namespace, and for the kind, we're going to say this is a task. We'll stick with the auto-generated numeric ID as our key identifier, and then we're going to add some properties. The first property, think of this as a column in a table, okay? So the first property we'll say is description. It's going to be a type of string. Notice our different data types here: string, data and time, integer, floating point number, Boolean, key, geopoint, array, embedded entity, null, and text, okay? These are the options we have for a document database. We're going to choose string, and we're going to say the value is learn Google Cloud Data Store. We do not want to index this property, okay? So we're going to deselect that and say done. Let's add another property. This is going to be a property called created. It's going to be a date and time, so we'll say date and time, and of course we'll stick with this value right here, the date being March 18th, 2019, 5:07 p.m. Central Standard Time. We're going to index this property and click on done. We'll add one more property. We'll say done, okay, and it's going to be a Boolean, okay, so is it done or not, okay? We could say finished or complete, whatever, but we're going to go ahead and choose Boolean and give it a default value of false, and we want to index the property, and we're done there. So we've got our namespace. We're just sticking with the default. The kind is a task, and we've got three properties. Click on the create button. So we've just stored some data in the Cloud Data Store. Let's run a query, okay? And we can do querying by kind, or we can do query using the Google Query Language, the GQL. We're going to query by kind. We already see in here task, okay? So we can choose that option, which is there by default. Let's click on filter entities. And let's say that this property done is equal to false, okay? If we apply the filter, we'll see here's an entry, here's a result. Now if we change that to done is true, and we apply the filter, we're going to have no match to that query, right? If we say the property is created after, apply filter, no match. If we say before and apply filter, we're going to get a result. Now we can also query by GCL. Let's click on that, query by GCL. And let's try one. Looks a lot like SQL, doesn't it? Okay, so we're going to say select. One thing about NoSQL or NoSQL, it doesn't really mean you can't use SQL query language. It means not only SQL, really, okay, when it gets right down to it. So we're going to say we're going to select all from task and run the query. And there's our result. Now notice that this is case sensitive. So if I say select from task and I do it all lowercase, I'm not going to get an entity matching that query. Let's try one more. Let's say we're going to select all from task. Well, it's case sensitive, so we'll put capital T in there, where done equals false. Run the query, get a result. We change that to done equals true. We're obviously going to see no result to our query. All right. Now, if you're using Qwiklabs, and I highly recommend that you do, it's a great investment. I think you get a lot of bang for your buck, and that's why I'm using it, because I'll have students out there that are going to work along with me to learn this and pass the exam. I want to recommend kind of a more intermediate to advanced level exercise that's using Cloud Data Store. It's also involving Python as well. Now this is in the app dev, so you're not really going to have to worry about this type of thing on the exam, but it will take you one step further. And if you have some programming skills, some Python skills, this will be a great exercise. So go up to Qwiklabs and do GSP 184, okay? Basically, there's a quiz application skeleton that's already been written for you, okay? So you're going to use DataStore to store data for an online quiz. You'll also configure the application to retrieve from DataStore and display the data in the quiz. So you'll clone the repository that has this skeleton. You'll use Google Cloud Shell for that. You'll review the code using the shell editor. You'll view it in the Cloud Shell Web Preview feature, and then you'll modify that Python code that stores data to use Cloud Data Store. So this is your homework assignment. If you so choose, go one step further in the app dev area by storing application data in Cloud Data Store using the Python language. Google Cloud Storage is object-based storage that scales massively and is accessible all over the world. It's perfect for website content, audio and video files, archival data, disaster recovery solutions, or simply making large data objects available for upload and download through a handy URL. In this demo, which is based on QuickLab GSP073 and GSP074, I'll create a bucket, upload objects, create folders and subfolders, and then make them accessible to the public. I'll use both the console and the command line. Alrighty, I'm at my dashboard, and I want to go up to the navigation menu, and I'm going to come down here under Storage, choose Storage Browser, and we're going to create a bucket. Now, notice, by the way, a couple things for the exam that you need to know. You need to know these different types of storage class options, so make sure you review that for the exam. Remember, there's 4 of them: multi-regional, regional, nearline, and cold line. Cold line is the equivalent of Amazon Web Services Glacier feature. When we click on Create Bucket button, also remember that there's quite a few different rules for naming your bucket. For example, don't include sensitive information, only lowercase letters, numbers, dashes, underscores, and dots. Names containing dots require verification. You have to start or end with a number or letter. It can't begin with GOOG or Google or any close misspellings of Google. I'm going to click on Upload Files and get some files in here. In my pictures, here's an old picture of me back in the 90s when I was in my alt-rock band. Okay, upload complete. We'll close that out. I can now see the image listed in the buckets list, bandpick.jpg, not public, with a Google managed key, and there's no retention policy. I'm going to select this and delete it. Let's upload the file again. I'm going to rename the file. Go into the 3 dots down there, click on Rename, and I'll call this My Band Pick. If I want to create a publicly accessible URL for My Band Pick, I'll go back to the 3 vertical dots down here, and I'll edit permissions. Click on Add Item, and I'm going to say for entity, I'm going to choose User. I'm going to say All Users, and we'll make sure it says Reader Access, not Owner, and then click on Save. We should see this little link icon here that means it's publicly accessible or shared publicly. Click on that link, and there it is. All right, let's go back here. We can also create folders. So I'll click on Create Folder. I'll just call it Folder 1 and Create. And I can go open up Folder 1, and obviously I can upload a file to that. We'll use that same band pick. And of course, I could go and set the permissions, and I could make that public as well. If I want to delete the folder, I just go back up 1 level, choose the folder, and then delete the folder. Google BigQuery is a data warehouse service that enables super fast SQL queries using GCP's infrastructure processing power. You can also manage access to both your project and your data based on your specific needs. For example, giving other team members the ability to view or query your data. We can access BigQuery using a web UI, a command line tool, or by making calls to the BigQuery REST API using libraries like Java, .NET, or Python. There are also a plethora of third-party tools that we can use to interact with BigQuery for loading or visualizing the data. In this demo, based on QuickLab's GSP 406 and GSP 160, we'll query a public data set, create a custom table, load data into the table, and then query that table and more. Now, I mentioned in the introduction there were several ways to actually access BigQuery. We're going to look at the BigQuery console because it's an interface that we can use to query tables, and that includes some of the public data sets that are offered by BigQuery. So in this lab demonstration, we're going to query the US Name Data public data set to find out the most common names in the United States between 1910 and 2013. Chances are one of them is Michael. Okay, so let's go ahead and go to the navigation menu. We want to go down to Big Data. So past the storage area, past the tools to Big Data, and we see BigQuery on the menu. We're going to see Welcome to BigQuery, basically telling us that the UI allows us to complete tasks like running queries, loading data, and even creating and training machine learning models. And they give you a link to the Quick Start Guide. I'm going to click on Done. I'm going to paste this SQL information into the query field, selecting name and gender, summing it up as a total from this BigQuery names from 1910 to 2013, group them by name and gender, order them descending, and we'll limit it to 10. Notice, by the way, we have a query validator. This query will process 99.9 megabytes when run. Tells us it's valid. If it's invalid, we'll see a red exclamation point. We'll click on Run. We can see our results at the bottom, okay? And we can see, I wasn't lying, Michael, number 4 on the list. My middle name is number 1 on the list, okay? So my name is Michael James. So, hey, I'm very common, okay? We can see the results here. We can also see it in JSON format, okay? If you're into that, JSON format. Next, we're going to create a custom table. And what I'm going to do is I'm going to download a file from the QuickLab, and it's 7 megabytes of data about popular baby names from the Social Security Administration. So I've downloaded this file to my local computer, and I've unzipped it. It's got a national readme.pdf that has the data set, and I need to open a file named yob2014.txt. I have this names on my desktop here. I'm going to look for yob2014.txt. So take a look at that. Most popular baby name of 2014 was Emma. So I'm going to create a data set to hold my table. I'm going to add some data to my project, and then we'll make the data table that we'll query against. Data sets allow us to control access to tables and views in a project. We're only going to use one table, but we still need a data set to hold that table. I'm going to go over here and I'm going to create a data set. We'll call this baby names. Data location, we'll say in the United States. And we'll leave the default table expiration to the default of 60 days. And then we'll go to the bottom here and click on Create Data Set. I'm going to type in here and search for it. There we go. Baby names. Let's create a table. Create a table from, and we'll say we're going to upload. We're going to browse, go to the desktop, and get that 2014 file. Let's choose for the file format, we're going to choose CSV. For the table names, we'll call this Names 2014. In the Schema section, we're going to click this Edit as Text toggle, and I'm going to paste a schema definition in here. And then we'll click on Create Table. We're going to wait for BigQuery to create this table, and we're going to load the data. You can see it's showing up here, Names 2014. I'm going to click on Names 2014 here. Here's the schema, okay, name, gender, and count, the type, the details, the information, and then here's preview. So now we've loaded data into our table, we can now run queries against it. And so let's just go up, paste that query in there. So we're going to get the top 5 male baby names from 2014, and we'll run it. And we can see that the most popular name from 2014 was Noah, then Liam, Mason, Jacob, and then number 5, William. Okay, I'm back over at the dashboard. I'm going to go back up to navigation menu, and we're going to come down towards the bottom, and we're going to access Big Data, BigQuery again. Click on Done. This time I'm going to go back over to Resources and click on the Add Data button, and I'm going to choose Explore Public Data Sets. Notice that we have a ton of different categories of data sets that we can look at, and we can run a whole wide variety of SQL or Google BigQuery statements against. Advertising categories, for example, we've got climate, we have economics, encyclopedic, finance, health, there's science and research, a bunch of those, okay? I'm going to go up here and search BigQuery public data, and then I want to look for, within this category, NCAA. Let's get out of there. There we go. NCAA basketball. By the way, this data set contains data about NCAA basketball games, teams, and players, okay, all the way back to play-by-play and box scores back to 2009, final scores back to 1996, additional win-loss data back to the 1894-1895 season in some cases. First thing I want to query is the men's NCAA game results table. So I'm going to go over here and expand this out, go down to the NCAA basketball area, and I'm looking for MBB underscore teams, games underscore SR, okay? And you can see here's the schema of this table. There's quite a few columns in this table, okay? And the details. If we go down, we can also see that the table size is over 95 megabytes, and there's almost 60,000 records or rows in this. Okay, let's do this statement to see what type of events, types of basketball play events. We'll click on Run. You can see here we've got, look at all those: rebound, 2-point miss, turnover, 2-point made. Okay, so we can see there's 291,935 3-point misses, 134,256 free throw misses. Okay, that's interesting. Let's see which 5 games had the most 3 points made. Click on Compose New Query. We'll copy and paste that in there. Okay, and we can also, remember, we can also do the validator. It's valid. Click on Run. And we can see that there's the top 5 games. So on November 18th, 2016, the Middle Georgia Knights attempted 38 3-pointers. They made 16. The Savannah State Tigers, they attempted 52, and they made 24. So here's one that you have 51% down here. That's pretty good. Okay, so let's do one more. What 5 basketball venues have the highest seating capacity? I'll compose a new query, paste that in there. Venue name, venue capacity, venue city, venue state. We'll run that. And let's see. Oh, the top 5. Interesting. I've actually been to 3 of these 5. Okay, AT&T Stadium. That's Jerry World, where the Dallas Cowboy plays. 80,000 in Arlington, Texas. University of Phoenix Stadium. I've been there. Used to live in Arizona. 72,220 in Glendale. NRG Stadium in Houston, over 70,000. I have not been to the Georgia Dome, but I look forward to going there. Have not been to Lucas Oil Stadium. So I'd like to recommend that you take some time to go over to this Resources Add Data area, go explore the public data sets, and just play around with some SQL statements, all these different categories. And also don't forget that earlier in this course, you installed the Google Cloud SDK, which has the BQ tool. You can use BQ in the command line to also formulate your queries against Google BigQuery as well. Cloud Spanner is a fully managed relational database service that offers mission-critical transactional consistency on a global scale. Cloud Spanner is great for relational, structured, and semi-structured data that requires high availability, strong consistency, and transactional reads and writes. This demo shows you how to create a Cloud Spanner instance, database, and table. We'll also add a schema, write and modify data, and then run a query. All right, let's take a brief look at Cloud Spanner. We're going to go up to the navigation menu. We're going to go down to the storage area, and we're going to find Spanner. We're going to click on that. And we're going to get a reminder that Cloud Spanner is a fully managed mission-critical relational database. Okay, it gives us transactional consistency at a global scale, offers traditional relational semantics like schemas, like ACID transactions. Remember, atomicity, which means that database modifications must follow an all or nothing rule. Consistency, where only valid data can be written to the database. Isolation, which means that you have to have multiple transactions occurring at the same time, and they don't impact each other's execution. And D, durability. Any transaction committed to the database will not be lost. We'll click on Create an Instance. We're going to call this Test Instance. Choose a configuration. Basically determines where the nodes and data are located. You can do regional or multi-region. We'll stick with regional, and we'll click on the drop-down, and we're going to choose US Central 1. We can add additional nodes to increase data throughput and queries per second. That will affect our billing. We can also review our costs, 90 cents per hour for the node cost, 30 cents per gigabyte per month for storage. We'll click on Create. All right, so let's click on Create Database. Call this Sample DB. Click on Continue. We're going to go ahead and skip the Define Your Database schema for now and click on Create. Now, when we're using the Cloud Platform Console, there's two ways we can create and change and delete tables and indexes in a database. We can use the default database editor, or we can switch the editor to the Edit as Text mode and enter SQL statements in the Cloud Spanner data definition language syntax. We're going to use DDL. So we're going to click on Create Table, click on the Edit as Text toggle. There we go. I'm going to paste in there my DDL, creating a table called Singers. You can see that the schema involves several columns or attributes: singer ID, first name, last name, singer info, and birth date. Click on Create. This might take a few minutes, so I'm going to go ahead and pause, and I'll catch you up when it's done. Okay, so it's done. Click on Data. We're going to insert some data. So let's skip the birth date, and I'm a singer, so I'll put Mike Shannon. I'll leave that empty. Oh, I need an ID, so let's do 01. Insert another one. 2. Addison Ash. Save. And then we'll do one more, and we'll say this singer just has one name, like, Madonna. We'll say it's Mensa, with a $sign, something clever like that. All right, and then we'll save that. We now have 3 rows in our table. We can edit. We'll just select Mensa, and we'll edit. Give them a birth date, say 1991-12/7, and we'll save that. Let's say I want to delete myself as a singer. Select myself, delete, okay. I'm going to go back up here and click on Sample DB. I can run a query, and we'll just say select all from singers, and run the query. All right. Google Cloud PubSub is a messaging service for exchanging event data among various applications and services. PubSub allows for secure and highly available communication between independently written applications by decoupling the senders from the receivers. It delivers low latency and durable messaging, and it's commonly used by developers for implementing asynchronous workflows, distributing event notifications, and streaming data from different processes or devices. You can also perform these actions in Quick Labs in GSP 095 and GSP 096. Let's learn the basics of PubSub. Okay, like I said in the introduction, Google Cloud PubSub is an asynchronous global messaging service. It corresponds to Amazon Web Services SNS, Simple Notification Service. And there's three terms that we need to be aware of: topics, publishing, and subscribing. A topic is basically a shared string that lets applications connect with each other using a common thread. Publishers will publish or push a message to a Cloud SubHub topic. Then subscribers make a subscription to that thread, where they either pull messages from the topic or they can configure webhooks for push subscriptions. Each subscriber must acknowledge each message in a particular time window, which is configurable. So basically, a publisher creates and sends message to a topic, and a subscriber creates a subscription to the topic and receives messages from it. Now we're going to start out in the Cloud Shell first, and then we'll look at Cloud PubSub in the console. And PubSub comes pre-installed in the Google Cloud Shell, so we don't have to install anything or do any pre-configuration. But I do want to go to full screen. So first, let's run this command to create a topic called My Topic. It'll be gcloud pubsub topics, not topic, but topics, create, and then we're going to call this My Topic. I'm going to go ahead and create a couple more. Test 1 we'll create, and then we'll create test 2. Next, we'll do a gcloud pubsub topics, and then we'll list that. We should see 3 topics here. Test 1, test 2, My Topic. If you want to delete one, let's say you want to delete test 2. So run the command again to list it, and we'll see only 2 topics. Okay, so now we can create, we can view, we can delete topics. We need to do subscriptions. This command right here, gcloud pubsub subscriptions create, is creating a subscription called My Subscription to the topic My Topic. I'm going to run this command to create a test 1 subscription. I deleted test 2, so I can't do that. Let's double check our subscriptions. Subscriptions, My Subscription, subscriptions, test 1. Let's go ahead and delete a subscription this time. gcloud pubsub subscriptions delete test 1. We'll list them, and we just have the 1. All right, so you know how to create, view, and delete subscriptions. Let's publish a message to a PubSub topic. I'm going to publish a message to My Topic. The message is hello. Let's publish a few more messages. Topic, publisher's name is Michael. Publisher likes to eat Thai and Mexican food. Not at the same time, but I like spicy food. We'll do one more, and as the kids say, publisher thinks PubSub is lit. Okay, let's use the pull command to get the messages from our topic. It's subscription based, and it should work because earlier we set up a subscription, My Subscription, to the topic My Topic. So we got gcloud pubsub subscriptions pull My Subscription and then auto acknowledgement, and we can see some output. publisher's name is Michael. Now we published several messages, I think 4 of them, to our topic, but we're only seeing one outputted. Well, there's a couple things about the pull command that we need to be aware of. Using the pull command without any flags will output only one message, even if you're subscribed to a topic that has more data held in it. And then once an individual message has been outputted from a certain subscription-based pull command, you can't access that message again with the pull command. So if we try running it again, we see publisher likes to eat Thai and Mexican food. Do it again. Hello, that's the original one, and then we'll do it one more time. Publisher thinks pub sub is lit. If we do it one more time, it tells us listed 0 items. We're getting this output because there's nothing left to return. Now, since all the messages have been pulled from our topic, let's go ahead and populate my topic with some more messages. We'll say publisher starting to get the hang of PubSub. Publisher wonders if all messages will be pulled. And finally, we'll paste in publisher will have to test to find out. Okay, so this time, let's add another flag to our message. I'm going to scroll up to that command. Remember, gcloud publish subscriptions pull. And we're going to add another flag on there to AutoAC. We're going to do limit equals 3 and then hit enter. Well, I was hoping to see 3 messages, but I only got 2, but you get the idea. So now you learned how to add flags to the command to output larger pools of messages. Let's go take a look at PubSub in the graphical console. Okay, let's go to the navigation menu. We're going to move down towards the bottom where we're going to see under Big Data, PubSub. We're going to choose Topics. Create a topic, and we'll call this My Topic, and create. So we have a topic. Let's click on the little 3 buttons here, and let's choose a new subscription, and we'll call this My Sub. You can pull it or you can push it. We're going to keep the pull, which is the default. There's a subscription expiration, so we can choose between 1 and 365 days, or we could say never expire. Okay, I'm going to stay with that option. You also can have an acknowledgement deadline from 10 seconds to 600 seconds, also a message retention duration of 10 minutes to 7 days, and you can also retain acknowledged messages by clicking on the checkbox. I'm going to leave everything at the default and click on Create, and I would have this under Subscriptions, by the way. You can see it there. Go back to my topic, click on the 3 buttons, and publish a message. That's hard to say fast 3 times. Try that. Hard to say that fast 3 times. Okay. You can also add tags or metadata to that, but I'm going to go ahead and just click on Publish. And let's bring up my Cloud Shell. Start the Cloud Shell, and we'll just paste that message in there. gcloud PubSub subscriptions pull AutoAC My Sub, and there it is. Hard to say that fast 3 times. So obviously much quicker, much easier to do in the console. What about snapshots? Let's click on that. A snapshot captures the message acknowledgement state of a subscription at a given time. Just remember that fact about a PubSub snapshot in case they ask you that on the exam. Cloud Bigtable is Google's NoSQL big data database product. It's the same database that powers a lot of core Google services, including Search, Analytics, Maps, and Gmail. A large number of organizations leverage this powerful service as well. In this demo, you'll learn how to use the HBase shell to connect to a Cloud Bigtable instance and then read and write data in a table. Then we'll connect with the console and perform some similar activities. All right, let's create a Cloud Bigtable instance. We'll go up to the navigation menu. We're going to go down to Storage here. I'm going to go to Bigtable and click on Bigtable. It's going to remind us that this is a fully managed NoSQL database supporting popular open source Apache HBase 1.0 API. Click on Create Instance. We'll call this Quick Start Instance. It'll give us a permanent instance ID. We're going to switch from the production recommended instance type to development. You can see some cost estimates over here. And I'm going to choose SSD for lower latency and more rows read per second, even though hard disk drives are cheaper. Go to the cluster ID area down here. We're going to choose a region. And I'm going to choose US East 1 and a zone, US East 1C. Notice that if we were to go with the production instance type down here at the bottom, we could add a second cluster automatically replicating all data between clusters. I'm going to just click on Create. There's my Quick Start instance of Bigtable. I'm going to go up here now and activate the Cloud Shell. Okay, I need to clone the GitHub repository that has the HBase shell Quick Start setup scripts. So let me copy and paste that in there. It's going to be Cloud Bigtable Examples. Okay, if you notice that. So we'll hit Enter. So the repository has been cloned to the Cloud Bigtable Examples directory. Let's get into that directory. CD Quick Start, and we'll start the HBase shell dot / quickstart.sh. A couple of errors probably. We'll ignore those. This will take a little bit of time, so I'm going to pause my recording and we'll catch up when it's done. That actually took quite a bit of time, okay, several minutes, but we're at the prompt. We're at the HBase prompt. Now realize that Cloud Bigtable stores data in tables. That makes sense. Okay, these tables contain rows, and each row has a row key. Data in a row is organized into column families, or basically groups of columns, and then there's a column qualifier that identifies a single column within the column family. An intersection of a row and a column is called a cell, just like in a spreadsheet, and each cell can contain multiple versions of a value. So let's create a table called myTable. Issue the command create, single quote, my-table, and then comma, and then single quote CF1. That's the column family 1. Okay, 0 rows in 2.4 seconds. We can just list. Let's put a value in the row R1. We'll put, and we'll call this myTable. We'll put myTable in row 1, column family 1, column 1, and then we'll call this test value. Let's go ahead and scan myTable. 1 row. And finally, we'll delete the table, myTable. We'll say disable myTable, and then we'll drop myTable. All right, good job. You set up your first NoSQL database in Bigtable. You stored data, and you retrieved data from it, and then you deleted the table. Let's go ahead and look at Bigtable from the command line now. Okay, I'm back in Cloud Shell. I need to configure Cloud Bigtable to use my project and instance. So I need to modify a .cbtrc file, replace it with my project ID. So let me do that real quick. And then one more command, echo instance. Okay, now I can use the Cloud Bigtable command. So let's create a table with cbt. Also remember for the exam that this is going to be the command we use in the console for Cloud Bigtable. Okay, we just saw the HBase prompt earlier, so be aware of those two things for the exam. So we're going to say create table, myTable. Let's go ahead and do CBT ls to list it. There's my table. Let's add a column. CBT create family CF1. Let's list our column families with CBT ls my table. There's CF1. Let's put a value in the row R1 using the column family CF1 and the column qualifier C1. CBT set my table R1 CF1 colon C1 equals test dash value. Let's read the data with CBT read my table. All right, well, let's finish this up by just using the CBT command, Cloud Big Table, to delete table, my table. All right, so you've worked with Cloud Big Table in both the HBase prompt and in the console using CBT. Cloud Dataproc, or DataPros as some call it, is a managed service that empowers you to leverage open source Spark and Hadoop data tools for batch processing, querying, streaming, and machine learning. Cloud Dataproc automation allows you to create clusters rapidly, easily manage them, and lower cost by turning clusters off and on when you need them and not need them. You would consider using Cloud Dataproc or DataPros to scale out compute-intensive jobs that meet several characteristics. One, the job is highly parallel in the sense that you can process different subsets of the data on different machines. Or two, you already have Apache Spark code that performs the computation, or you're familiar with Apache Spark. And third, the distribution of the work is consistent across your data subsets. Let's dive into this service and finish up seeing the results in the AI ML Vision API. Okay, this demonstration is based on QuickLab's GSP 010, Distributed Image Processing in Cloud Dataproc, or DataPros, if you want to make pros short for processing. The first thing we have to do is create a virtual machine that hosts the services, so a development machine in Compute Engine. So I want to go to the navigation menu, go to Compute Engine, and we'll go to VM Instances, and we will create. We're going to call this dev host, US Central 1, US Central 1, and then we're going to give it 2 virtual CPUs. We're going to come down and say allow full access to all cloud APIs and click on create. This is going to be our development bastion host or jump host. Okay, let's click on VM instances. Okay, so I'm going to secure shell into this. Now we need to set up some software to run the job, so we're going to use SBT, which is an open source build tool. We'll build the jar for the job and we'll submit to the Cloud Dataproc cluster. The jar will have the program and the necessary packages to run the job. Basically, the job is going to detect faces in a set of image files that are stored in Google Cloud Storage buckets. Then it'll write out image files with the faces outlined to either the same or to another cloud bucket. So we need to install Scala and SBT so we can compile the code. So let me go ahead and copy and paste these commands in here. There's a bunch of sudo commands, sudo apt-get commands, sudo apt-key commands that I need to get this going. We'll do an update. We'll do an install-y apt transport HTTPS. Let's update again. And then finally, we need to get and install Scala and SBT. That took a while, so I went ahead and paused again. Next, you want to configure the feature detector files. So we're going to build these. Code is in the Cloud Dataproc repository on GitHub. So we're going to, let's go ahead and run this command again. Then we want to clone the repository. Git clone, and then there's the URL. And then now let's change over to that directory. So we're going to build what's called a fat jar. of the feature detector. So we can submit this to Cloud Dataproc. So we're going to say SBT assembly. Okay, that took a while, but our feature detector files are built. Let's create a cloud storage bucket and add some sample images to it. Okay, let's try that again. Had to go in and actually use a different bucket name, -01. There we go. I was using my bucket as the bucket name, and it needed to be an actual unique bucket name. So let's go ahead and download some sample images into the bucket. We're going to create a Cloud Dataproc cluster. So this first command, creating a variable. Okay, so my cluster will be clust-dpc-01. Next, we'll set a GCE default zone and create a new cluster. This might take a couple of minutes. Okay, so we're going to be using a face detector program, remember? So the inputted HAR, H-A-A-R classifier has to describe a face. This is basically an XML file that's used to describe features that our application will detect. So we're going to download the HAR classifier file, and then we'll include its GCS path in the first argument. So let's go ahead and paste this in here, along with my bucket name. Now we're going to use the set of images we uploaded into the images directory in our GCS bucket as input to the feature detector program. We have to include the path to that directory as the second argument of the job submission command. Okay, so you can see I submitted the job with the gcloud dataproc job submit. Got my cluster names and bucket names in there. I'm going to go over to the navigation menu again and go down to Dataproc Jobs, and we should see our completed job there. There it is. If we go up to Storage, we should see our bucket. Let's go to Dataproc, and we're going to go to in the Images folder, we see our images there. Those are the 3 images. And then we'll go to this Out folder, click on an image, family of 3. There we go. So the image has downloaded to my computer. So how accurate is the face detection? Well, the Vision API is a better method. So I'm back in the Images folder. I'm going to download these. Okay, so I went to the Vision API page and navigated to Cloud Vision. I'm going to try the API. So I'm going to browse pictures from my computer. Here's family of 3. Open that. I'm not a robot. So we can see Joy, very likely. Okay, pretty cool. Let's try it again with a different picture. See how this, again, very likely for Joy. And one more time, we'll get the African woman. I'm not a robot. And it says headwear, very likely. That's interesting. Okay. All right. So there's our demonstration of distributed image processing in Cloud Dataproc and also using the Vision API, which is an AI machine learning product from Google Cloud Platform. Lesson 10, Deploying and Implementing Networking Services. We'll begin creating a VPC with subnets, followed by creating firewall rules for a VPC. Next, we'll look at testing network latency and performance, followed by 2 parts, creating a virtual private network part 1 and creating a virtual private network part 2. Next, we'll look at examining dynamic routes, then compare and create load balancers, and we'll finish up setting up a private Kubernetes cluster. This is the first of several demonstrations of networking fundamentals on GCP. First, I'll discuss networks and subnetworks. Then I'll create several custom VPC networks, both in the console, then in Cloud Shell. Okay, so I'm in the VPC network or VPC networks area. I got here by going to the navigation menu and then coming down here to the networking area and choosing VPC network. Let's talk about networks for a second. These are going to directly connect your resources to each other within Google Cloud Platform and to the outside world. Networks will house the access policies for incoming and outgoing connections by using firewalls. Also realize that networks can be global, which gives you horizontal scalability over multiple regions, or they can be regional, which is going to give you low latency performance within a single region. Subnetworks let you group related resources like compute engine instances into RFC 1918 private address spaces. Subnetworks can only be regional, and a subnetwork can be an auto mode network, which has one subnet per region, each with a predetermined IP range and gateway, or a custom mode network, which has no subnets at creation. To create an instance in custom mode network, you must first create a subnetwork in that region and then designate its IP range. A custom mode network can have 0, 1, or many subnets per region. Now, when you create a new project, you have a default network configuration within that region with an auto subnet network. And that's what we're looking at here. So for example, here's US East 1. You can create up to 4 additional networks in a project. Additional networks can be auto subnet networks, custom subnet networks, or in some rare circumstances, legacy networks. Each instance created within a subnetwork is assigned an IPv4 address from that subnetwork range. Also realize that each network has a default firewall that blocks all inbound traffic to the instances. To allow traffic to come into an instance, you have to create allow rules, or you have to whitelist for the firewall. In addition, the default firewall will allow traffic from instances unless you configure it to block outbound connections using an egress firewall configuration. So by default, you can create allow rules for the traffic you want to pass inbound or ingress, and deny rules for traffic you want to restrict outbound or egress. You may also generate a default deny policy for egress and prohibit external connections altogether. Generally speaking, Google recommends that you configure the least permissive firewall rule that will support the type of traffic you're trying to pass. Also, all networks have routes created automatically to the internet. That's a default route. Let's click on firewall rules here. And it reminds us that firewall rules control incoming or outgoing traffic to an instance, and by default, incoming traffic from the outside to your network is blocked. So here's our default firewall rules: ICMP, allowing internal, RDP, and secure shell. Let's click on routes. All networks have routes generated automatically to the internet, that's the default route, and to IP ranges in the network. The route names are typically generated and will look different for each project. Let's go ahead and create a custom network with the console. Let's go back up here to VPC Networks and choose Create VPC Network. I'm going to call this My Custom Network. Here we can see we've got custom or automatic subnets. Let's call this subnet US Central. The region we'll say is US Central 1. And the IP address range 10.0.0.0/16. Let's add another subnet. We'll call this subnet Europe West. And we'll choose Europe West 1 for our region. Make this 10.1.0.0/16. We'll add a new one. Call this subnet-Asia-East, and we'll make this Asia east 1. And that'll be 10.2.0.0/16. When we're done, we'll scroll down and click on the Create button. Now at this point, the network doesn't have any routes to the internet and to any instances that we might create. But it does have firewall rules that allow access to instances, even from other instances. So we have to create firewall rules to allow access. Now we're going to do firewall rules in the next lesson, but let's go ahead and create a custom network with Cloud Shell. Okay, so I've entered the command gcloud compute networks create. This custom network is called TAW custom network, and the subnet mode is custom. It reminds us that instances on this network won't be reachable until firewall rules are generated. As an example, you could allow all internal traffic between instances, as well as secure shell, RDP, and ICMP by running the following two commands. Let's go ahead and create subnets for our new custom network. We're going to create 3 of them. There's US Central, 10.0.0.0/16. Let's do subnet Europe West at 10.1.0.0/16. And then finally, we'll create subnet Asia East at 10.2.0.0/16. Now at this point, the network does have routes to the internet and to any instances that I might generate, but it has no firewall rules that allows access to instances, even from other instances. So we have to create firewall rules to allow access, and we'll do that in the next lesson, lesson 10.2. And don't forget, you can do this yourself up at Quick Labs doing GSP 016. Every network has a default firewall that blocks all inbound traffic to VM instances. To permit traffic to come into an instance, you must create allow rules for the firewall. In other words, whitelisting. In this demonstration, based on GSP 016, I'll create a firewall first in the console and then several more in the Cloud Shell. Okay, as I mentioned before, to allow access to VM instances, we have to apply firewall rules. We're also going to use an instance tag to apply the firewall rule to our VM instances. That way, the firewall rule will apply to any VM that uses that same instance tag. Instance tags are used by networks and firewalls to apply certain firewall rules to tagged VM instances. For instance, if there are several instances that do the same task, such as serving up a large website, you could tag these instances with a shared word or a term and then use that particular term to allow HTTP access to those instances with a firewall rule. Tags are also reflected in the metadata server, so you can use them for applications running on your instances. We're going to start by opening the firewall to allow HTTP internet requests. Then we'll add some more firewall rules. So let's go up to the navigation menu and go to VPC Networking. Click on VPC Networks, and we should see our TAW custom network there. That's the one we just created in the command line. Notice we have subnets, we have static internal IP addresses, firewall rules, routes, VPC network peering, and private service connection. We're going to click on Firewall Rules and add a firewall rule. We're going to name this NW101-allow-HTTP. Notice we also can turn logging on or off. That'll involve Stackdriver. This is the TAW custom network. Target tags. Let's do HTTP here. Direction of traffic is ingress. Action on match is allow. We're going to specify the target tags of HTTP. Source filter is IP range. The source will be 0.0.0.0/0, which is also referred to as any. We're going to specify TCP port 80 and then click on Create. Okay, I want to create some additional firewall rules. For example, I want to allow ICMP. I want to allow internal communication. I want to allow secure shell and RDP. I could do that right here by just continuing to add firewall rules. But I have to use one method or the other, okay, the console or the Cloud Shell. Let's go into Cloud Shell and let's create some rules there. Okay, let's go ahead and create a rule. This one's going to be to allow ICMP, so gcloud compute firewall-rules create. Remember that command for the exam, okay? You'll need to remember that. You won't be configuring this in some type of demonstration, but you need to remember that command. And then we're going to name this NW101 allow ICMP. NW101, by the way, is what this is called in Qwiklabs. It's Networking 101. So we're going to allow ICMP. Our network is the Tau custom network, and then we're creating target tags called rules. Next, let's create a firewall rule called NW101 allow internal, and this is going to allow our internal communication, basically allowing all the TCP ports, all the UDP ports, and ICMP. Notice that the ranges of the IP addresses are the 10.0/16 network, the 10.1/16 network, and the 10.2/16 network. Let's go ahead and allow secure shell now. Again, gcloud compute firewall-rules create. We're allowing secure shell, port 22, on the same network, and we're tagging it with SSH. Finally, let's add RDP for our Windows instances. So we're going to do allow TCP 3389. All right, let's go back over to our VPC networks. Go to firewall rules, and we can see all the firewall rules that we created. Here's the one for the Tau custom network. Okay, we allowed HTTP. We did that one in the graphical interface, but these are the ones we just added in the Cloud Shell. The next obvious thing would be to do some testing. So in the next lesson, we'll actually create some VMs in each subnet and make sure that we can connect together. We'll also look at traceroute, performance testing, and iPerf. In this demo lab, I'll spin up 3 VM instances, one in each subnetwork, then use the ping, traceroute, and iPerf commands to perform some testing and diagnostics. I also want to encourage you to go up to Qwiklabs and do GSP 043, Networking 102 on your own to reinforce the concepts taught in these first 3 sub-lessons of Lesson 10. Okay, so I'm back in the Cloud Shell. I'm going to run these commands. I'm going to paste these in here. And I'm going to create an instance. I also want to make sure that when I do this, I'm going to document the external IP address. So when you do this yourself, make sure that you document that address. You'll need that for the testing. Notice, by the way, the tags that are here, SSH, HTTP, and rules, these are the same tags we designated when we created our firewall rules. My external IP address on US Test 01 is 146.148.89.246, and it's running. Let's do this again with Europe and Asia. So this is Europe Test 01. Again, notice the subnet, notice the zone, notice the tags. I'm also going to document this Europe IP address 34.76.203.217. Here's Asia Test 1. And the external IP address here is also 34 network, but it's 80.38.252. So I've got my 3 instances, my 3 VMs, each running in different subnets. Let's go back to the console, and I'm going to navigate up to the navigation menu and go to Compute Engine and go to VM Instances. And there we are. We can see our 3 instances. Let's go to US Test 1 and click on Secure Shell. And we're going to ping, and we're going to do -C for count. We'll do 3 of them. And then we're going to put in the IP address, which was 146.148.89.246. Let's go ahead and do it again for Europe, which was 34.76.203.217. And I'm pretty sure if US worked and Europe worked, that Asia will work as well. But let's go back here and just make sure 34.80.38.252. There we go. Notice, by the way, if we look, let's say, at Europe, which was 34.76.203.217, let's check out the latency from the US Central region to the Europe West region. So we're still on US Test 1. So let's go ahead and say we're going to ping -C3, and we'll say test 01. The latency is the round trip time, or the RTT. The minimum was 98.851. The average was 99.366. The maximum was 100.376. That's good information. We can also do traceroute. Traceroute is a tool that we can trace the path between 2 hosts. This could be helpful in finding network problems. To do this, I need to have the traceroute tools. So I'm still in the secure shell to US Test 1. So I'm going to go ahead and issue these commands. Sudo, you can see what they are here. Sudo apt-get update. Sudo apt-get -y install traceroute. Okay. I'm going to pause and we'll catch up when this is done. Okay, so we're going to do traceroute or traceroute www.icann.org, and you can see there's the paths. Okay, all the hops that we take, hop 1, hop 2, other places we hit till finally we get to icann.org. We can also see the minimum, average, and maximum round trip times. So this would allow you to find out if there was some place where it was failing along the path of one of those hops, or if there's extra congestion, for example, along that way. If you ever want to stop the trace, just do Control-C in the secure shell window. You can also test performance. So we can do iperf -s #run in server mode. And then let's go back to Europe and secure shell into Europe. I know what I forgot to install, so let's install all this stuff. Now let's go up and run that iperf command, the iperf command in client mode. There we go. So we can see some performance metrics there on port 53020, transferring 278 megabytes from Europe Test 01 to US Test 01, and 233 megabits per second. All right.
In this 2-part demonstration, I'll configure cloud routers using the Google Cloud Console. These cloud routers will implement VPN gateways configured with dynamic network discovery and eliminate the need to configure or maintain static routes. I will then be able to ping the internal IP of the VM in a newly discovered subnetwork through an auto-populated route. First off, I'll create 2 custom networks and spin up micro VMs in both. So let's get started.
Okay, so our scenario begins establishing a VPN between our headquarters, which will be our on-premise site in Belgium, well, let's say Brussels, and then a branch office or remote office
in the United States. So we're going to create 2 custom networks. They'll have subnetworks, and then we're going to spin up micro VMs in each one of these. And then ultimately, we'll also have Google Cloud routers as well. So let's go ahead and create our first network. So we'll go up to VPC Network on the main menu, navigation menu, and we'll go to VPC Networks and create a VPC network. Okay, we're going to call this GCP VPC. I'll just describe this as the US branch office. Always a good idea to have, descriptions and metadata. For subnets, we're going to say let's do a custom subnet as opposed to automatic subnet. We'll name this one subnet A or subnet-A. The region is going to be US East 1. And we'll give it the IP address range of 10.5.4.0/24. We'll leave off the private Google access, we'll leave off the flow logs, and we'll click on Done, and then Create. Let's do our second network. This is going to be our headquarters network, or we're going to call this on-prem. I'll just put HQ in there, HQ Brussels. Also be a custom network. We'll name this one Subnet B. The region is going to be Europe West 1, and the IP address range 10.1.3.0/24. Now, as you're going through this, whether you're doing this in your own GPC environment, whether you're doing this in QuickLabs, always make sure that as you go along the way that you document these IP address ranges. So remember, 10.1.3/24 is the internal network at the Brussels headquarters, okay? 10.5.4/24 that we saw a second ago, that's the internal network of the US East branch office. All right, so I'm going to click on Done and then Create. And now I've got a couple, you can see it's spinning up down there at the bottom. These should show up now in my VPC networks. I need to create some utility virtual machines or some utility VM instances, and the first one's going to be in the same region as the GCP VPC, and that's already established. So I can go ahead and just jump into the compute engine from the navigation menu and go to VM instances and create. This is going to be our GCP server. The region is going to be US East 1, which happens to be in South Carolina. The zone US East 1B. We want to go ahead and just do a micro. So micro, 600 megabytes of memory. And then scroll down to the management security disks networking, sole tenancy area. Okay. So we want to expand out that area. Quite a bit of things here that are really beyond the scope of this course and this exam. But we're going to click on networking right now. We want to come down to the network interfaces here, and we don't want this to be default. We want to click on this little edit pencil and expand this out, because the network is going to be the GCP VPC network. It's going to be subnet A, okay, 10.5.4/24. We'll keep everything else at the defaults. Click on Done, and then Create. So we're spinning up that instance. Let's go ahead and spin up our second instance, which is going to be at the Belgium headquarters. So we'll just go create another instance here. We'll call this on-prem 1. This is going to be in Europe West 1, Belgium. Zone Europe West 1B. We'll also do a micro VM here. Scroll down to the management security disks area. Click on networking. Go down to the network interfaces. Click on the pencil. And we want this to be not in the default network, but in the on-prem network. And then the subnet, it should be the subnet B. So we want to see 10.1.3, and click on Done, and click on Create. And I'm going to pause while this spins up. Okay, so we've got our 2 instances. You can see the zones that they're in. You can see we've got internal IP addresses of the internal networks. They also have external IP addresses assigned to them. So I'm going to document that right now. And I recommend that as you go along and you do this yourself, you go ahead and you document this as well. So I got GCP server. The external IP address is 35.231.141.251. And then on-prem 1 in Europe at the headquarters, that external IP address is 35.195.48.203. And if I go up and take a look at my VPC networks, I've got my two VPC networks out at the bottom, the on-prem network, Europe West 1 Subnet B, and GCP VC US East network in Subnet 1, all looking good. Okay, we need to create some firewall rules, and we're going to allow ICMP and Secure Shell into each one of these networks. So go back up to the navigation menu, go to VPC, Network, and go to Firewall Rules. There's my default firewall rules, but I'm going to go and create a firewall rule at the top here. I'm going to call this allow-ICMP-Secure Shell, and this is going to be for the GPC VPC. And I'll leave the description blank, but I don't want to do the default network, and don't make that mistake. Make sure you choose the GCP VPC network. We'll leave everything else the same. Priority, ingress, allow. Let's go down to source filter. We want to filter on IP ranges, okay, not source tags, not a service account. And we're going to say, let's just go ahead and allow everything or all 0.0.0.0/0 or all. Not a good idea in the real world, especially for management traffic. Okay, you'd like to reduce the attack surface or reduce the blast radius. So for managing, which is what Secure Shell and ICMP do, typically this would be a more selective range. But for the sake of this, we'll just say any, and we'll go down and we'll specify TCP port 22, and we'll say other protocols ICMP, and then we'll create. Oh, I forgot something. Okay, so for targets up here, it says specified target tags. We're not doing that. We're going to do all instances in the network. Okay, so that's why I got that error. So I want to make sure I choose all instances in the network, any IP range, port 22, and ICMP traffic. Now I can create it. Now while that's spinning up, let me go ahead and allow traffic to the on-prem or the Brussels network. So we'll create a firewall rule again. We'll call this allow ICMP-SSH-on-prem. The network is the on-prem network, right? This time I won't forget targets should be all instances in the network, and we'll do any again, and allow TCP/22 and other protocols ICMP. And we'll click on Create. Let's go back to Compute Engine, VM Instances. Okay, so I'm still waiting for my firewall to spin up. And so what we'll do is we'll stop part 1. And when we come back in part 2, we'll verify our network connectivity with Secure Shell. We'll talk about connectivity to the internal IPs and the external IPs, and then we'll create our cloud routers, and we'll finish up our VPN configuration. So I'll see you in part 2.
Okay, let's continue with our VPN demonstration as we test our connection, then create the cloud routers and VPN gateways with dynamic BGP routing.
Okay, so let's carry on with our VPN configuration. Again, I've got 2 VM instances that are running in 2 different VPCs. The GCP server is the US branch office, and the on-prem 1 instance is running at the headquarters in Brussels, Belgium. Let's test connectivity first from the GCP server, the branch office, to the headquarters. So on the GCP server, I'll click on Secure Shell. And so I'm going to do a ping. I'm going to do 4 of them. So I'll do -C4. And I want to see if I can first ping the external IP address of on-prem 1 or the headquarters. And I can see the external IP address is 35.195.48.203. And there we go. Okay, 4 of those. This should work. Now, what about the internal IP address? So what about 10.1.3.2? Well, if I try to ping that, this shouldn't work. but we'll try it anyway. 10.1.3.2, and that's not going to work, okay? Now eventually, once we get our VPN set up, we'll be able to ping that internal VM. But let's exit out of here. Next, let's test connectivity from the on-prem, okay, from the headquarters to that branch office. So we'll bring this down while it's connecting. I'm going to ping 4 of these, and I want to enter the GCP server, which is 35.231.141.251. Good. And again, if I tried to ping the internal server at 10.5.4.2 on the internal network, it's going to fail. I will exit. So why are we testing the GCP server to on-prem 1 and the on-prem 1 to GCP server? Well, this particular demonstration in this lab basically has 2 separate paths, okay? It has a path from subnet A to subnet B, and then a separate path from subnet B to subnet A. So we're using one tunnel to pass traffic in each direction. And if both tunnels aren't established, you can't ping the remote server on its internal IP address. It might reach the remote server, but the response can't return. So what we're going to do now is let's create our cloud routers. So we're going to go back up to the navigation menu. We want to go down to hybrid connectivity down here under the networking area, and we're going to choose cloud routers. Create router. The first one is going to be called GCP VPC-CR for cloud router. So obviously this is going to be the one at the branch office. So I could just put branch router. The network, it's in the GCP VPC network. It's in the US East 1 region. And then we'll choose a Google autonomous system number, and we'll choose 65,470. We're going to use this ASN with Border Gateway Protocol. Okay, so I'll click on Create. And this is a virtual router. Okay, let's go create another one. We'll call this On-Prem Cloud Router. This is the HQ router. The network is on-prem network. It's in the Europe West 1 region, and its autonomous system number for BGGP will be 65503. And then click on Create. Make sure you document those ASN numbers because you'll need those later when you set up the VPN gateways. Now, here's the deal. Each one of our gateways needs to have a static external IP address. So we're going to go ahead and create those, and we're going to make sure that we document those. Now remember, we have external IP addresses for our virtual machines, right, within the subnetworks, but these gateway routers need external IP addresses because these are going to be used in the actual VPN tunnels. So let's go to the navigation menu and go to VPC network at the bottom, and then external IP addresses. And let's reserve static addresses. Okay, so this one will be called GCP VPC IP. As you can see, been here before. And this is going to be branch router. Make sure that the type is regional, and then the region is US East 1. Got to be in the same region, and we'll say attached to none. So let's click on reserve to reserve that address. And let's reserve another static address, this time for on-prem IP, Europe West 1, same region, attached to none, and then reserve. There we go. We can now create our first VPN. So let's go up to the navigation menu and come down to hybrid connectivity, and then choose VPN and create our VPN connection. This is going to be called VPN1 by default. That's okay. Okay, so I'm just going to put branch in here, and the network is the GCP VPC network, US East 1, and the IP address is the GCP VPC IP address. And I'm going to document this. It's 35. I should have documented it already back on the other page, but just in case I can see it right here. Okay, if I want to go back to the reserve IP address page and make sure I document that, I need to do that. Okay, so this is the GCP VCP IP public address on my router, and then go down here to tunnels, and so here's tunnel, and I need the remote peer IP address. And so since I forgot to document that, I need to go back and get that real quick. And so there it is. I didn't write it down like I should have. 35.233.83.253. Gotta have that. So let's go back to my VPN now. Okay, so now I can put in the remote peer IP address. That's the other Brussels router at 35.233.83.253. Notice I have a choice between Ike version 1 and Ike version 2. This is something that makes actually the Google Cloud VPN superior to Amazon Web Services. At this point in time, AWS, for their site-to-site VPN, they only support Ike version 1. Now they're also going to use BGP, okay, like Google does. So it's the same kind of BGP setup. As a matter of fact, it's almost identical. They'll have a BGP router, they have a public IP address. They'll also use a tunnel address that's from the PIPA family. Okay, we'll see that here in a second. But they only support Ike version 1 at this point in time. Ike version 2 is faster, it's more secure, and it supports stronger crypto systems. I have to have a shared secret here, so I'm going to use GCP rocks, and this has to match on both sides. Okay, for routing, we're going to do dynamic BGP, and for cloud router, make sure I choose the GCP VPC cloud router. I want to go down to the BCP session area down here and click on this little pencil and edit this. So this is going to be the BGP from 1 to 2. I'm going to put in the peer ASN, which if you jotted this down, it's 65503. That's the other router's autonomous system number. We won't worry about this advanced advertised MED, which is part of BGP, but I'm going to go ahead and put in the cloud router BGP IP, which is going to be 169.254.0.1, and then the peer is 169.254.0.2. Now this is actually the logical tunnel that's being used between these two. Okay, so you've got a physical connection between those public IP addresses, right? 35.185.11.16 and 35.233.83.253, okay? But we have these logical BGP connections, and they use the PIPA IP addressing realm of 169.254. And by the way, this is exactly how Amazon Web Services does it as well. So I'll click on Save and Continue. Oh, I forgot the IP address. All right, and then click on Create. All right, let's create the second VPN. We can do that while that one's going. Click on Create. This is VPN 2. This is going to be at the headquarters. The network is on-prem. It's Europe West 1. The IP address is the on-prem IP address. The tunnel, the remote peer IP address, is 35.185.11.16. Ike version 2. The shared secret is GCP rocks, and then the dynamic BGP, and then the cloud router, on-premise cloud router, and then the BGP information. BGP 2 to 1. The peer ASN is 65,470. Hopefully you wrote that down. And then the cloud router BGP IP and the BGP peer IP will be the inverse of what we just configured. So the cloud router 169.254.0.2, so it's a mirror image 169.254.0.1, and then Save and Continue. And I can click on Create. It'll take several minutes for these VPNs to connect, and I'm looking hopefully for 2 green check marks. So I'm going to go ahead and pause the video, and when this is all done, we'll catch up and verify the connections. Okay, let's click on Google VPN tunnels. I can see that they're both established using dynamic BGP. For the sake of time, I'm just going to verify the connectivity from the branch office to on-prem 1. Okay, so let's go to Compute Engine under the navigation menu and go to VM instances. So let's go to Secure Shell from GCP server, and we'll just verify that we have the VPN that allows us to connect to the inside of on-premises. So we'll say ping, we'll do 3 of them, and we need to do the internal IP address of on-prem 1 in Europe West 1B. So it's 10.1.3.2, and there we go. All right.
In this demonstration, I'll use the exact VPN topology from the previous 2-part lessons and look at the behavior and importance of dynamic BGP routing.
Okay, to demonstrate dynamic routing, I went through and did the lab GSP 218 again one more time. And as you can see, I'm in the VPN area, and I've got 2 Google VPN tunnels. And you can see I've got VPN 1 and VPN 2. They have a Cloud VPN IP address and then a peer IP address. And again, we've used dynamic BGP as our routing type. And we have the VPN tunnel status as established, right? Which is what we're looking for. We got our 2 regions. Again, the on-premise is Europe West 1, that's Belgium. And then the remote network, GCP VPC, is US East 1, and that VM there. Let's go ahead and go up to the navigation menu now. And let's go to VPC network, and then the routes area. Now when we go in here, we're going to see all of these routes, and there's a bunch of default routes that are in there. If I just go to dynamic, that's going to filter out, and we're going to see 2 routes here. Notice we have 2 routes currently present. Destination IP range 10.1.3.0, so that's the internal address on the GCP VPC network. And then 10.5.4.0, that's the internal network on the on-prem network. Notice the next hop is that APIPA address that's being used by the BGP tunnel. So let's create a new subnetwork in the on-premises subnet C with a different IP address range. Then we'll launch a utility VM on-prem 2 in this new subnet. If BGP dynamic routing is working properly, then BGP will automatically discover the new subnet, and it should add it to our list of routes. Then we can ping on-prem 2's internal IP address from the GCP server. So let's click VPC Networks over here in the left-hand pane. Let's go down here to On-Prem and click on, at the bottom, the On-Prem. And let's click on the Add Subnet button. And we'll call this Subnet C. It's in the on-prem network. The region, we'll say, is Europe West 1. And then we'll put for the address range 10.4.2.0/24. And then we'll just click on Add. Just notice again we're in the same region as on-prem. Let's create a new utility VM in this new subnet C. So we'll go up to the navigation menu, Compute Engine, and then VM Instances. And we'll create an instance. Let's call this on-prem-2. The region, Europe West 1. Belgium, zone Europe West 1B, do a micro, go down to the management security disks networking sole tenancy, expand that out, click on networking, and then little pencil here to network interfaces, little edit, we'll click on that. The network is going to be the on-prem network, and subnetwork we want Subnet C. Keep everything else the same. Click on Done, and then click on Create. This will take a few seconds, so I'm going to pause the video. Okay, notice the internal IP address for on-prem 2 is 10.4.2.2, defaulting to NIC 0. Let's go to the GCP server and click on Secure Shell. And let's see if we can ping, and we'll do a count of 4 to on-prem 2's internal IP address, which is 10.4.2.2. If the ping fails, just go ahead and wait another 60 seconds or 90 seconds for those VPN tunnels to connect. So let's exit out of there. Hopefully, if we go back to the VPC network routes area, that there should be a new route dynamically added. So we'll cross our fingers, we'll go up to the navigation menu, go to VPC network, and then routes. Click on dynamic. All right, there we go. We have a new dynamic route, 10.4.2.0/24. And this is obviously the great benefit of doing cloud routing. If you do this on your own in GSP 218 at Qwiklabs, they'll tell you that, imagine you're in a situation where you have a complex campus network that's attached to another complex campus network, okay? And you've got each location maybe adding or removing multiple subnetworks on a daily basis. The good thing is these cloud routers will discover those topology changes and then propagate them to the peer routers automatically. Let's say you had 10 global campuses. We're doing this with Belgium and in the US, okay? But imagine you had 10 global campuses and each one of these adds or removes subnets. Well, you have to account for those in all of the other campuses. And by using dynamic BGP, you can build this full mesh dynamic topology, which can easily compensate for the changes. And this would be extremely difficult if we were using static routes. All right.
In this demo, you'll learn the difference between a Layer 3 network load balancer and a Layer 7 HTTP/HTTPS load balancer. We'll use the Google Cloud Shell exclusively in this demo as I set up these load balancers for your applications running on GCE virtual machines.
Well, as I said in the introduction, we're going to spend the entire time in this demonstration in the Google Cloud Shell. And I'm going to first do a gcloud config set. This is a command to remember for the exam. We're going to set our default zone. So compute/zone is US-central 1A. And the default region, I'll up arrow compute region US Central 1. Okay, so we're going to simulate having a cluster of machines. So we're going to generate a simple cluster of Nginx or Nginx web servers to serve static content. So we're going to use instance templates and managed instance groups. Instance templates are going to define the look of every virtual machine in the cluster, which includes the vCPUs, the vDisks, the vMemory, and so on. The managed instance groups will instantiate several virtual machine instances using that instance template. So we're going to use a startup script from the Qwiklabs lab 007, so GSP 007, if you want to do this yourself. So we'll have a startup script that'll be used by every virtual machine instance to set up the Nginx server upon startup, an instance template to use the startup script, a target pool, and a managed instance group using the instance template. So I'm going to copy and paste this script to set up the Nginx server upon startup. Next, I'll paste in an instance template that uses the startup script, gcloud compute instance-templates create. Next, we'll create a target pool. I'll just type this one in, gcloud compute target pools create Nginx pool. Okay, looking good. Now I'm going to paste in the gcloud compute code to create a managed instance group using the instance template. This is going to create two virtual machine instances with names that are prefixed with nginx dash. So nginx dash group and then nginx dash template. Let's see all the instances we've created with gcloud compute instances list. Next, I'm going to issue gcloud compute. I'm going to create firewall rules. And this is going to be a www-firewall, and we're going to allow TCP on port 80. and we'll catch up when this firewall is done being configured. Okay, I'm going to paste in the command to create a network load balancer. Now I'm going to spend more time talking about the application load balancer because it's much more common. Network load balancing lets you balance the load of your systems based on incoming IP protocol metadata, like the address and the port and the protocol type. You do get some options that are not available with HTTPS or HTTPS load balancing. So for instance, you could load balance additional TCP UDP based protocols like SMTP traffic, for example. And if your application's interested in TCP connection related characteristics, which it may be depending upon your service provider, then network load balancing could let your app inspect those packets. HTTP or HTTPS load balancing or application load balancing won't do that. So you can see I've issued the command here, gcloud compute forwarding rules create nginx-lb load balancer. You can see I've got the variables being the region, the ports, and the target pool, the nginx pool. You also want to take note of these external IP addresses up here. Okay, these external IP addresses are things that you could visit for the load balancers. Next, I want to create an HTTPS load balancer, but I want to bring up a diagram to kind of further explain what's going on. This is a very popular solution. Okay, HTTP or HTTPS load balancing provides global load balancing for your clear text HTTP and SSL TLS requests that are destined for your instances. And it's made up of several components, okay? So first you have a global forwarding rule, and the global forwarding rule actually directs incoming traffic requests to a target HTTP proxy. These will route the traffic based on IP address, port, and protocol, and the target HTTP proxy will check each request against a URL map. And the URL map determines the appropriate backend service for the request. You can see on the back end here we have two backend services and instance groups within those. So the backend service, which is after the URL map, will then direct each request to an appropriate backend based on attributes like the zone it's destined for, the serving capacity, for example. Maybe there's been an instance health and one of the backend instance groups is not healthy enough. So the backend instance is verified using a health check, an HTTP health check, or if it's SSL TLS, it'll be an HTTPS health check, or it could be HTTP2. And if it's configured for HTTPS or HTTP2, it'll be encrypted on its way to the backend instance. Now, if it's an HTTPS load balancer, it's basically the same kind of structure as HTTP. However, the HTTPS load balancer is going to require at least one signed SSL certificate installed on the target HTTPS proxy for the load balancer. Now, that's beyond the scope of this exam, but you can go and you can search for Google managed SSL certificates, or you can search for self-managed SSL certificates. So your clients out on the internet, for example, will communicate with the load balancer using the HTTP 1.1 or the HTTP/2 protocol. Now, if the client's using HTTPS, the modern client will default to HTTP/2. And this is controlled on the browser side, not on the load balancer. All right, so let's first create a health check. I'll just paste that in there for the sake of time. gcloud compute HTTP-health-checks create. Next, we'll define an HTTP service and map a port name to the relevant port for the instance group. So we're setting named ports to nginx group and the named ports to HTTP port 80. Next, let's create a backend service. gcloud compute backend-services create nginx-backend. Next, we'll add the instance group into the backend service. Notice we're using backend-services and then add-backend. This next command is going to create a default URL map. Okay, so these are all the components I just showed you in the diagram. The URL map directs all incoming requests to all of our instances. gcloud compute URL-maps create. We're calling it web map. Next, we're going to create a HTTP proxy that will route the request to our URL map. gcloud compute target-http-proxies create http-lb-proxy. We're going to parameterize that with the --URL-map called webmap that we just created. Next, we need a global forwarding rule that's going to handle and route incoming requests from those clients on the internet. The forwarding rule sends traffic to a specific target HTTP or HTTPS proxy. It depends upon the IP address, the IP protocol, and the designated port. It doesn't support multiple ports. So gcloud compute forwarding-rules create HTTP content rule. This could take several minutes, so I'm going to pause. Okay, so it's finished. We'll do a gcloud compute forwarding rules, and we'll list that. Okay, it's very important that you take note of the HTTP content rule IP address. Okay, so you can see HTTP content rule IP address. I'll jot that down: 35.201.65.251. And if I wait a few minutes, I should be able to open up a browser and go to that IP address. Okay, that took at least 5 minutes for that to cook, but finally I put in that IP address of the HTTP load balancer that we got from the forwarding rules, right? Forwarding rules list, 35.201.65.251. It says, welcome to Google Cloud Platform. If you see this page, then this web server is successfully installed and working, but of course, further configuration is required. All right, you just set up an application load balancer, specifically an HTTP load balancer in Google Cloud Platform using Google Cloud Shell. Excellent.
In this demonstration, we want to fulfill some exam requirements by first working with different ranges of classless interdomain routing, CIDR or CIDR addressing. In the Kubernetes Engine API, address ranges are expressed as CIDR blocks. We want to create a Kubernetes Engine private cluster that makes the master inaccessible from the public internet. In a private cluster, nodes do not have public IP addresses, only private addresses, so the workloads can run in an isolated sandbox environment.
Now, so far in these live lessons, we've basically almost always made our services or our web services or our components in GCP public using public IP addressing. But sometimes you want to work in a development environment and you really don't want to have any access to the internet. So for example, if you're developing in Kubernetes Engine, you want to work with a private cluster. A private cluster makes your master inaccessible from the public internet. So in the private cluster, the nodes don't have public IP addresses, only private addresses. So we basically want to run our workload in an isolated environment. So we're going to do that here. The first thing I have to do is I need to set the default zone. So I'm going to do gcloud config. Then we're going to set the compute zone to US Central 1A. When you create a private cluster, you have to specify a /28 CIDR or CIDR range for the VM instances that run the Kubernetes master components. Also, you need to enable IP aliases. So we're going to create a cluster here named private cluster. Now I'm going to use the commands from the lab, Quick Labs, which is GSP 178. However, some of the commands I'm using here from the Quick Lab have been deprecated, but for the sake of consistency, I'm going to go ahead and use these. Okay, so we're using gcloud container clusters, create, and it's called private-cluster. And we're using some flags. We're using the -- private cluster flag. We're using the -- master IPv4 CIDR. That's the one I mentioned. 172.16.0.16/28. So we have to specify that /28 CIDR range for our masters. And also we're doing enable IP alias and then -- create -subnetwork. And so you can see our cluster is being configured, and we'll pause until this is done. Notice, by the way, while this is still spinning up, that the -- private cluster flag is deprecated, and now you need to use from now on -- enable private nodes instead. So keep that in mind just in case it comes up on the exam. Also, you're going to want to have a notepad and a pen handy to take down some addressing that's going to be created for you automatically. You'll want to document that. Okay, private cluster has been created. Let's go ahead and list the subnets in the default network. So gcloud compute networks, subnets list, and then -- network default. And what I'm looking for is this one down here that says GKE private cluster subnet 217E2571. Okay, that's the one. And what I really want is that IP address. I'm going to jot that down. I'm also going to make sure I save the name of that cluster because I want to get information about the automatically created subnet. So I'm going to paste in this command, gcloud compute network subnets describe, and then there is my cluster name, and then -- region US Central 1. We can see the IP CIDR range there is 10.33.40.0/22. Notice that the secondary range down here, we have secondary IP ranges. We have one range, which is for the pods, 10.36.0.0/14, and then another range for the services, which is 10.33.0.0/20. And again, using different CIDR ranges like this is one of the requirements for the exam. And one thing that will help you is to, when you do this, is also get a subnet calculator from, you can get a free subnet calculator online. You can go to SolarWinds, and those subnet calculators will help you also to understand how many networks and how many hosts are in each one of these CIDR ranges. Notice that private IP Google access is set to true. This allows the cluster hosts, which have only private IP addresses, to communicate with Google APIs and services. Now at this point, the only IP addresses that have access to the master are the primary range of your subnetwork. That's the range used for the nodes, and the secondary range of your subnetwork that's used for the pods. If you want to provide additional access to the master, you have to authorize certain address ranges. Let's create a VM instance, a source instance that we'll use to check the connectivity to the Kubernetes clusters. gcloud compute instances create source-instance. I'm going to issue this command to get the external IP of the source instance. I can see the NAT IP is 35.238.78.250. I'm going to jot that down because I'm going to need it in a moment. Next, I want to authorize my external address range with the CIDR range of the external addresses from that previous output. So it's basically a NAT IP /32. So we're just basically whitelisting one specific address here, 35.238.78.250. Let me try that again with the /32 in there. Okay, I left off the /32. You got to have the CIDR prefix, and so that's why I got the error message. Okay, now that we have access to the master from this external address, we're going to install kubectl so we can use it to get information about our cluster. For example, we could verify that our nodes don't have any external IP addresses. So I'm going to secure shell into my instance. I'm going to install the kubectl component. Okay, all right, I got that error. Let's try this. Let's try sudo apt-get install kubectl. Okay, that worked. Yeah, if you get that error message, they're going to instruct you to use that command, sudo apt-get install kubectl. Okay, so next I'm going to issue this command to configure access to the Kubernetes cluster from the secure shell. And then let's verify that our cluster nodes do not have external IP addresses. With kubectl get nodes, output YAML, and then pipe it to grep -A4 and then addresses. Notice that the nodes all have internal IP addresses, but there are no external addresses. All right, let's exit out of here. And I'm going to finish up by deleting the Kubernetes cluster. There we go.
Lesson 11, Using GCP Deployment Manager. This lesson has two sub-lessons, Developing Deployment Manager Templates and Launching a Deployment Manager Template. Google Cloud Deployment Manager allows you to designate all of the resources necessary for your application in a declarative template using YAML. You can also use Python or Jinja 2 templates as well to parameterize the configuration and allow for the reuse of common deployments, such as load balancers, auto-scaled instance groups, or others. In this demonstration, we'll treat our configuration as code and create a repeatable deployment using Deployment Manager in the Cloud Shell.
Okay, let's go up to the navigation menu and click on that and go down towards the bottom. And we're going to see under Tools, we'll see the Deployment Manager, and then we'll click on Deployments. And this has two areas, the Deployments on the left and the Type Registry. Now, the Deployment Manager is a service for what we would call infrastructure as code, okay? It automates the creation, the generation, and management of Google Cloud platforms on your behalf. So it's a managed service where you can construct flexible template and configuration files and then take those and then roll out a variety of cloud platform services like Google Cloud Storage, Google Cloud SQL, Google Compute Engine, and they can actually be also configured to work together. Now, this is the graphical area where you come and you go to the marketplace. It tells us you don't have any deployments yet. You can use gCloud to create a deployment, or you can use Marketplace to deploy a prepackaged solution. We're not going to do the prepackaged solution. We're actually going to use gCloud to create a deployment. So let's go up and activate Cloud Shell, and we'll use Cloud Shell to create a configuration. Now, what a configuration does is it describes all the resources for a single deployment. Now, the configuration is written in YAML, Y-A-M-L syntax, and it's going to basically delineate or list out each of the resources that you have in your deployment. And a resource can be any resource type that's defined in the resource list. So before we do that, let's go take a look at the resource list. Okay, we're up at cloud.google.com and we're in deployment-manager/docs/configuration, and it's supported resource types. And basically it's telling us that the deployment manager uses the underlying APIs of each GCP service to deploy your resources. And the example they give is to create a Compute Engine VM instance, the deployment manager makes a call to the Compute Engine API on your behalf to generate the instance and then adds it to your deployment. It also mentions that you can use GCP type providers to create your resources. That is in beta right now, but down here it says the resources for project creation. Okay, so if you're creating projects in Deployment Manager, you can use the following virtual resource types to enable APIs in your project or modify the billing information. So you can see these two resource types, and it tells you what each one of these does. The first one enables a service API, and the second one modifies the billing information for the project. You can see an example in GitHub, and you can go look at documentation. Also, each API has its own documentation and API reference. And so down here you see a list, and you can see that the examples of these would also be in the Deployment Manager GitHub repository. And a lot of these resource types are obviously going to correspond to the many services and products of Google Cloud Platform, okay? And it tells us that as a Deployment Manager service continues to evolve, more resource types will become available. And you can see the current list by going and issuing this command. Well, let's do that. Let's click on this to copy, and let's go issue that command real quick. All right, there you go. So there's the full list, okay? G-Cloud Deployment Manager types list. I'm going to close this out. I started a new Cloud Shell. Remember, by the way, if you ever want to have multiple Cloud Shell windows open and you're doing this, let's say in the lab environment, you have to go up to this little terminal settings here, and you need to go to the tmux settings, and you have to disable this checkbox, enable tmux integration. That'll allow you to have multiple sessions by default, just in case that comes up again. Okay, so in the Cloud Shell command line, we're going to create a VM YAML file. We're going to do this in the text editor, nano. So we'll do nano, and we'll call this vm.yaml. And I'm going to go ahead and paste in the content. And of course, this comes from QuickLabs GSP 083. So I'm not going to write out this code myself. I got this from QuickLabs. And by the way, you don't have to actually pay for QuickLabs to actually see what's in the QuickLabs, okay? You can basically just log in with your Google account, your Gmail account, for example, and you can see the actual lab and the different processes and steps, and you can just copy and paste everything out of there and work in your own GCP environment, right? Okay, so I pasted this YAML script in here. The type is compute.v1 instance. The name is VM my first deployment. And again, I had to make sure that I put in there my GCP project ID in that URL. I had to do that in 2 different places. So basically, this simple configuration file describes a deployment that has 1 virtual machine instance. It's in UF Central 1F zone. It's an F1 micro machine type. It has a root persistent disk. The image is going to be Debian 9, and it'll have a randomly assigned external IP address. So I'm going to do Control X, and I'm going to save. Okay, I'm going to paste in this command, G-Cloud Deployment Manager deployments, create my first deployment, --config, and again it's VM YAML. That'll deploy the configuration. I'm going to pause while this spins up. Okay, great. We've spun up our first deployment, VM my first deployment. If I want to see information about the deployment, I'll issue G-Cloud Deployment-Manager deployments describe my first deployment. You can see it has an ID, it has an insert time, it has a name, my first deployment, and you can see the type is compute.v1.instance and the state is completed. Now, one key aspect about this is the manifest value, where we see right here, manifest dash and then a string of numbers. We'll need to use this to view the deployment manifest. Okay, so we'll paste that in there. A manifest is a read-only file that basically describes the deployment's resources in detail. Deployment Manager will generate the manifest and log any errors or warnings that happened during deployment. So that makes it a useful troubleshooting tool. So I went ahead and inserted my manifest timestamp in there. You can see right there, and we'll hit enter. And so there it is. There's the complete manifest of my infrastructure as code or deployment manager solution. There are a couple of other labs at QuickLabs you might want to do. There's create a Cloud SQL instance using Deployment Manager. That's going to be GSP 148. You might want to check out Deployment Manager for App Server. That's going to be GSP 057.
In this demonstration, we'll continue looking at the Deployment Manager. However, this time, we'll also create a VPC network along with firewall rules. And this time we'll use Jinja and YAML together. Sound good? Okay, let's dive in.
Okay, for this demonstration, I'm going to have the Cloud Shell command line down here. And then up here at the top, we'll have the Cloud Shell code editor. And we're going to create 3 template files, a network template, a subnetwork template, and a firewall template file. They'll be in Jinja format, and we're going to use these as the underlying code for our VPC network. So let's go up here and go to File, New File, and we're going to call this Network custom-template.jinja. I'm going to paste in this information. First we have resources, and we're going to have name and then type. We want to fill in the network resource type, so I'm going to go down here to the bottom. We want to run this familiar command, gcloud deployment-manager types list. And there's the list we saw in the previous sublesson, 11.1. Let's go ahead this time and take the list and let's pipe it to grep network so we can just see the network ones. We want compute.v1.network. So I'm going to copy that. I'm going to paste it up here where it says type, compute.v1.network. That's our network type. We also want to add a value down here to properties. Auto create subnetworks. We're going to set that to false. When we do that, the network will be in custom subnet mode. And let's go ahead and save the file. Let's create a template now for a subnetwork. So we'll go to File, New File, and we'll call this subnetwork template Jinja. We need some resources in here. Let's do the subnetwork resource type. Let's go back down here to the shell, and we're going to do the same command, but we're going to grep to subnetwork this time. And we want compute.v1.subnetwork. Paste that in here. We're going to add some properties. Get my tab key and clean these up a little bit. Okay, so IP CIDR range, network, and region. And we'll be using some variables in a little bit to fill in some of these values. But I'm going to go ahead and save this file now. And let's create a new one, a new template for our firewall. Firewall template.jinja. We need some resources in this template. We need to get the firewall resource type. So again, let's go down to the bottom. Issue that same command, but this time we're going to grep firewall, and we want compute.v1.firewall. Paste that in there. We want some properties, so we'll paste some properties in there. Network, source ranges, allowed protocol and ports. We'll save this. So now we have 3 template files, or 3 template Jinja files. Let's create the configuration file that's going to reference these 3 templates that we just created. This new file will be a YAML file. So let's go new file, and we'll call this config.yaml. We're going to import those 3 templates. Next, we'll add some resources. It's going to be called custom-net, and the type will be network template.jinja. Next, I'm going to add some properties for custom subnet, the type, IP CIDR range, network, and region. Notice in the subnetwork there's a reference to the custom-net resource right there. Okay, let's go and add some resource properties for firewall. So we can see we've got type firewall-template.jinja, network properties, and IP protocol TCP. All right, everything's looking pretty good, so I'm going to go up and save my file. Kind of cleaned it up a little bit there. Okay, we're going to use some environment variables now. So since we declared a name for the resources in config.yaml, we have to use the same name in the corresponding template file, and we'll do this by using an environment variable. So let's update first the network template file, and we'll use this variable for network name. Save that. Let's go to subnetwork and use that same variable for subnetwork name. So now these files will use the same name as the one used in the config.yaml configuration file. Remember to save that. Let's go to the firewall template file, and let's replace firewall name with this variable. Basically, we're appending -allow-http to the name of the firewall, so it'll be called custom-allow-http. So I'm going to add some more properties values to subnet. Let me first save that. So go to the subnetwork template. I need to fill in some values here. I'm going to paste those in, save that file, putting in some variables for IP CIDR range, for network, and for region. I also want to add some more variables to the firewall template. Paste those in there. Network, source ranges, allowed IP protocol, ports. Make sure I save the file. All right, now I'm ready to actually deploy my configuration. So let's use the gcloud command and issue gcloud deployment-manager deployments create. And again, it's called custom-net-deployment, and then --config. We're going to use the config.yaml file. And this will take a little bit of time, so I'm going to pause the video. Okay, excellent. So I have my custom-allowed-http firewall template. I have my custom-net network template and my custom-subnet subnetwork template. If I want to see my deployment, I can issue gcloud deployment-manager deployments describe custom-net-deployment, and there's my information. This is just like we saw in the previous lesson 11.1. Notice it has its own manifest number. Let's go ahead and test this out. I'm going to go back over here to the compute engine, VM instances, and I'm going to create an instance. We're going to use the template, okay? So we'll call this DM test instance, US Central 1 Iowa, 1 VPCU. Everything is good there. We do want to allow HTTP traffic so we can actually see the web page of this. Let's go down to the management security disks area and go down to management, and then under automation, we want to put a startup script, which is basically going to roll out Apache web server. So we'll paste that in there. And you can see it's sudo apt-get update, sudo apt-get install -y Apache 2, and then sudo service Apache 2 start. Click on the networking tab up here. And let's go to the network interfaces field, and we'll click on the little pencil there for network. We don't want to stick with the default. Remember, we have templates. So we have custom-net for the network template. We have custom-subnet, which is our subnetwork template. We'll stay with ephemeral automatic primary internal IP and ephemeral external IP, and we'll leave IP forwarding off. Click on done, and then create. And I'm going to pause again while this spins up. Okay, so it's ready. Notice I have an external IP address here, 35.193.73.19. I'm going to open that up into a new window, and hopefully, there we are. There's my Apache 2 Debian default web page of my Apache VM launched with the network, subnetwork, and firewall templates in Deployment Manager. Awesome.
Module 5, Ensuring Successful Operation of a Cloud Solution. The 3 lessons in this module cover monitoring and logging using the popular Stackdriver solution. We'll then return to the important Identity and Access Management IAM service with both predefined and custom roles configured in both the console and Google Cloud Shell. Lesson 12, Monitoring and Logging. We'll begin monitoring multiple projects with Stackdriver, followed by monitoring and logging for cloud functions, and then finishing up Kubernetes monitoring with Stackdriver. Stackdriver monitoring is a vital service to implement very soon after you begin your GCP adventure. In May 2014, the Stackdriver company was acquired by Google, and then an expanded version was rebranded as Google Stackdriver and launched for general availability in October 2016. Stackdriver provides dashboards and alerts for you to review performance metrics for cloud services, commonly GCP and AWS, virtual machines, and common open source servers such as MongoDB, Apache, Nginx, Elasticsearch, and much more. In this demo, we'll configure Stackdriver monitoring using the Stackdriver monitoring console. This demo is based on QuickLab GSP090, where I'll have two different projects to monitor in Stackdriver. I'll add them both to a newly created Stackdriver account and then monitor the metrics that the virtual machines in the two projects provide. So I'll enable Stackdriver monitoring, observe some concepts, and then finally navigate through the Stackdriver monitoring interface.
Okay, in this demo, I've got two projects. 8DEO is project 1, 9B89 is project 2. I just went into project 2 and I've spun up an instance. Okay, I didn't make you wait for all that. And now I've got instance 2 in project 2. This virtual machine, by the way, just accepted all of the defaults. What I want to do though is I want to enable Stackdriver monitoring. Now, my projects have to be in a Stackdriver account, and the Stackdriver account is separate from whatever account you created in Google Cloud Platform. So I'm going to go up to the menu or over to the menu, and we want to go down to the Stackdriver area. It has its own area, and then click on monitoring. I'm going to choose use another account and log in. They want me to create a workspace, so I want to do that. I also want to make sure that I add both projects to my workspace. So I'll click on the blue Create Workspace button, and I'll see two checkboxes for both the projects, Project 1 and Project 2. So I'll select both of those, click on Continue button, and it's adding the projects. The next thing it wants to know is, do I want to also monitor AWS accounts? And what's interesting about Stackdriver is that was the initial reason it was created, to do monitoring of AWS. Then Google bought it, and now Google offers this to their customers, and a lot of enterprise customers will use Stackdriver to monitor resources that they have at both AWS and Google Cloud Platform. Sometimes they do this for high availability and continuity of operations, disaster recovery planning, business continuity. Maybe they do this because they want to use Google Cloud Platform more for the dev stuff and use AWS for more of the ops stuff. It just depends, okay? But either way, I could go do this. I would create an IAM role at Amazon Web Services, assign that role and manage permissions to that role, and I could do that. But I'm not going to do that. I'm going to skip the AWS setup. I want to install the Stackdriver agent that's recommended, so click on Continue. You see the curl commands there, by the way, that are going to be run to do that. Next, it wants to know, do I want to get reports on performance of my cloud applications through email? I could do this and get daily reports, which includes weekly summaries. I could get weekly reports, but I'm going to say no reports. This is just a demonstration. And I'm going to click on Launch Monitoring button. The first thing I'm going to do now, there's a bunch of stuff here on this panel, okay? You know, you can monitor uptime, set alert policies, create a dashboard. We're going to do all three of those things, okay? You can do groups, okay? Stackdriver will allow you to define and set up groups of resources, like groups of databases, groups of VM instances, groups of load balancers. And you can name these groups, you can base these groups on different things, okay? But we're going to go ahead and go over to groups on the left-hand side, click on groups, and we're going to create a group. We're going to call this group Demo Group. Notice that the filter match is going to be, you know, any or all, okay? So kind of a Boolean and or a Boolean or. We're going to say any. So based on the filter criteria that we configure here, Stackdriver is going to dynamically determine which resources belong to the group. So you can see you can do name, you can do tag, you can do security group, you can do cloud account or project or region. We're going to choose name. And we're going to say the name contains, of other options here, does not contain, equals, does not equal, starts with, and ends with, okay? So we're going to say name contains instance, because our instances are instance 1 and instance 2, so that's part of both of ours. And of course, we could add more criteria here if we wanted to. I'm just going to click on Save Group. We want to do an uptime check, okay? I don't have any uptime checks by default. These will let me quickly get a handle on the health of any of my web pages, my groups of resources, any instances, okay? And then each configured check will be contacted regularly from different locations around the world. And these can be used as conditions in an alerting policy. But before we can alert, we have to create an uptime check. So I'll click on the Create button. I'm going to title this Demo Group Uptime Check. And the check type we're going to do is going to be TCP. You see our options there. The resource is going to be instance resource, not load balancer. It's going to apply to the demo group. It's going to be on port 22, secure shell. And we're going to check every 1 minute. And then we'll click on the test button just to make sure that it's going to work. And we'll do a testing check, and that's good. So we'll click on Save. Now, after we have our uptime check, we can create a alerting policy. We could say no thanks, okay, but we want an alerting policy, which allows us to be notified via email, SMS, or any other notification option when our check is unresponsive. I'm going to click on that recommended uptime health check on demo group uptime check. So it's targeting all resources. Here's my uptime check ID. The condition triggers if at any time series violates above 1 minute. That's fine. So I'll go down here and click on Save. So I could add more conditions, but it's pulled in the metadata for me. I could also do notifications. I could go in here and add my personal email. And if you were going to do this on your own, you might want to actually go in there and add a webmail and go ahead and get the alert, get the email to see what it looks like. I'm going to enter a policy name. We'll call this Uptime Check Policy and click on Save. I could also create a custom dashboard. So I'm going to go over here to the left-hand side to Dashboards and create a dashboard. I'll just call this Dashboard Uptime. Add a chart and start typing uptime in here, and I should see the uptime from the offered metrics. So the resource type is GCE VM instance, metric is uptime, and I'm not going to go into the other options here. You can do that, of course, when you want to on your own. But I'm going to go to the bottom and click on Save. So I need to cause a problem. So I'll go back to the Google Cloud Console. And I can see instance 2. Let's go ahead and stop this instance. Stop it. And I'm going to go ahead and pause the video recording because it'll take a few minutes for this to actually stop. What we're doing is we're creating a uptime event. So I'm going to pause. So hopefully this is going to work. Let's go back to the dashboard. I'm going to go to Monitoring Overview here. And I'm hoping to see an incident. Let me refresh that. No checks have run yet. That's not a good sign. So it's not working like it should, but that's okay. The bottom line is, what would happen in a normal situation, in a real world situation that wasn't a lab environment, is that you would see an open incident here. So you could use this monitoring overview, or you could go to your custom dashboard that you created, the uptime dashboard. And what it would normally you would see is you would see the instance actually coming down here. So the bottom line is, just make sure for the exam you're familiar with the process of adding your account or your accounts to Stackdriver monitoring. You can see the 3 main areas that we looked at, monitoring your uptime, setting an alert policies, and creating a dashboard. All 3 of those things were done. Whether or not the lab environment, is cooperative, we have no control over that. But normally you would see something in the incidents area, or you could go back and you could try to create a new policy and see if that would work. Anyway, when you have a chance, maybe you can go on your own, go up to Quick Labs, and you can do GSP 090. Maybe you'll have more success getting some response than I did. But make sure you do that, or make sure you watch this video and be aware of this information, because you will be tested on this on the exam.
Stackdriver can also be used to monitor and log your Cloud Functions activity on data such as execution times, execution counts, and memory usage of your functions. In this demo, We'll set up custom monitoring and log these metrics in Stackdriver Monitoring. We'll even use a regular expression to create a custom metric and then view it in a dashboard. Okay, we did set up Stackdriver. We set up a workspace in the previous lesson or sub-lesson 12.1, but it never really hurts to reinforce that. So let's do it again. Let's go to the navigation menu and let's scroll on down to the monitoring area and click on monitoring. Okay, we'll click on create workspace. We'll dismiss that alert. Click on continue. We're going to skip the AWS setup. If we were going to do this, we had to create a role in Amazon Web Services, and then we would do it that way, but we're going to skip that. Click continue, no reports, and then continue again. When we click on launch monitoring, it's going to show us our Stackdriver account dashboard. And again, the goal of this particular demonstration is to view Cloud Function logs and Cloud Function metrics. So we're going to generate that ever familiar Hello World Cloud Function. So let's go back over to the navigation menu, go to Cloud Functions, and create a function. We'll call this Quick Labs Demo. And this is 092, so it's GSP 092 in case you want to do this one yourself. We'll stick with the allocation of 256 megabytes. We'll have our trigger be HTTP as opposed to one of these other many ways to trigger the function. Come on down to the index.js file. I'm going to grab some code and replace it. Place in there the Cloud Function Hello World function to execute. I actually need to change this back to Quick Labs Demo so it matches up what's in the code. So we're going to execute the Quick Labs Demo function and click on Create. Okay, well, I've got the green check mark. That's what I'm looking for. So I'm going to go to the Cloud Shell, which I opened up in the background while that was spinning up. And I'm going to paste some code in here. And this is going to basically get a tool called Vegeta, V-E-G-E-T-A. That'll allow me to send some test traffic to the Cloud Function. Let's run this tar command so we can unpack this Vegeta tool. Go back to the console. Let's click on the name of our function. And we're looking for a trigger tab. Click on that. Click on the URL. Hello world. Okay, so we got our code up and running. Let's send some traffic to our Cloud Function. Back in the Cloud Shell, we'll use echo. Next, we're going to create a distribution type logs-based metric using a regular expression that extracts the value of latency from the log entry's text payload field. Let's get back to the navigation menu and go down to logging. Go to the log screen. If you want to see just the logs from the Cloud Function, then in the first drop down here, we want to choose Cloud Function. We can also filter where it says all logs. We could say let's filter by cloudfunctions.googleappies.com cloud-functions. Say OK. We can filter those out. Let's go to the top of the screen and create a metric. Click on the Create Metric button. We'll name this Cloud Function Latency -logs. We want the type to be distribution. For the field name, we want text payload. And then we notice we have an extraction regular expression. We can build it. Here we've got a builder. So we're going to put in this execution took open parentheses, whack, D plus, close parentheses, and then click Done. Double checking my metric editor, looking good, so I'm going to click on Create Metric. I should now see the log-based metrics area, and I can see the system metrics that are up here. Billing per bytes ingested, billing per monthly bytes ingested, byte count, log entry count, and then user-defined metrics at the bottom, and there's my metric. Let's go back to Stackdriver
and go over to Resources and Metrics Explorer. We'll take a look at the data for our cloud function. Let's start by typing execution, and then we'll choose executions from the list. Let's change from a line to a stacked bar, and there we go, execution count. We can try a different metric. We can get rid of executions and do execution times. We're getting a heat map view, but we can change that to something else, like a stacked bar or a stacked area. I think stacked bar is working pretty good. We can also, change some aggregation down here. So for example, change it to the 95th percentile. All right, so looking at some logs, looking at some metrics, let's create a custom dashboard. Let's go to dashboards. Let's name this results, and we'll add a chart. So we'll get executions again. Notice this, naming it executions, okay? And we can go and we can add another one and make it execution times, whatever we want to do. Okay, so logs, metrics, dashboards. Make sure you're familiar with these three elements before you take the Google Associate Engineer exam.
This demonstration is based on QuickLab GSP 243. I'll show you some unique features of monitoring your Kubernetes application by integrating metrics, logs, events, and metadata in Stackdriver Kubernetes monitoring. Let's check it out.
Okay, we have to have a demonstration app or a demo app. It's going to be called the Pet Clinic Demo app. So it'll be one that's already kind of pre-cooked for us. So we're going to use Cloud Shell to generate a Kubernetes cluster so we can deploy the Pet Clinic app. So the first thing I have to do is create a project ID variable. So I'm going to replace the actual project ID, which you can see here, okay, and then create this variable. So let's go ahead and do that. Then I need to enable the necessary APIs. G-Cloud Services Enable. You can see we've got a compute, container, spanner, and cloud profiler APIs. One thing I want to mention to you as we go through and as we've gone through so many different Cloud Shell code samples and different commands, it's not necessary for you to memorize, a lot of the steps that we've gone through, but the basic fundamental commands, okay? So for example, G-Cloud Services Enable, those fundamental commands are important to remember. So for example, if we're going to clone a API or an app, remember it's get and then clone and then the URL to where that API is. In this case, spring-petclinic-gcp. So it's those fundamental commands that are important. Next, we're going to create a container cluster. We're going to get a bunch of warnings, but we don't care about that. We're using the command gcloud beta container clusters create, and then it's Pet Clinic with some variables like the cluster version, the region being US Central 1. They're going to be type N1 standard 2. There'll be auto repair turned on, and we're also enabling Stackdriver for Kubernetes. I'm going to go ahead and pause, and we'll take this up after we get spun up. Okay, so the cluster is being health checked. The master is healthy. And in a few more seconds, we see Pet Clinic in US Central 1. We've got the master IP, the machine type, the node version, 6 nodes actually here, and it's running. Next, we need to set up a namespace for the Stackdriver agents. Okay, we enabled Stackdriver for Kubernetes up here. So we need to create a namespace for that. We're also going to have our role-based access control. So we'll have AS equals admin and AS groups or system masters. We need that authorization. Next, we'll set the project ID. We've already got that variable created. Kube control, create, config map. Next, we'll set up the cluster name and location with kube control, create, config map again, but this time, instead of Google Cloud Config, like we see here, we're going to set up the cluster name and location with cluster config. Our config map cluster-config is created. Let's set up our agents with a YAML file. Kube control apply-f. There's the location of the agents.yaml file. And let's verify that our pods are running. With kube control get pods. They aren't all running. Okay, some of them have a status of container creating, and so we need to kind of wait for all of those to be running. While that's going on, in the background, let's install the Stackdriver Prometheus collector, which can collect metrics into the Stackdriver Kubernetes monitoring. So we'll do kube control apply-f and then the location of the rbac-setup file. Next, we're going to run this script, curl-s. We need to install the basic Istio. Paste this in here to install Istio. Istio is going to allow us to intelligently control the flow of traffic and API calls between services. You can do testing, you can do upgrades. It automatically secures your services through managed authentication and authorization. It applies policies. It allows you to see what's happening with rich automatic tracing, monitoring, and logging of your services. So we're going to install that tool. We next need a Cloud Spanner database. This will take a couple of minutes. So gcloud spanner instances create. And I'll go ahead and pause while this is happening. Okay, so we have our Spanner database. Next, we need to create a new service account. And it's critical on the exam that you're familiar with the commands to do this. Okay, so gcloud iam service-accounts create. This will be called Pet Clinic, and the display name of the service account is Pet Clinic Service Account. Very important that you know how to do this. Now, in the next lesson, which is actually the final sub-lesson of this course, we're going to start looking at identity and access management a little bit more in detail. But I'm going to go ahead and run the following commands in gcloud to actually grant IAM roles to this service account. And as you know, these are actually the permissions that this service account is going to have. So quite a few permissions there because we're doing a lot of different services. Next, we're going to generate a new JSON service account key, which in the real world, you would make sure you keep that secure. gcloud iam service accounts key create. And I want to copy and paste this key. And then finally, we're going to store the service account as a Kubernetes secret. So we have a secret called Pet Clinic-credentials created. Okay, so we want to deploy the Pet Clinic demo app now. So we need to change directories. I'm going to CD over into the Spring Pet Clinic-GCP directory and use kube control apply-f to deploy the demo on Kubernetes. Okay, let's go take a look at the set of microservices that make up our web store application. So I'm going to go over here to the navigation menu, go to Kubernetes Engine. Let's take a look at workloads. And I'm still waiting on, let me refresh this, but I'm still waiting on, and if you're doing this yourself, for example, if you decide to do QuickLabs GSP 243, which is what this is, GSP 243, when you go to the workloads area, you have to make sure that you have check marks on all of these areas before you proceed. Okay, so I'm going to pause the video and kind of wait for this to cook. And once I see, the green OK status for all of these services, then I'll be ready to move forward. Okay, it took a few minutes, but now I've got status OK for all of my different services. So I need to get an ingress IP address so I can actually view the application. So I need an endpoint. Let's go back over to the Cloud Shell. And I went back to this root directory, and we'll do kube control get ingress. And there's my IP address, so I'm going to document that. So let's go to a new browser window. Put that in there. And it's not secure, but there's my Welcome to Pet Clinic app. So let's add some new pet owners and pets, just like we would if we're an employee. So we'll click on the owners drop down here, and we'll register. Okay. To add a pet, now we'll go click on Addy Ash and we'll add a new pet. It's not a lizard, not a snake or a bird or a hamster. Laddie is a dog, and we'll submit that. Okay, so now we've made some changes. Let's go ahead and monitor this app. Now, what I need to do next is I need to create a Stackdriver workspace. But I've already created a Stackdriver workspace in this training several times, so I'm not going to record that process, okay? I'm going to go ahead and create the Stackdriver workspace, and then we'll just mess around with that. Welcome to Stackdriver Monitoring. Now, to monitor a Kubernetes application, we want to go over here to Resources on the left-hand side, and we want to choose Kubernetes, and it'll say Beta next to it. And you should see the Pet Clinic cluster as we do here. Here we see Kubernetes components like clusters, deployments, services, pods. We're on the Infrastructure tab right now, and you can expand this out with this little arrow there. You can see the 6 nodes, as well as any incidents and any CPU utilization and memory utilization. The Workloads tab and the Services tab has the Kubernetes services. So make sure you're aware of this resources area for Kubernetes in Stackdriver. You may want to also dive into creating an alert policy. We've already done that before, but if you want to create a policy for alerting for Kubernetes, you would just go up to alerting and say create a policy. And you could add a condition. So for example, maybe if a container is consuming 85% of the CPU limit over 1 minute, you want to get a notification. So you basically would just click on add condition. I can give this a title. Notice up here we've got metric, we have uptime check, we have process health, okay? So be aware of that. Under target, if it is something like CPU limit utilization, I could just start to type that in there, CPU, and you can see request utilization, usage. Here's limit utilization, for example. Then you could go back, you could say, you know, condition the trigger if any time series violates or all time series violates the condition if above 0.8 is 80% or 0.85 is 85% over a 1 minute time, and then save that. And make sure that if you don't have a chance to do this demo in QuickLabs, that you go into your own account, and you can also follow through and use all the code that I pasted in. You can just go pay for a few hours of QuickLabs, and then you can just use that and log in, and you can see all the scripts. Okay, you can have access to all of the walkthroughs, and you can do it yourself in your own account.
Lesson 13, Managing Identity and Access Management, IAM. We'll begin assigning IAM roles to accounts in Google Groups. Then we'll define custom IAM roles, and then finish up configuring roles in the console. When it comes to Google Cloud's Identity and Access Management IAM service, well, this is not our first rodeo. Even though we're going to officially look at IAM in the next 3 lessons, we've already used IAM a number of times throughout this training. It's actually pretty much unavoidable, in fact. So in this lesson 13.1, we'll sign in with 2 different sets of credentials and look at how granting and revoking permission functions with different roles. I'm basing this on QuickLab GSP 064 if you want to do this yourself, and I highly recommend that you do. Google Cloud IAM gives you the ability to create customized Cloud IAM roles, and this is really to have a specialized approach to the principle of least privilege, okay? So you can make sure that users and service accounts in your organization only have the abilities or the permissions that they need to do exactly their intended function or their intended role, and nothing beyond that, okay? If they do need to go beyond that role, then you can use some type of ticket system or service desk to, on an ad hoc basis, give them those permissions.
Now, realize you can create a custom role at the organization level and, as we're going to do here, at the project level. However, you cannot create custom roles at the folder level. And we basically create a custom role by just combining one or more of the available Cloud IAM permissions. And the permissions come in the form of service.resource.verb. For instance, compute, which is the service, and instances, which is the resource, and list is the verb, allows a user to list the Google Compute Engine instances that they own. If you give them compute.instances.stop, that allows the user to stop a virtual machine. And we're going to see a lot of these in this lesson. Now also realize that custom roles can only be used to grant permissions and policies for the same project or organization that owns the roles or the resources under them. You can't grant custom roles from one project or organization on a resource owned by a different project or organization. And to create a custom role, which we're going to be doing, you must have the iam.roles.create permission. Before you create a custom role, you might want to know what permissions can actually be applied to a resource. You can find this out using the gcloud tool. You can use the Cloud Console, or you could use the IAM API. So let's go up and use the Cloud Shell, activate that, go to full screen. I'm going to paste in this command, gcloud IAM list testable permissions. And I've got a variable there, dev shell project ID. It's a huge list, okay? And it's just going to keep putting out output for all these different services. And within all these different services, you have tons of different resources. And within those different resources, you have verbs, okay? Like stop and get and list and reimage and reset, okay? You can see those here. You also might want to get the metadata for both a predefined and a custom role. Role metadata includes the role ID and permissions contained in the role. So let's say we're going to do gcloud IAM roles. We want to describe, let's say we want to describe roles /viewer. See the metadata. There it is, okay? You can see what the viewer can do in all these different services, okay? Like Firebase, logging, machine learning, monitoring. And then the second element is the resource in that service. For example, Redis.locations, Redis.instances, and then the verb. So viewer, you see a lot of list, you see a lot of get, okay? Another command to be aware of is going to be gcloud IAM list grantable roles. This will return a list of all the roles that can be applied to a given resource. So for example, if I put in here the grantable roles from my project, it's going to show them. Description, for example, read access to GCS objects. Okay, the name would be roles, and then storage object viewer, and the title storage object viewer. Now there's several ways to create a custom role. You can do it in a YAML file. So you just kind of create the YAML file, let's say in Nano, and then you offer that YAML file that has the role definition. Or you could do it the old-fashioned way, which is really the way you've probably seen it the most throughout this training. And that's using flags like -- organization -- project, okay? Various different flags. So let's go ahead and create a custom role using a YAML file. By the way, here's how we structure the YAML file. First, you have the title. So the role title would be something like role viewer. Then a description, which would be a kind of a short, friendly description, like this is my custom role description. And then the stage, the launch stage, would be an indicator of the stage of a role in the launch lifecycle, like it's the alpha, it's the first version, or it's the beta version, right? And then you have your included permissions, okay? Included permission 1, included permission 2. So this specifies the list of one or more permissions that you include in the custom roles. For example, IAM the service dot roles the resource dot get the verb, okay? IAM.roles.get. Okay, so let's create a role by running Nano. So role definition.yaml. I'm just going to paste that in there. Okay, so the title is Role Editor. The description is Edit Access for App Versions. This is the alpha stage, and you can see the two included permissions. They're both from the App Engine service. They're both the versions resource, and one is a create verb and the other is a delete verb. I'm going to save that. Okay, let's go ahead now and execute this gcloud command. Gcloud IAM roles create editor, and then -- project, which is my project. You can see there's the YAML file, -- file, role - definition.yaml. And there it is. You can see our two included permissions. All right, now let's use the custom flag method to create a new role. And this is the gcloud IAM roles create viewer, and then -- project. This is the one that you saw most often throughout this training course when roles were being created on the fly for various projects and various activities. Let's list out the custom roles with gcloud IAM roles list, followed by my project, and there they are. All right, let's update a custom role using a YAML file. So let's first get the current definition of, let's say, editor. Let's create a new YAML file with the output from this command. So we'll start with description, grab all that, copy it. So we'll do nano new role definition .yaml, and we'll just paste that in there. And let's add two permissions under included permissions. storage.buckets.get and storage.buckets.list. We'll save that. Okay, let's use the update command to update the role. Paste that in there, gcloud IAM roles update editor. And again, the file, notice -- file is new role definition.yaml. We could also update a custom role using flags. I think for the sake of time, we're just going to go ahead and bypass that. You can do that yourself if you want to go and do a GSP 190. You can go through and do all of this in Quick Labs in GSP 190. And it'll also show you at the very end how to disable the role, which is basically just putting in gcloud IAM roles update and then having disabled at the end of the command, which I'm not going to do. But if I wanted to delete a custom role, I would do gcloud IAM roles delete viewer. So enter that to delete it, and realize that after the role's been deleted, there are bindings that remained, but they're inactive. So the role can still be undeleted within 7 days. Okay, so I can undelete the role by doing gcloud IAM roles undelete viewer within 7 days. There we go. After 7 days, the role goes into a permanent deletion process that lasts 30 days. After 37 days, the role ID will be available and can be used again. All right.
When it comes to Google Cloud's Identity and Access Management IAM service, well, this is not our first rodeo. Even though we're going to officially look at IAM in the next 3 lessons, we've already used IAM a number of times throughout this training. It's actually pretty much unavoidable, in fact. Custom roles are user-defined identities that let you bundle together one or more supported permissions to meet certain security needs. In this demo, I'll show you how to create, update, delete, and undelete custom roles.
Okay, when you do this at Quick Labs, let me just show you, you're going to have 2 users. Okay, so you're going to have username 1 and username 2. They'll both have the same password. They're both under the same project ID. So right now I've logged into the console as username 1. I'm going to go up to navigation menu and go down to IAM and admin, and we'll choose IAM. As you can see, there's a bunch of members in here already, quite a few. I'm going to click on add at the top, and notice under select a role, I've got project, Android management, app engine. As I move over these, auto machine learning, I'm going to see on the right hand side different roles or permission sets. Now if I go back to project up here, we see browser, editor, owner, and viewer. These are referred to as the primitive roles in Google Cloud Platform. You have to know that for the exam. Primitive roles set project level permissions, and unless you designate otherwise, they control access and management to all GCP services. Browser gives you read access to browse the hierarchy for a project, including the folder, organization, and Cloud IAM policy. This role does not include permission to view resources in the project. Project Editor has all viewer permissions, plus permissions for actions that modify the state, such as changing existing resources. Owner has all editor permissions and permissions to manage roles and permissions for a project and all resources within the project, as well as set up billing for a project. This is obviously the highest privilege level. And then Viewer basically has read-only permissions that do not affect the state, but things like viewing but not modifying existing resources or data. Now, we were able to manage roles and permissions for this project. So obviously username 1 has project owner permissions. Okay, so I'm going to cancel out of here. Let's switch over to the username 2 console. Let's do the same thing. Go up to the navigation menu, choose I am an admin, and then I am. So if we look down here, we'll notice that this user 5290_student, this is username 1. And then this user right here, which is username 2 that I just logged in with, 1845, notice that this particular user just has the viewer role, whereas student 1 basically has App Engine admin, BigQuery admin, and then editor, owner, and viewer roles. Notice at the top, I don't have the ability to add a user. So just a simple example of how IAM roles will affect what you can do and what you can't do in Google Cloud Platform. I'm going to switch over to username 1. Just go up to the tab here. Notice in username 1, I have the add button again. Let's create a GCS bucket. So we'll go to the navigation menu and go to storage and choose browser. Create a bucket. Call it user1bkt. It's multi-regional, and we'll go to the bottom and click on create. Let's upload a file. Just get my band picture, bandpic.jpg. Let's go to the 3 dots down here at the end and rename. Let's just call this sample.txt. Let's go back to username 2 now and go to storage, browser. Notice we can see the bucket, user1bkt. So username 2 has the viewer role given to them, which allows them read-only actions, but they can't affect the state. Okay, so they can view cloud storage buckets, and they can see the files that are hosted in the GCP project they've been given access to. Let's go back over to username 1. So let's go back up to IAM and admin in the IAM area. Let's go down to username 2, which is 1845 here, and let's click on this little pencil where you would edit. And if you want to remove, let's say project viewer access, this little trash can right here, we'll do that, and then we'll save it. Notice, by the way, that that user is no longer on the list. So the user has no access. Now it can take up to 1.5 minutes for these changes to propagate, so keep that in mind. Go back over here, navigation menu, storage, browser. That's what we want to see. You don't have the permission to view the storage browser or storage setting pages in this project. All right, just a quick view at different permissions and roles and their effect on users in identity and access management.
In this final demonstration of this training course, let's see how easy it is to work with roles in the Google Cloud Console graphical interface.
Well, as we learned in the previous 2 lessons, and really as we've learned throughout this entire training, Cloud IAM, or Identity and Access Management, gives us the tools we need to actually manage resource permissions. And again, we don't directly grant permissions to users, but we grant them roles which bundle one or more permissions. And don't forget, if you're dealing with Amazon Web Services and Google Cloud Platform, roles are really a different thing in Amazon Web Services, okay? In Google, roles are the equivalent of AWS managed permissions. For the exam, don't forget there's two types of roles. There's predefined roles, which are created and maintained by Google. They're automatically updated on the back end. So if there's a new feature, there's a new service, there's a new resource, there's a new action or verb, then it's automatically added to Google Cloud Platform. And then there's custom roles. And we saw in the previous lesson, we use the Cloud Shell to examine the roles, create roles, change roles, and delete roles. But I wanted to finish up here in this final lesson of this series by reminding you that you can, of course, go up to the navigation menu and go to I am an admin, and you can go to the roles area here. Okay, so again, this is where we can come and we can deal with our roles in a graphical interface. Okay, if you want to learn more about roles beyond what I've taught you in these 3 lessons, you can obviously click on this link and it'll open up a new tab, and you can go to Google and you can go through and you can deal with this. You may want to come here, for example, this won't be on the exam, but there is a Cloud IAM API. I mentioned that, by the way, in the previous lesson. You may want to go, if you're a programmer or developer, and look into the Cloud IAM API. Also, it wouldn't hurt to go look at the Cloud IAM Service Account Credentials API. These 2 different areas for developers and programmers. Now, that being said, when we come in here, we're going to see a huge long list of the predefined roles of Google Cloud Platform, right? And you can see that there's 352 rows. So that would be different types of roles. For example, BigQuery user, if I select BigQuery user, you can see a description, okay? Access to run queries and create data sets. The identification of this is roles /BigQuery.user, and you can see that right now it has 13 assigned permissions. So for example, as I've mentioned already, BigQuery is the service, config is the resource, get is the verb or the action. One thing I didn't mention in the previous sub-lesson was the ability, and we could have done this in YAML, we could have done this with feature flags as well, but to create a new role from a selection. So basically what you're doing is you're cloning a role. So if I want to create my own kind of least privilege methodology, and I want to have a special user that has some of the permissions of BigQuery user, but not all 13, or maybe I want to add a couple of things to the BigQuery data viewer, okay? I want to give them one extra permission, I could choose create a role from the selection, right? So you can see this is called custom BigQuery data viewer, even though I could obviously give it my own name. It has a description of when it was created. This is the ID that is assigned to it. And we talked about this in the previous sub-lesson, but one of the components of a role is the role launch stage. And I think we actually did this as alpha. So you've got alpha, you've got beta. You can have general availability, so it doesn't really matter, or you can disable the actual role right here under launch stage. So I showed you the way to do that programmatically to disable it using the gcloud. However, this is where you would disable it by coming to the role launch stage. So keep that in mind for the exam. So I can take away some of the assigned permissions that come with this BigQuery data viewer if I want to create my own least privilege approach, or I could go and I could add permissions, right, to this particular custom role. Some of these are not applicable, but you'd want to go and you'd want to find the ones that would be applicable, okay? So you can see some of these are supported, some of these are not applicable, okay? And then you would just add to that, make a custom role. So I'm going to go back. So that's actually probably the best approach. Okay, if you're going to create a custom role, you could go and you could create a role, and you could do it, just customized, right, from scratch, where you would go and you say, look, I have no assigned permissions. I'm going to add permissions, and that's something you could do, but you'd have to have a really good understanding of the resources, the types of users, the actions they're going to take, the permissions they're going to need. I would highly recommend, rather than creating a role, and this is really what would be recommended to you if you were on Amazon Web Services or Microsoft Azure or IBM Cloud. Their IAM methodology, their best practices are always going to ask you to really to come in and take an existing role, or in AWS an existing managed permission, and take that, for example, project browser, take that and then modify it as a custom role or a custom permission set. Because here's the deal. These assigned permissions, Google Cloud, they're experts, okay? They're experts at knowing exactly the best permissions for each resource and the actions. They have a really good idea of the best practice and the best approach for identity and access management, okay? So we can leverage their expertise. We can leverage their experience in dealing with IAM, and we can create our own custom permission or our own custom role based on their pre-existing set. And so that's highly recommended that you take that approach, as opposed to just going in and creating a role from scratch, okay? Even though you do have the ability to do that. So that's the roles area, and of course, as we finish out here at the top is the overall IAM area. Either way, whether you go to IAM or you go down to roles, it's going to bring you pretty much into the kind of similar area. Okay, so you can see all the members I have in my existing project, and then clicking on roles here is going to show you the roles that are being used in my first project, for example. All right, so that kind of wraps that up. Again, if you want to use the graphical console, it's a really excellent tool for working with roles. One last thing I want to show you before we wrap up here is you can see Manage Resources. And if I click on my first project, I can see this info panel over here, which will show us, the permissions, 2 owner members, 3 editor members, okay, then other services as well. For example, there's 1 member in the Compute Engine Service Agent. There's 1 member of the Firebase rule system. I can tell you that these 1 members are basically the billing account, okay, when I created this. So don't forget about this Manage Resources area as well, where you can create new projects, you can delete projects, and you can also get permissions and labels for your individual projects.
Well, congratulations on completing the Google Certified Cloud Associate Engineer from Pearson. In this course, you gained a ton of knowledge about foundational concepts and core service configuration on the Google Cloud Platform. You are also well prepared for the Certified Associate Engineer exam, which will then be your launching point to other higher-level GCP certifications, like Professional Cloud Architect and Professional Cloud Network Engineer. If this is your first time through the course, I really want to recommend that you go through it again, at least the areas that you feel are not your strengths from an experience standpoint. Hopefully, you enjoyed watching this training as much as I enjoyed producing it. On behalf of the entire Pearson team, I want to wish you success with your technology journey, your cloud IT career, and your life in general. Take care.